Is Felipe actually here right now in the stands? Oh, boom. I've been looking right here. We are ready. All right, so ladies and gentlemen, welcome to the Chisel stage for day 2 of Modular Summit. We're going to be having a wonderful day of programming all the way through 7 p.m. today on Metagame at Modular Summit, and it's great to hand the mic over to Felipe from Celestia, who will kick things off. Sorry, Cartesi. My apologies. And clicker here.
All right. Is it? How do I pass slides? Just oh. All right. So this it's an impromptu talk. I found out that I was gonna do this very recently, so please bear with me. The idea is to talk a little bit about the user journey. User in this case meaning developer, and specifically when choosing the execution layer that's gonna host their app. So I'm gonna explore a little bit about the design trade-offs on execution layers. So the point of this talk is to convince you of 2 things. First one is that execution layers have a very big design space, and that is a shame to explore app chains, for instance, without also exploring the design space of execution environments. And the second thing is that execution environments are very context dependent. So it depends on what kind of app you want to build, what kind of application, what kind of user experience, and so on. A little bit about myself. I'm this guy. I'm a co-founder, and I led the first roll-ups implementation at Cartesi. I'm Brazilian, but I'm very bad at soccer, and I'm also very bad at designing slideshows. I'm always down to chat. I like to talk a lot, so please reach out. I have a Farcaster and an X account, and there's a link to the Cartesi development community. It's kind of fun because we do every development and research in public, so you can see all the conversations live. Quite interesting. There's a lot to learn there. So let's start. So this is the Modular Summit, so I guess I'll skip a little bit this slide. But that's the common accepted view of the modular stack. So you have execution, settlement, consensus, data availability, and also a meme layer down there that's very important. The definitions change often. There's a bunch of new modular layers being added basically every day, added and subtracted. So at first sight, the execution layer looks very simple, right? Just you got an input, you execute on it, and you have an output, right? Usually you have a state, you add an input, and you get a new state, and the outputs can be embedded on that state. So it's quite simple. The problem that you have is that the execution layer has interplay with a lot of other layers, right? So this is a good example to show the interplay between computational capacity and data availability capacity is what we call the cone of innovation. And it's just an intuition. It's not to be taken as gospel, but it's the idea that as the computational capacity grows and the data availability capacity grows, you have an extended design space for applications, right? So if you take, like, let's say, Ethereum L1, which you have limited, without EIP 4844, you have limited data and you have limited computation, so there's only so much that you can do as an application developer. Once you start to go to, like, say, EVM rollups, you start to increase the computational capacity, and you start to be able to do way more than just in a sense, gentrified DeFi. And then have app chain rollups, which is a trade-off between interoperability and computational capacity, and then you start to be able to do much more fun things as well. So here we have areas without any application, and that's to show the intuition that it doesn't really matter if you expand one of the axes a lot without touching on the other one, right? In other words, if you have 10 gigabytes of data availability, but you have the computational capacity of one calculator, then there's not really much you can do with that. So that's why you have some areas without applications. All right. So what should you consider about your execution environment when you are thinking about developing an app? And just as a quick reminder, the dApp lives in the execution environment. So in a sense, the developer's final experience is the execution environment. So that's why it's very important to choose it well. So the first thing is a little bit obvious. It's the kind of dApp that you want to build. So what kind of dApp are you optimizing for? Are you trying to do DeFi? Are you doing games, social fi, governance, and so on? How intense how much computation will your dApp need? Is it a super simple dApp? Or are you trying to build something complex with a lot of computation, right? So what's the preferred programming language? Are you okay with coding Solidity, Cairo? Do you want to use Python, Rust, or any other language? You see, there's a long list of things that you need to consider before locking yourself into an execution environment. So for instance, you have developer resources. What resources will you want to use when coding your dApps? Do you need a file system? Or are you okay with just like storage and call data? Do you have latency tolerance? Do you need instant composability, instant interoperability? Or are you okay with having latency outside your dApp domain, right? So if you're, say, interacting with Uniswap, you probably need instant composability. If you're ERC20, you need instant composability. If you're an order book exchange, then very likely you don't really need instant composability. You can deal with asynchronicity a little bit more. Is your app shared or isolated, right? Is your execution environment supporting a single dApp, or is it supporting multiple dApps at the same time? So if you think about Ethereum and AVM was built to support multiple dApps at the same time, and it takes the trade-offs necessary for that to happen. That's why when we talk about alt VMs, there's some people that criticize EVM a lot, and I'm not on that camp, because I do believe that EVM is quite useful for a lot of things. All right, so please don't get bored. There's a proving system. Like, are all the choices that you made regarding your execution environment, are they gonna catch up to you when you try to prove it to the base layer, right? Because it's very easy to promise a very incredible execution environment, and then you'll find out that it's very hard to prove, right? What's the financial model? For instance, if you have a shared layer like an EVM rollup, then your application doesn't need necessarily to sustain itself, because you can just launch it, and it's gonna live on that layer forever. You don't need to constantly pay the upkeep price of the infrastructure. An app chain, on the other hand, has to justify itself financially. Because if you launch an app chain and no one is using that, then who is running the nodes, right? Who is paying to run the nodes? How important is privacy? Do you need privacy for inputs or just for state? So it's a last one, but it ends in an infinite list. So what kind of inputs is your application expecting? What kind of outputs will you bring? Like, what kind of messages are you going to send to the other applications? And so on, so on, so on. So you can see it's a lot of, it's a massive design space for execution layers, and a lot of decisions that the dApp developer need to make before locking into one. I think a very good way to split the design space in a first look is to think about shared rollups and app chain rollups, right? So I have this idea of shared rollups, which we have machines, execution environments that were planned to support shared rollups. So the AVM is an example of that, right? We have the Solana VM as well, Aztec and StarkNet and so on. And these are execution environments that are planned to host many dApps at the same time. And if you want to do that, then you have to be very careful with things, right? Because first of all, if anyone can deploy a dApp, then someone can deploy a malicious dApp to attack your execution environment, right? To attack other dApps. So memory safety is a problem. Metering, adversarial metering is a problem, right? And you see that in Ethereum all the time. They have to be very conservative of gas costs, because anyone can launch an application that takes advantage of some mispriced gas to attack the entire layer. On the other hand, you have app chain rollups, which are way less composable than shared rollups. They have a worse interoperability, but they do have the advantage of being a safer environment for your application, because your application is not really attackable by other applications, at least not directly. So you can take more design trade-offs regarding metering gas, and even decentralization, computational scalability, and so on. So Cartesi, we are at this side of the spectrum. You have like Solana. This is not a complete graph, of course, but yeah. And you have some projects in the middle who are trying to cater for both shared rollups and app chain rollups. But this separation usually is very good at defining the kind of trade-offs that you're going to get. So just going over real quick about the design choices that we made at Cartesi, just to give an example of what I'm talking about. Cartesi is an execution environment with a RISC-V architecture, right? As a Linux runtime, and it's optimized for app chains. It would be insane to run this as a shared layer, simply because the computational scalability wouldn't be there. It's too expensive for you to host multiple applications at the same time. So we optimized for computational power, which means that we had to sacrifice instant interoperability, for instance. We optimized for fairly complex applications. And therefore, we need an execution environment that can support complex tooling, because you can only build complex applications if you have complex tooling, at least safely. This slide's a bit outdated. But the trickiest parts of building Cartesi is building the fraud-proof system. Because as you can see, you have to prove a very big computational power application that has complex tooling on a semi-complex machine, which is RISC-V, which is not really complex, but it is complex compared to the EVM. So that's it. Thank you, guys. And any questions, I'm around.
We do have time for a couple questions, if there's anything from the audience. All right, big round of applause. So next up, we have Ethan, and I will be pulling up the slides, and he'll be joining me on stage in a moment. This is a beautiful, beautiful initial slide.
Hello, hello. Hello, yeah.
All right, turning it over.
Oh, yeah.
Ethan is all yours.
All right, what's up, Modular Summit? Cool. Do I have a timer? I gotta keep precise track. No? All right, I'm gonna bust out my phone. I'm already wasting precious, precious time. Okay. Cool. Well, thanks everyone for coming out here. Modular Summit. Woo. Yeah. Round of applause. All right. That's right. Yeah. Love this place. So I'm back. Guess who's back? It's me. I'm the co-founder of Cosmos, CEO of Informal Systems, and we're incubating the Cycles protocol. We do a lot of stuff at Informal Systems, security audits. We run staking. Offering on Ethereum and in the Cosmos ecosystem. We're also leading development for the Cosmos Hub, best place to launch a chain. We do a lot of secure engineering for the interchain and for Starkware and others. And we're incubating Cycles, which I'll talk to you a bit about. So a lot of exciting stuff happening. But I also like to think about sort of bigger problems in the space, and that's what I want to talk about a bit today. And so the talk is called Defund the Dealers, but I'm not going to tell you why for a little bit, right? So just keep the mystery, just hold it in the palm of your hand. This is what I want. All right, so we're here to talk about liquidity, and we're here to ask the big questions about liquidity. Where does it come from? What is this mysterious stuff? Is it in the room with us right now? Yeah. Who pays for it? How do we decentralize it? What does it even mean to decentralize it? Is that something we want? Okay, and these are the things we're going to try to answer. Or at least understand a little bit more in this talk. But to do so, we're going to have to talk a little bit about history, okay? And I promise I'll be brief, sort of. When I heard my talk was going to be 25 minutes instead of 20, I thought I could, shower you all in a little bit more monetary history. This is the stuff I love. I promise this is not seed oil. This is, pure extra virgin olive oil here, monetary history. All right, so we're going to talk about the medieval period, okay? And the reason this is important is because they actually had a quite advanced and sophisticated banking system and monetary system that isn't that well known. And I think there are things that we can learn from that historical monetary system that we've kind of lost in the transition to modern capitalism. And I want to sort of revive that. And I'm not suggesting that we need to return to the medieval era or anything like that, but there are things we might have lost that are worth knowing about. And so I want to describe describe this system briefly, and then we're going to evolve forward in time. And so in this period, you had many different jurisdictions, and they all issued their own money, primarily in the form of a silver coin, sometimes gold. And there were two main institutions in the money market at this time. There was what we call the mint and the exchange. Now, the mint defined the issuance of coins within each particular jurisdiction, right? And this was governed by the king, while the exchange defined the exchange between different monies, between different jurisdictions, and this was dominated primarily by the Italian banking families, okay? And so how did this all work? Well, at the mint, some merchant would come along and they would have some silver bullion that they acquired from trade or from mining or dug out of a hoard or something like that, and they would bring it to the mint, and they would give up their silver to the mint, and the mint would give them back some coins. And in doing so, the merchant has given up some of their silver, some as seigniorage. They're sort of taken away by the king, and so the merchant is paying essentially for this service. But they receive coins in exchange, and the value of those coins to the merchant in that jurisdiction, their actual purchasing power, is higher than the metal they started with, right? So they actually gain purchasing power, but they have to give up some silver, right? And this excess purchasing power actually comes from sovereignty. It's the power of the king itself to declare that by stamping my face on the coin, it's now worth more than the silver in its uncoined form, right? And so the important thing to emphasize here is that it's the users, it's the merchants that are paying for liquidity, right? They're paying for access to the liquid coin form, this means of payment. They're paying for it by giving up some silver, and they're incentivized to do so because the coins are worth more. And that's the sort of power of sovereignty expressed by the king that allows the merchant. The king wants silver because he needs to fight wars overseas, right? His own coins, aren't kind of enough for him. He needs the silver. But the merchant, so long as they're doing business in a local jurisdiction, they're happy to get those coins and to get that higher purchasing power, okay? Now, the exchange is a little bit different, right? Now remember, this is a time when usury, it was illegal, right? So it was prohibited. So you couldn't deal in the time value of money because time is something that belongs to God, and who are you, to sell something that belongs to God? And so they were having, modular summits at the time where they'd get on these panels and they'd talk about, can we sell something that belongs to God? And the theologians were unanimous that no, you can't. And the Italian bankers are like, all right, so we're gonna have to do something else. So we're going to engage in foreign exchange, and that was legal at the time. That was okay. So instead of dealing in current versus future money, these guys are dealing in present versus absent money, and that was what sort of dominated the monetary system at the time. And the way this would work is that some merchant, say in France, who's an exporter and has some importer in Spain, right, who owes him money. And he's in France, and so he wants to collect his money, but he doesn't want to go to Spain. He doesn't want to ship metal. It's all expensive. So he'll write up a bill. He'll draw a bill on his importer from Spain, and he'll sell it to a banker in France. And the banker will give him some coins, right? And it'll now be the banker's problem to collect on the debt. But the bankers were smart. They coordinated a highly sophisticated, very advanced banking system. This is back in the 16th century and even earlier. And they would coordinate the whole system to try to balance the trade flows across the different regions, right? So that they could gather on a quarterly basis in these clearing fairs where they got together with the other bankers and they cleared all of their debts without using any money at all. Right? Very, very powerful. They're focused on this idea of liquidity saving, right? That between themselves, they would structure the whole system so that they could save liquidity. Now, so that's clearing and liquidity saving, but the users are paying for liquidity. And unfortunately, or fortunately or fortunately, this system sort of came to a crashing halt at the end of the 16th century because of all the silver that was being imported into Spain. It compressed the spreads, it kind of ended seigniorage, and it led to the rise of the central banks and the modern system, right? And so in the modern system, instead of focusing, instead of the users paying for liquidity, now the state is explicitly subsidizing liquidity by paying for private people to actually produce it rather than the other way around. And we've moved from a system based on the clearing principle and liquidity saving to one based on accumulating reserves and liquidity provisioning, right? And so in summary, this is a beautiful chart. Take a picture of this and mull over it. But the important thing to emphasize is that we moved from the merchant paying to the state paying, from a principle of liquidity of clearing to reserves, liquidity saving to liquidity provisioning, from a quality theory of money based on balancing the graph to a quantity theory of money based on an imbalanced graph, funding the permanent deficits of states. Okay, and so I'm not saying that we have to go back, but maybe we lost something. Maybe there's something to be learned there. Okay, now where does that leave us today? Well, today we have our good friends, the grand firefighters, Janet, Jerome, and Ben. This is a real picture. You can tell because that's actually what Janet's hands look look like. And there's the grand firefighters just dousing the world in liquidity, right? Like, oh, we're in this crisis. Everyone's on fire. The fires of illiquidity are just ravaging the planet, and so we need the great firefighters to douse us in liquidity. But what is this liquidity even, right? Everyone's just obsessed with the Fed's balance sheet, right? This is the Fed's balance sheet, the liabilities over the last, 20 years or so. Look at this explosion, but is this stuff even money? Who is this liquidity for? It's only liquidity for the banks. Only the banks can access this liquidity. These are their deposits. I don't have deposits with the Federal Reserve. They won't let me in. I could try to register. They'll exclude me, right? And so this kind of liquidity, it doesn't even make it into the real world, right? Everyone's obsessed with these numerical quantities. How much liquidity is the Fed printing? What is this stuff? Is it in the room with us now? Can you access it? Can you use it? No, you can't. Only the banks can use it, right? And they're starting to recognize that this is a problem and they need to do something about it, right? But it seems like in crypto, same shit, different ledger, I mean, for all of our open source and verifiability and transparency and all this great stuff, we're still stuck in the same paradigm of monetary aggregates, this obsession with liquidity that has no meaning, no value, no utility to real people. When was the last time your mother accessed, liquidity from one of your blockchains? She never did, and I'm not sure she ever will. Well, we might have something to do about that. Okay, so before we kind of address that problem, let's talk a little more about providing liquidity. Now, where do we start with that? Well, I'm starting with Jack Trainer's The Economics of the Dealer Function. It's very, very nice, easy, clean paper that just describes the mechanics of how dealers work, right? And so we're just going to cover it briefly. How do dealers work? Well, besides the dealer, we think about two different kinds of actors. There's the value investor and the time investor, okay? Now, the value investor has low time preference, right? They don't need, high time preference. High time horizon. They don't need to worry about liquidity. They're just in it for the fundamentals. They want to buy low, sell high, right? But the time investor is in a different situation. They have illiquidity issues. They need to transact now, okay? So the willingness of the value investor to buy low, sell high creates what we call an outside spread. And within that's the outer bars. And within that outside spread, there's an opportunity for the dealer, the market maker, right? Dealer, market maker, it's the same term. They show up and say, hey, I'm going to take advantage of this outside spread, and I'm going to quote an inside spread, a bid-ask price, to the time investor who needs money now. And I'm going to use my balance sheet to absorb flow from the time investor so I can make liquidity available to them, and I'll take the risk onto my balance sheet because I'm going to expect that over time the flows are kind of going to net out, right? So I have this opportunity because of these, because I can take some risk but the flows will net out, I can harvest this spread in the meantime, right? But the size of that spread is actually the dealer's estimate of their uncertainty of the existence of the market itself. Because if they take on too much directional flow, right, then the market's going to disappear altogether. The dealers are going to step out, and this happens from time to time, yeah? Okay, now in crypto, we've gone ahead and tried to decentralize the dealer function, AMMs, XY equals K, all this beautiful stuff. But in doing so, we've collapsed the spread into a static fee. It's no longer something dynamic that the dealers can adjust. It's just the transaction fee in the AMM. Now, there's been a lot of research over the last year or so about, okay, how can we make dynamic fees in AMMs? Can we make them a function of volatility? This kind of thing. But it's still a big open area for research. And we're increasingly discovering that actually, just decentralizing the dealers isn't quite cutting it. And a lot of folks are going back to hiring, centralized dealers, centralized market makers, adding concentrated liquidity, things like this to address these kinds of liquidity problems that are still plaguing us in the blockchain ecosystem. Now, Cosmos is certainly no stranger to this. We've been, plagued, you could say, by liquidity challenges, and despite having clearly the best tech, Celestia and everyone else, and amazing user interfaces and all this stuff, and amazing DEX like Osmosis, we're still struggling to attract sufficient liquidity to compete with, let's say, Ethereum and Solana and these kinds of ecosystems. Now, so what are we going to do about this? Well, we're introducing Hydro, right? So this is an application that we're building at Informal Systems. Right, it's cool. We've gone from like theory and history, deep theory and history of money, to actually building like degenerate liquidity providing in the Cosmos ecosystem. Let's get it done, right? And so this is a decentralized auction platform for protocol-owned liquidity, right? We want to make, there's all this capital tied up in community pools across the Cosmos ecosystem and beyond. We want to make this capital accessible. We want to deploy it into AMMs and into other, other apps that actually need access to liquidity in a frictionless and permissionless way. And we're going to work with our friends from the Time Wave project to make this all kind of automated. Because right now what's happening is people are making making proposals to the Cosmos Hub to say, hey, we want some atoms. We're going to put it into multisig. We're going to deploy it into some AMM. You know, it'll sit there in the LP. No one's really monitoring. It's all kind of like ad hoc, right? So we want to formalize it, build a proper auction platform, let people bid on it, and unlock all that capital in the community pools to provide liquidity across the ecosystem. So for all you modular people building rollups, you should know that the Cosmos Hub is Celestia's best ally, and it's your friend, and it's here to support you. And if you want access to TIA liquidity, you should get in touch with us. And for all of you, you know, that want the grand power of an application-based blockchain and building in Cosmos, the Cosmos Hub is the best place to launch a chain, and Hydro is a big part of that. And you should get in touch. So arguably, you know, after all this ranting about problems with liquidity providing, this is sort of like the best we can do in the world of providing liquidity, right? Nice decentralized liquidity provider. This is kind of the pinnacle. But there is another way, and it's the other way that I want to talk to you about, right? So liquidity saving. Now, I hope you were paying attention during the history, because we're gonna run it back turbo here. You know, remember the bankers, they're gathering in these clearinghouses on like a quarterly basis to clear all their debts, right? Well, I came across this paper about liquidity that says for the ordinary saver, liquidity is of little value, right? And I would just sort of keep the dealer function in your mind here, because the point of the dealer function is that it only works because the flows balance out over time, right? And so they make this point that many long-term investors would be just as well served by an asset market that only traded once a week. Imagine if the markets were only open once per week. I mean, it's ridiculous. Obviously, it's a silly idea, but just conceptually, there's something interesting there, because if the market's only traded once per week, then you might not need dealers, because all the flows from all the different individuals that would happen over the course of that week could balance out against each other. You'd find the liquidity from the other people that were going in the other direction, right? And so, you know, they say the attempt to offer perfect market liquidity actually ultimately works against the interest of investors. So there's something to think about in this like batch offering, right? That batching trades can actually be incredibly valuable. And so, you know, maybe not weekly, maybe we should do it, you know, daily or hourly or every few seconds, right? And who's doing it every few seconds? Our good friends Penumbra. Yeah, represent. So Penumbra just launched, huge round of applause, right? These guys are doing some breakthrough stuff, and they get it, right? And this combination of privacy and batching, I mean, they still have liquidity providers because they're only running the auction, they're only running the batch execution every few seconds, right? So they can't net out all these trades, but at least they can significantly reduce how much is being leaked in executing their trades, and they've got the right idea. This working towards batching, right? So everyone's really excited about Penumbra, and for the right reasons. And so we're building something similar. We're sort of generalizing the ability to build private batched execution on COSM-WASM chains, and we call that Quartz, right? And what I really like about the design of Quartz is that it really emphasizes the sort of modular thesis of composition, right? We have encrypted intents and results that really just need data availability. You can post that to Celestia. You have execution. We like to do it in a trusted execution enclave so you can keep it private, right? And then produce zero-knowledge proofs of correctness, so that in the worst case, if Intel rugs us, we're just back to the base case of like public, you know, transparent blockchains today. And then we have settlement happening on chain where you can update state and so on. Now, the reason we went and had to build Quartz was because we're building a really interesting application that we call Cycles, right? And Cycles is based on these ideas of privacy and batched execution, but it's an open clearing protocol, right? It's designed to clear the most debt for the most people with the least money. Okay, I'm going to say that like 6 more times in the talk, so don't worry if you didn't catch it the first time. But the idea behind Cycles is that everyone in crypto thinks that like, oh, the power of banking comes from the assets, the asset side of the balance sheet. If only we had counterparty-free, permissionless assets, then we could solve banking. And the bankers are just like laughing all the way to the central bank, because they know that the power of banking comes from the liability side of the balance sheet. Like we saw, the bankers have been gathering, even though our system is no longer systematically designed around the clearing principle and liquidity saving, the bankers still gather in clearinghouses every day, and have for hundreds of years, to clear as much debt as they can with as little money as possible, right? And this power of clearing, we have all been systematically excluded from. Unless you're part of the bank, unless you marry into their family or whatever, you're excluded from it, right? And maybe you've used Splitwise. That might be the only time you've experienced clearing, right? You split a bill with your friends, but Splitwise only works in small trusted groups with trusted friends. What we want to do with Cycles is allow people to clear with arbitrary strangers, arbitrary debts, anywhere in the world, in a privacy-preserving way, right? So that's the power of Cycles, to clear the most debt with the least liquidity for the most people, right? And so to illustrate how kind of Cycles works. We have our good friends, the Three Stooges. You might be familiar with this video. You know, the idea is that they all find out that they each owe each other $20, but they only one of them has a $10 bill, right? And so they pass the $10 bill around a few times until all the debts are cleared, right? And then everyone's like, oh, banking is stupid. Okay, there's actually like a profound insight in here, which is you could clear all $60 of that debt with no money at all, right? And the bankers know this, but the rest of us seem to have kind of forgotten about it, right? So that's what we can bring back. Here's him actually, giving the money. And so with Cycles, the way we're approaching this is to build what we call a universal finance engine, right? We can we can boil finance down to a very small number of primitives, what we call obligations and acceptances and tenders, that allow us to express kind of arbitrary financial compositions that can then be solved over with a graph solver in an enclave, like I was showing in a batch operation in private. And it's not just about cycles between people. We can add liquidity sources as well. That purple node at the bottom is a liquidity source. It could be Bitcoin, could be Atom, could be TIA, could be what have you. It could be Hydro. It could be this platform we're building for providing liquidity that you can close cycles with a liquidity source. In the world of cycles, there's no difference between a liquidity source and a user. We can abstract over all of it with our universal finance engine and build arbitrary kinds of financial applications from a small number of primitives with the same graph solver. And when you generalize this into a network with many different liquidity sources, you come to unpack incredible amounts of power, where a small number of people being willing to use and accept a particular currency can actually benefit a much larger number of people that don't even want anything to do with that currency because of the network effect in cycles. And so the way we're building out this platform is to make it a sort of a risk-reduced platform that gives you the power of the obligation graph for building new kinds of lending protocols and new kinds of stablecoins that are aimed to be designed on top, right? So Cycles is aiming to be this sort of optimal place to build lending protocols and stablecoins. And so with that, I'll tease the idea that we can now build a safe, decentralized, liquidity-saving stablecoin. What can be unburdened by what has been. Yeah? Let that sink in for a minute. This is where I drink some water. I don't have any. So, Chad liquidity savers, Virgin liquidity providers, respect the graph, okay? All right, now I'm ready to tell you what the title is. Are you ready to know about the title of the talk? Do you think you know yet? Does someone want to get up here and, we have some time? No, that's crazy. So, back in 1922, Carl Schmitt said, sovereign is he who decides on the state of exception. And today, I apply this to blockchains. I say, sovereign are they who decide on the state transition. And I bring this up because to understand this problem of liquidity, I think we have to go back to the question of sovereignty, sort of where we started with in history. And it's somewhat unfortunate that we have to turn to like a proto-Nazi to really get the best the best of sovereignty and theorizing about sovereignty. Many people are struggling with this sort of challenge, but there's our friend Carl, or anti-friend Carl, however you want to refer to him, was really focused on the state of exception as the state of emergency, right? The emergency event, right? But there's a counterpoint to this, which is that the state of exception can actually occur in day-to-day reality. It can occur in the everyday. It doesn't require some extreme emergency to go all the way up to the central bank. And this is most easily expressed in the institution of the police. Okay, where the police get to actually express this kind of sovereign power when they intermediate the making and enforcing of laws, right? They show up for security reasons. They intervene for security reasons where no actual legal situation necessarily exists, right? And by doing so, they actually inhibit our ability to build more preventative solutions or to decentralize the reaction, right? There are lots of different ways to respond to things, that institution actually inhibits us. And thinking about that, it occurred to me that, hey, maybe dealers are like cops, right? Maybe dealers are like the police. They express this kind of sovereign power when they interfere in people's illiquidity in the everyday, the state of exception of illiquidity in the everyday. They intermediate between production and consumption in markets. They show up for liquidity reasons when no economic situation exists. And they potentially inhibit more preventative mechanisms and more decentralized mechanisms for addressing those liquidity challenges, right? So defund the police and defund the dealers. Now, I'm not saying that we completely get rid of police, completely get rid of dealers. I mean, obviously, we're going to need cops, we're going to need dealers to some extent. But these are very expensive, state-subsidized institutions, right? And what we can do is significantly reduce our reliance on them. I mean, people like to say cities are like police departments. Cities are large police departments with small civic service appendages. Well, it feels like our economies are large dealer departments with small, production appendages. Everything's about, the dealers, the market makers. It's all anyone seems to care about, right? And so what we can do is focus instead on preventative mechanisms and on decentralizing their reactions so that we can reduce our reliance on them. Not get rid of them completely, but reduce the reliance. And so in the world of liquidity and the dealers, these preventative mechanisms are the liquidity-saving protocols, right? Protocols like cycles, things like Penumbra that do this kind of batch execution, but really we have to push towards the liquidity saving and to decentralize the reaction in the liquidity world, we can use things like AMMs, right, and like Hydra, which are really focused on that. So the alternative title for my talk was a throwback to Evan Forbes' talk last year. Who saw that? Yeah? More of you have seen Evan's talk. I mean, come on. Yeah, it was a real banger, right? But this was the alternative title, How to Make the Dealers Cucks, okay? But you weren't going to understand that until we got, all the way through. Evan last year put out a long list of stakeholders that he believes are cucks. I will add, dealers to that list because that's what we need to do here. So that's it for me. Thank you so much. Stay connected. We are hiring at Informal. We're bringing cycles to market. We need a lot of creative, brilliant, motivated people to make this thing work. We're transforming the financial system, and that's hard work. So if you're interested in any of this or what we're building with cycles, trying to clear the most debt for the most people with the least money, please reach out, get in touch, and thanks so much.
We will do a couple questions for Ethan, and if you all don't have any, I got some spicy ones. So
Hello.
We'll see. You guys can think about it for a minute too. How does defunding the dealers change the notion of inflation and inflation control?
Yeah, so I think this is one of these things where people are focused on quantities of money again and inflation indices. And inflation is always a subjective thing. There's no such singular thing as inflation. It always depends on an index, right? And who composes the index is actually a source of power. What really matters is the structure of the graph, the quality structure of the graph. We need to move from a quantity theory of money to a quality theory, which allows us to actually balance out the flows. And defunding the dealers is all about balancing the flows and moving towards a more quality theory of money, respecting the graph, and allowing people to clear more debt with less money, and that is another way to actually address inflation. Yeah.
Lovely. We have one for the crowd.
Yes.
Wait for the mic behind you.
We've had the idea of Dutch auctions in crypto like as long as I can remember. Everyone's trying to implement them at some point in time, but yet we have not had like a Dutch auction paradigm. I'm wondering like why you think we haven't been able to have that ideal.
Park, did you just stand up to answer that?
So we do actually have Dutch auctions. They exist on Penumbra now.
Woo!
Yes, but in terms of just like adoption and usage and volume running through them, I wouldn't call that like the dominant paradigm in crypto.
Well, it might have required the power of Cosmos chains to really make it work. I don't know, but that's sort of a joke. But there are, I think there are some. I'm not too familiar with the exact state of the ecosystem. I think it's probably easier to build the people ask the same question in the TradFi markets why Dutch auctions haven't caught on, and there are a lot of interesting mechanisms that just require kind of more. I mean, BFT itself is an interesting mechanism that didn't catch on until there was like really the socioeconomic impetus for it until Bitcoin had proven it out, right? So someone needs to do the hard work of actually like proving it out and changing the paradigm. I was telling Henry the other day, like, Penumbra has basically succeeded in like changing the scope of like what's possible in people's minds now, at least I think, and so I expect that we'll see a flood of these kinds of mechanisms in the future now that they're kind of here now. Yeah. Defund the dealers.
All right, and with that, let's give a big round of applause for Ethan.
Thank you.
So next up, we have a panel. So give us a couple moments as we get the chairs on stage. If the panelists can make their way up as we get the chairs on stage, we'll be ready to go. Honestly, fuck booths, just just go and find the people.
Yeah. You haven't finished the last question, by the way.
Oh, that part got cut out. Honestly, part must ask for like things that you want for the
No, this is actually it's a different one, but it's come
yeah.
lately.
That's not for me. You're not supposed to know.
What are you doing, dude?
Sure. Awesome. Maybe
You should probably be
on
together.
yeah. Just in time.
I have so many mics. Anyone missing a mic? Should I double assist? No, just kidding.
All right. Hello, everyone. I'm sorry you have to bear with my coarse voice for a little bit. Today we have on stage a set of interesting contributors from different ecosystems, primarily focused on application ecosystem, as well as our base layer protocol, our researchers from the EF. I feel like maybe someone else moderates better.
You want to moderate this? Hi, welcome everybody. I also have a coarse voice, but maybe it sounds better because it's like deeper, whereas normally my voice is much higher. So it's kind of sensual. All right, welcome everybody. Welcome to this panel. Thank you, Tina, for bringing us all together. We got some EFers, we got some application layer people. Why don't we go down the line and introduce ourselves?
Sure, hey. I'm Ansgar, I'm a researcher at the Ethereum Foundation. I've been doing a bunch of different things, most recently looking both into the kind of the staking economics and overall staking system for Ethereum, but then also worked on roll call, which is an attempt of basically trying to coordinate EVM-based layer 2s and give them help in moving beyond the base layer EVM.
Yeah, I'm Vitalik, also at the Ethereum Foundation. Also, I'm gonna look researching a bunch of things.
Well, hi, my name is Easy, and I'm from co-founder CTO of Math Network. We work on we work on social in general, from like front-end application to protocols to infrastructures. So yeah.
Yeah, hi everyone. I'm Matt, co-founder of Caldera. We are a rollups as a service platform. We help a lot of people launch customized L2s and L3s. Today I'm up here to represent some of the gaming projects that we work with, including ApeChain.
Hi, my name is Makoto. I'm from ENS, Ethereum Name Service. We have recently announced the plan for ENS v2, which core of the part is moving core parts into layer 2. So I'm excited to join here to learn and learn what's the best way.
Hi, I'm Ken. I do research at the Uniswap Foundation. Uniswap swaps things. Cool, fun. Do we dive in?
Yeah. So maybe just to spice it up a little bit. So for all of the application ecosystem, or if you consider yourself part of that ecosystem, what's the usage of your ecosystem? you can choose your favorite metrics. Let's go. And who are your primary users?
Cool. Let's start backwards. Primary users. So Uniswap is cool, right? Because Uniswap technically it can be for anyone. Uniswap is about access and sort of the ability for everyone around the world to be able to have liquidity, to swap with each other, and to use any tokens and kind of do with it what you want. And so with Uniswap v4, I think like one thing that sort of shifts the framing here is like instead of thinking about Uniswap as a product and thinking about how we swap with each other, how we make LPs more profitable, Uniswap thinks more about, with V4, you think more about order flow as the product, right? How do you actually use liquidity as a way to change the way you're thinking about order flow, right? What is the order flow that you're doing? And how you're actually expanding kind of the scope of what that is. So for us, I guess, as V4 sort of expands with more hooks and sort of more integrations, we're not really thinking of users as just like a retail user who's just swapping ETH USDC, but really thinking about everyone else who wants to do new things on Uniswap, right? It's more of what if your LP was like a margin call, right? What if you actually have KYC tools for real world assets? This is a fundamentally different net new market we're bringing access to for anyone in the world.
Okay, yeah, so ENS is probably one of the oldest running dApps. We launched in 2017, May the 4th. May 4th is the way to remember. And yeah, so the usage number, one of the great things about dApps and smart contract is everything on chain. So I just look into geoanalytics, and currently we have over 2 million active names. One of the point is like our name will expire if you don't renew. So in total we had more registrations, but for the active ones 2 million, and I think we have about 800,000 unique addresses which point to ENS name. That's on-chain metrics. We also have some sort of things called off-chain resolver, which allows you to basically doing anything on layer 1 is very expensive nowadays. So one of the kind of layer 2 strategies, we introduced something called off-chain resolver, which allows you to store the data not just on-chain, but anywhere. So it could be layer 2, it could be off-chain. So perfect example, I think Uni have uni.is, and you issue subnames to, I think, 100,000 users, and also cb.id, Coinbase. I think they have like several million users, but they are currently storing on, I think, their database. So we don't have the on-chain metrics, but over a million is something we've had.
Yeah, because I'm kind of here representing like the conglomerate of like gaming projects in our ecosystem, I don't have a lot of the metrics offhand. But one of the things I will say is that when we work with gaming projects, they're often interested in all sorts of different types of users, right? So there's like the kind of highly crypto native on-chain users, but there's also a bunch, maybe there are some users who interact on-chain, but they're only really there to like hold, buy, and sell NFTs. And then there are a bunch of other users who, may or may not even know that they're using, a project that interfaces with the blockchain.
So we're doing social, and we consider everybody as our users if you're doing really like behaving in society. And then, so we started from a browser extension that allows users to send encrypted messages on like major social platforms like Facebook and Twitter, because like we thought like these Web2 social players are just like abusing our data and abusing our privacy, so we want to like make something to fight against them. So we started from a browser extension, and then we brought in a lot of users onto this like encrypted web or encrypted social. And then we just like, connect with like Ethereum and then connect with the blockchain so that these users then are also able to directly interact with like, smart contracts or any like on-chain assets directly within their like timeline on Twitter and Facebook. So it's more like enhanced timeline for users to better behave on like on-chain world. And on our best estimation of like total number of users is within like 100K who have ever like downloaded our extension. But we are also doing a lot of like Web3 and Web2 identity aggregation, and we have like at least 500 to 700K, I can't remember clearly, but bindings between like, a Web2 identity to non Web3 identity, which is like a double sword, I would say a double-edged sword, because like on one hand, you can get really great like information regarding some like Web2 and Web3 user connections, but on the other hand, it's like a huge privacy issue here, because like you can easily be social engineered through this information. So we are trying to find a way to fight against this, or find the balance, or find the trade-off between convenience and privacy, or like secure social world. Okay, that will be for my answer.
Yeah, I mean, I guess, users of Ethereum include, it definitely is still a lot of direct users, a lot of layer 2 protocols, and some applications. So it probably ends up being a mix of all three. Like obviously, originally Ethereum was kind of 100% just like people building applications like directly on top of it and doing everything there. But then like over time, more and more has been starting to happen through the layer 2 ecosystem. But I think like base layers definitely have like a much more low level relationship to stuff that happens on the user layer, right? It's kind of like, if you're like C++, like it's hard to design C++ in ways that's opinionated on issues of like, like privacy, for example, right? But I don't think blockchains are quite as low level as C++, but I think they're, like somewhat more in that direction relative to some of the, like closer to user stuff that other people are working on. Though I do personally think about closer to user stuff as well.
Yeah, I think that's pretty much covering it. I think basically, well, with the modular approach of Ethereum, right now, basically, you can think of Ethereum as the ecosystem, and then our users are hopefully like a lot, basically all of the above, basically. Or then you can think of like more narrowly of just the base chain, which basically really just the root of the ecosystem. And then of course, yes, like basically the users become in a way more over time more boring because they're mostly just management operations for the higher level actual user activity. So.
Well said. Well, so I have a question for Vitalik again. So in 2013-14, Ethereum white paper characterized it as a next generation smart contract and decentralized application platform. So it seems to have changed maybe.
Oh, I see, because we're now a smart contract and decentralized application platform.
Something like that. So, and also during in the white paper, you laid out a few lovely examples. Why was storage an application?
Yeah, okay, so the whole decentralized storage thing, I feel like that's like one of the like underloved parts of the original vision, right? Basically, a lot of people have needs to store stuff, and I mean, there's different kinds of storage. There's like backup of your hard drive. There's like like hosting, like static web pages. There's like some of everything in between. But there was like there's centralized providers for all of this stuff. But it would be nice if we had decentralized providers. And the nice thing about crypto is that you could have like these very direct incentive markets where you just like directly pay people to store stuff for you. And this was something that like I was very excited about as a use case, like back then. And like I mean, I think it definitely does end up being pretty challenging to provide in practice, basically, because like you need like essentially for redundancy, you need data to be stored in multiple places, and then ideally you need some kind of assurance that the different places your data is being stored is like actually kind of like politically independent and not just like architecturally independent. So there's like this big rabbit hole, and then like people like Filecoin ended up like trying to like solve the problem partway for like at least some use cases. I do think that we should like actually go back and try harder to solve some of that stuff. Basically because you know, specifically I think like for the use case of storing content for dApps, right? Because okay, like I think for personal files, I mean realistically, like you know, like there's like we literally have like 1 terabyte USB keys. Like I actually saw these I mean, like once I was like going to the like one of those like crazy I mean like electronics like stores in Taipei that just like has like some of everything on every floor, and you know they got like the drones and the cables and everything, right? And they like I saw this thing for the first time. It's like a USB key, and it said 1 terabyte on it, and I'm like, whoa. But and like that's like basically the only thing like I have that can like that I need to store that can match that are like basically exactly 2 things, right? One is AI models, and the second is blockchains. And you know, for blockchains, like you know, we need to implement like EIP 4444 like yesterday. So you know, big cheers to everyone who's still actually working on doing that. And then like after that, stateless clients and so on. But like, yeah, it's a bit of a digression, but like for the point is like I think the storing your own pictures like use case is less necessary, because like I actually think it's getting easier and easier to just you know, like store all of your own pictures locally. I mean like if that's what you want. But for dApps, like okay, so I saw like I think what was that dApp that got hacked, like whose website got hacked yesterday? I forget. Was it? It was Compound. No, that was the one, right? And like basically, yeah, you know, like we have this like trust chain that's like much crappier than it needs to be on a whole bunch of ways, right? And what we do need, I think, is like it's time to bring back Mist, right? Like who here remembers Mist? You know the Ethereum web browser, right? Yeah, so you know we need to bring back Mist, right? And then inside of Mist, like you know, like we need to actually let people, you know, like go to like you know like dapname.eth. And then like that .eth, you know, like on ENS, you actually have a hash, and then you have an IPFS like record, and you actually download the content, and you actually check the content against the hash, and then the ENS thing itself like needs to be you know, like controlled by some kind of multisig or even some kind of DAO directly, and so you have like this actual trust chain that you'd have to follow. So like there isn't this like one single thing that you can hack and then just like immediately and even undetectably like start you know like serving people a web page that just like grabs all of their you know, like all of their assets, right? But the point is that like for that to happen, one of the really valuable things to have is to have like dApp content storage that is independent of specific servers, and like having better you know, like infrastructure for that. I don't know. I feel like I have to say the full word infrastructure because like the word infra is like maximum cringe. So the you know infrastructure to actually do that, right? And then we like that actually increases the security of the ecosystem. Yeah.
Speaking of the security of the ecosystem, back in the days when Uniswap first started, the immutability was super important, and things seem to have changed quite a lot. So why has dApps evolved? Like what has changed over the years? This is a question for Ken.
Well, this is really interesting. And I just like a little bit of preface, like I've cornered both of these guys about this, but it's this like heavy financialization of where we are in DeFi and Ethereum, and there's now a lot of liquidity. There's a lot of money that comes in and out. There's a lot of money that sits on Ethereum, and you know I think we're afraid to say the words MEV. We don't want to talk about that, but it's such a big thing, right? We are like. We're so afraid of it being exploitative, and in many ways it is exploitative, but it also it's natural market efficiency that exists with how blockchains are created, or specifically for Ethereum, and it's tough, right? I think like, you know, when you think about Uniswap users, you think about the retail users who are using app.uniswap.org, who are using BananaBot, or just Telegram bots in general. And it's tough because when the people who are trading on Telegram bots, which is not an insignificant amount of people, it's like 12.5, they're 15% of market share. They're giving their private keys to Telegram bots, being like, yeah, let me buy insert coin, and just like you know, it's it's really tough for Uniswap to kind of like see this happen, get picked off, and like the degeneracy like keeps going. So I think like one of the things that I've been super anxious about is like, okay, over the last couple of days, we've been talking about how liquidity on AMMs is moving off of Ethereum. And I guess, you know, if liquidity moves off Ethereum because of MEV, you know, it sort of like moves applications or DeFi applications off Ethereum. And I think I know what some people would say, you know, maybe it's good that dApps move off Ethereum and we move it to L2. But it sort of does lose some of the economic security of what Ethereum kind of upholds. It also, you kind of lose the sort of like the, I guess the ability for people to freely kind of build on Ethereum the same way, right? Because you lose the composability, you lose the interop, or at least you create more friction of like actually letting users build on top and use these applications again for like Uniswap. Like we're looking to provide access to everyone, right? And if we move it off Ethereum, move it onto L2s, it's creating more static friction to be able to get started. The onboarding stuff needs to get created, and then like the dirty word, like the infra, right? With like negative incentives. Please don't attack me after this, but like the incentives are such so that like the infra actually becomes even more fragmented, so the users have even less of an ability to be able to transact on like what I think should be like freely accessible. But it's tough. I don't know. I'm curious to see how everyone else thinks about it.
I'm curious, what does the big picture guy, Ansgar, think about liquidity moving off-chain?
Wow. Well, I mean, moving off-chain, we're saying just moving upwards, right? So that does make a difference. And I agree that, like, if we have to be realistic that today that does come with a hit to interoperability and even security and all these things. But of course, I think that is the bullet we have to bite to get to scalability. Like at this point, kind of blockchain scalability, that's been a topic that's been around for I don't know 10 years or something. And I think we understand the design space pretty well. And you have to make some tough choices. And I think basically we are right now in this process. L1 is just not big enough for everyone to do all the things. Even if we try very hard, it's just not. And so we have to do go through the one-time painful process of making L2 feel basically like L1. And we can totally get there. Like I think we are right now maybe halfway there. In terms of both user friendliness and interoperability and everything, but then also of course security. But there is a clear path to that. And so if we just if we basically it's like a little bit of a like narrow path where on one hand, of course, we can't ignore all the complaints because those are valid complaints. But at the same time, I think we still have to trust that path is the right path. And I think if we get that right, then the end outcome will be just the same as L1, just much more scalable, basically.
But I guess like it's not. I guess we're not really seeing that, right? Like a lot of research is really pushing us to kind of like get Ethereum to be more creative around how we're dealing with MEV. And so a lot of the research is focused on what I think is actually like more centralizing forces and creates more, more surface area around like how we're capturing for validators, which is not a bad thing, but it also like doesn't stop essentially the problem that we're trying to solve here, which is like if we think MEV is exploitative, like we're creating new mechanisms to kind of move it around, shift in different places, but it still like doesn't change the paradigm of like where like Uniswap is, where the users are, and like the negative externalities that we'd want to like prevent and moving everyone off chain, right? Like I think we're not solving the problem here, and I think that's it's tough to reconcile with. Do you know what I mean?
I mean, yes and no, but I think basically we have to. The way I think about it is that like just because we have this very modular approach in Ethereum and also this very actual decentralized approach, that basically there are all these different sub-problems and there are different people that have, or different groups that basically have to solve the different problems. Like I think with MEV, we're seeing this very encouraging trend now of like more and more apps actually being smart about preventing MEV or capturing that themselves or something, basically so that it never actually hits the protocol level, right? But I personally, for example, like in my own research, I don't think about MEV much at all, right? So like I think we are pretty good at like having compartmentalized different research streams and everything, and I don't think I agree with your criticism that basically there's no progress on You know, like
Yeah, I guess it's not-
also just when you say off-chain, like I would not call, like if someone moves from L1
L2s
to
are not
L2,
off-chain.
it's not off-chain.
Sorry? No.
L2s are not off-chain.
Well, so people are not moving
They're
to
moving
L2s,
up,
right?
not off.
Well,
Yeah.
I guess the thing is, like, they're not just moving to L2s, they're actually moving off-chain with, like, private market makers, with a lot of these things, it's not necessarily just to L2s. And I again, like, please, no disrespect, I love you guys very deeply. But I definitely am not criticizing research in that direction. I guess my point is just, like, why can't we have both?
But okay, like last thing, and I don't want to
Yeah,
not ping
of
pong,
course.
but just back and forth. But I do think actually there's an important point here that like blockchains in a way like they're magical, but they're also like, you know, they're like a very, very powerful tool, and like you don't always need the most powerful tool. Basically, like for example, in the very early days, what dApps often did was literally just store everything they needed just into storage, right? And at some point, storage became not free anymore because actual adoption picked up, and then you had to be a little bit smart. Wait, do I really have to put that into storage? Can I just have that be off-chain, you know, indexed, and then I can just like get it because I only need it in the interface anyway. It's not relevant for my trust assumptions, right? And so basically, I think we are in that process where basically we had this magical new tool, and in the beginning we used it in the simplest way possible. And now that we are like getting more and more sophisticated, it really, I think, it's in a way like an art of like using this kind of trust anchor that the L1 is in basically the most lightweight way possible without compromising your trust assumptions. And I think that's not a bad thing. I think that's actually, in a way, like it's a beautiful thing. And I think it is inevitable if you want to really make the most out of, you know, the technology. I don't know, Vitalik, do you? I heard some thinking
I'm trying to
noises.
think. Sorry, I just forgot what my point is.
Well, so we actually have quite a few presentations or conversations about this later on. I want to actually turn to the our app and app rollup developers. What are your considerations? What goes through your mind, like when you choose what to do? There's so many choices today. Why do you launch a rollup? And why do you design it the way?
Why do we launch a rollup chain, or we just go to L2, or both?
Both.
Okay, yeah. So in our case, we just had a ENS conference on Monday where we invited lots of players from like the rollup, the service provider, to the end users. And currently, we are still open-minded. We could go just deploy to existing public layer 2 chain, or we could deploy our own. And actually, some teams, I think Axiom even suggested we should have our own VM, so like custom rollup, not even EVM. So we are kind of exploring from the diverse range. And in our specific use case, one thing unique, I guess ENS is slightly different from all the other L2 use cases because still most people use it in a context of DeFi where liquidity matters. And quite often when, for example, a fraud-proof based rollup, even though there's a 7 days challenge period, there's ways to work around because it's a fungible token. So whenever you can put the value and the stuff, someone can come and put a collateral, whereas NFT is inherently more difficult. So that, and yeah, that's one thing. And also, in our case, again, most DeFi or any chain, actually base model of the layer 2 is about, most of the case, you just create a copy of what you were doing in L1 on L2. And you just have an exact replica of the same thing everywhere. Whereas in our case, we basically need to cater for every chain, like, you know, for the simple usage of name resolution. So in our case, just copy, making a copy doesn't really help in terms of name resolution. So we actually developed something, our own kind of interoperable protocol called EIP3889, aka CCIP read, almost like 3-4 years ago. And that actually uses layer 1 as the entry point that most people, because pretty much all the dApps have a connection. If it's EVM compatible, you have a connection to layer 1. And the current nightmare is like whichever the usage, you need to figure out which chain it is, and you have to change network. Our protocol, our framework abstract that, so like you always use L1 as an entry point, but we have a ways to proxy to get the data from other chains. And to do that, we use storage proof of the Ethereum data storage, and also we design use ways mostly like hooking up the existing rollup mechanism that where every rollup tend to store the state root of the entire L2 on L1. So our framework use it to check that fetch the storage proof and then verify on chain. By that nature, we actually need a finality to the L1. So most people, if you have 7 days gap window, there's a way to work around. But in our case, we directly hook into the rollups core mechanism. So the faster finality, if it's 7 days, if there's a 7 days period, if you set the data on layer 2, you need to wait 7 days, which is almost unusable. So we are really, I think we are the, people sometimes say like faster finality is important, but there's a lot of work around like liquidity or like a pre-confirmation, all that stuff. But we are kind of, our design constraints to really challenge layer 2 to have that fast finality. That's the first thing. And another thing is decentralization and the censorship resistance. When ENS first launched, it was pre-DAO. So that DAO came in 2021. So when it first came out in 2017, we had a 7 multisig, which had quite a lot of power of like, I think the biggest power was like if 7 people multisig agrees, they could override your name. But from in the very beginning, it was very important because we were not sure how stable our smart contract is. And as time progressed, we gradually actually killed these features to the point that we still have multisig, but this multisig doesn't have much capability to do. But now, when it goes to layer 2, there's still lots of area where it uses like centralized sequencers, or even if there are many players working on centralized sequencers, then if it's zkShares, what happened to the provers? Can provers be, so there's a, we start seeing the, I think the last part our founder Nick Johnson mentioned in our conference is like, we spend so much time to decentralize ourselves, and then we don't want to get back to the square one. So that's security, and the fast finality is our top priority when choosing to, whether we pick our own L2 or just deploy to someone else's.
Thank you, that's super thorough. Anything to share on what about the ApeCoin community?
Yeah, so I think ApeCoin's very interesting, where they're trying to do a lot of things to improve both the user and developer experience in kind of like somewhat sort of degen, very creative ways. They're working on native yield, which is of course an increasingly common conversation that we're having since Blast introduced that into the ecosystem. Another thing that we're looking at very closely is the idea of like separate gas markets for different applications. One of the big issues that a lot of teams in the gaming ecosystems face is that they have to constantly hop from like chain to chain to chain, because one chain will get saturated, gas prices will explode, and then they need to move. And so we're investigating kind of 2 potential approaches here. One of which is dedicated gas markets, or allocating a specific proportion of like the total throughput of the chain to specific applications to make sure that they at least always have kind of like a dedicated lane on the chain that they can use. And another one, which I think is going to be more impactful for long-term scaling of the ecosystem, is this idea of launching multiple different chains within an ecosystem that are all highly interoperable with each other, sort of like, I don't know, like a mini sort of super chain between all of these different chains with really, really strong interop properties that allows assets to move across them really quickly. And that'll allow new teams that enter this ecosystem to rapidly spin up new chains that still feel kind of part of this one community, that don't feel like they're spinning up an entirely new thing. I think in general, when we see a lot of teams that are working on like new rollups, it's always like a bit of a balance between like highly, you can call it creative, you can call it degen protocol development. Like I think one of the really cool things about L2 is that it kind of allows you to do permissionless protocol level innovation. The tricky thing there is like making sure that those things are fundamentally sound, or at least like everything won't go to shit immediately. We work with all sorts of different teams, some of which aren't necessarily super Web3 native, who come to us with pretty fundamental questions like, why do we even need gas on the chain? And then that opens up all these other conversations around spam protection. What happens if a bunch of developers come on, a bunch of users come on? So it helps us kind of challenge a lot of our initial assumptions. We think generally we can get to a good spot where we're not too afraid of the thing going up and failing on day one. There's just a lot of very interesting innovations happening.
I think just a follow-up question for both ENS and maybe Ape and other communities. What's the decision-making cycle? How early do people start thinking about it? How long how close do you think a decision is even made? Because it's it's a community.
Yeah, in our case, I think we start looking into layer 2 area back in 2020. I think Vitalik wrote a blog post called is it roll-up centric thing? And I think initially that dictates it coming up with our current EIP 368 framework. That was about 3 months period. We had a monthly call, and we invited people from ZK Sync, Arbitrum, Optimism, and Vitalik came a couple of times. And that was a pre-DAO moment. So it was very, very small community. It was easy to make a decision. So I'm from ENS Lab, which is a company responsible for launching the initial protocol and the DAO as well. But last November, community presented now DAO is there, you need to decentralize the development process as well. So we actually have a so-called service providers that I think allocated 2 or 3 million to 7 different players, and there's some will get grants of 100K to 700K. So some team is big and some team is small. So they also needs to be involved in the decision-making system. So I think around March, when we have the ISO Global London, there's a lot of community member came to talk to us, and that kind of actually we were thinking about going to L2, but they also really pushed the boundary of we should really go for a layer 2. So right after that, we did a series of intense session to basically coming up with ENS v2, which published I think back in May. And again, last Monday we just had a meeting, and I made sure I invite all the service provider. So final decision making will probably become some sort of DAO governance voting, because there are certain things we need to switch the contract. So that needs it. And most of the I think key thing. There's the 2 things. First, it requires all these applications to switch to the new endpoint. That doesn't require DAO governance vote, but we just have to talk to all the wallets and the services to go. That's kind of, it's not governance, but then there are certain contracts to change that require DAO governance. No, we don't have the timeline yet, but probably we don't want to spend 3 to 5 years. So it should, some sort of the decision will come in hopefully in a year time, I think.
Yeah, I think so. For us, it's honestly been quite similar. Dealing with very decentralized organizations, it's always a very unique, interesting challenge / opportunity. I think for us, we've seen the most important thing is to have people in the discussions that represent all the different interests, including the kind of fundamental interests in the technical soundness of the protocol. But for us, it's really about making sure, for organizations where there is a strong token holder community, they feel very heard, they feel understood, and they feel really excited about the direction the protocol is going. Then of course, users and developers in the community also need to feel very excited, feel like they're heard, and also hopefully get their ideas in. And then we also found it's definitely very, very important to have someone to kind of act as the face of the idea to the community. Communicating fundamental protocol upgrades is always very hard. The decision to move to your own L2 or build an L2 is probably often case the most impactful important architectural decision that like any protocol will ever make. And so it's very, very important that someone who really understands the community can like very easily and strongly communicate the rationale for this and how it'll benefit everybody in the community in order to get everybody on board. Because what you absolutely don't want is any sort of like fragmentation of the community or strong disagreements about the new direction.
Yep. Issa, you've been quiet. So Mass has some of the coolest products in our decentralized world. Like, why not an L2 already?
Oh yeah, we're building that now.
Oh,
Thanks
oops.
for mentioning that. But yeah, we haven't announced it, but we're actively researching and then building our own L2 very soon. Yeah, I should have said that, but yeah, it's okay. It's okay. But yeah, I mean, like the reason why we built this like a new L2 just for it's like more like optimizations for social is basically because like we thought it is time. Back in like the days like 4 to 5 years ago, we built like a mask. We just want to build 12 users to have a better experience on the social media, on the major social networks. And then we built a lot of like different toolkits for them so that they can just protect their privacy or have a better enhanced like experience on these like platforms. But now we just like actively think for the users. So our like design model is pretty easy. So we just like we think we need to build something for the users from the user side, not from the developer side, not from the protocol like issuer side. It's more like on users. So we just want to bring. So the sole thing we want to do is like bring more people to blockchain, especially in the social way. So we want to build. For example, gasless transactions for sure, and then we also want to like say, hey, I'm not sure if you guys know like Keybase, but back in 2014, 2015 when they launched Keybase, you can actually send encrypted messages on everyone, every single person, as long as they have a Twitter handle or like have a email address. Basically, just like bringing these people into the game is the most important, one of the most important things to do. And also, we want to like allow people to send tokens to anyone you know, maybe your mom, your grandparents. But it's seemingly like quite impossible right now because like you cannot send tokens to some like a non-existent address. So we are building something that we can just like map all the like unique identifier on some like, domain name, and then send the token to that. And then if you can just bring a DKP to prove like you're the owner of that account or that like a domain address, you can just like, claim and then just transfer the token out. So basically, we just want to build something to like to allow people to use crypto more easily. And then I think we are running out of time, but I did have a like talk in ECC back in, can't remember, 2 days ago, and then I do have the slides for that. So if you guys are interested, I have a detailed like a design for that. But basically, yeah, our design model is pretty simple, just built for the users, and make it easier for them to get on board.
That's cool. Well, you're right, we're almost out of time, but before we go out of time, very rapid round of response. Will you become base rollup or not? Let's go.
No comment.
We're thinking about it.
Yeah, also thinking about it.
Okay, DK.
I mean, Ethereum should become a based rollup on top of XRP.
Absolutely.
Okay, well, okay. Another round of. So I asked each of you to think about 3 most important asks. I'm gonna ask you to just think of one. So what is the one thing that the base layer can do for your project in the next 3 years?
Love Uniswap more deeply. Like, just give us a little appreciation, a little love, That would be great, because it helps all the users.
So what L1 can do, not L2?
L1.
L1. Not really. Well, just be secure, I guess. Yeah. Don't get hacked.
Yeah, that was mine. I would also say let's try to keep DA and settlement as cheap as possible.
Just like store the most important information data on L1, please. Just don't spam it.
Yeah. Let's see, what should L1 do to like better accomplish, I guess, my goals? I mean, I don't know, just like minimize the risk that it turns into a centralization dystopia.
Yeah, I think basically be the best possible settlement layer, facilitate basically a maximally secure and scalable layer 2 ecosystem as best as possible.
Cool.
While
Well,
still being useful by Uniswap directly, you know?
all right. Well, thank you so much for great panel. I think we have another panel coming up, which is, I think the second panel is going to be Ethan. And Dave Ocha. Yes, you're also on this one. And Ken, I figured that you are the most well-versed in this. All right, well, we have a short panel this time. We'll make it 20 minutes. But Ethan, great talk.
Thank you.
And good to see you again, Dave. So yeah, so this panel, we're seeing application rollups. It's a Cambridge explosion of it on Ethereum. It sounds familiar, right? Wasn't there like an app chain thesis somewhere by some chain a while ago? So how's it going though?
Well, we're hurting for liquidity, but it's going. But once we defund the dealers, yeah, I mean, I think we're still seeing a lot of like the premier innovation happening on Cosmos chains. I mean, Celestia is built on Cosmos, Penumbra, Anoma. You've got a lot of other, like anywhere, DYDX, anywhere where you really need like, explosive power and you want to enable application developers to have as much control as possible over the consensus, the kind of Cosmos stack enables that, right? And so that's still happening, but we'd love to see more kind of integration and sort of back and forth with the Ethereum community. I think we've both learned a lot from each other, and that's kind of pushing the whole space forward.
Okay, I don't know where to go from here. I think kind of the big difference in my head is what's being prioritized. Like, I think at some state this is very convergent designs. But I think in Cosmos right now, one of our main focuses is like decentralized consensus, or like how you can get short-term decentralized inclusion commitments, or get your validators to do more to reduce like reliability concerns. But I don't know, lots of shared learnings, like how do you get fast inclusion times with pre-comps and stuff. I don't know. Not sure where to go from. What's the prompt?
What was the prompt again?
Well,
how's it going?
Exactly.
I want to raise attention to the fact that like we all have very appropriate names. Like I'm Vitalik, and I care about not dying. You're a dev named Dev. You're an Ethereum adjacent person named Ethan, and you're Ken Next Generation, and you have the there's the alternative thing. So yeah. So, okay. So what's the prompt again?
Well, the prompt is that how can we learn from the app chain thesis, however it's going, yesterday or right now, and what are some of the lessons and what are some of the things that are distinct that we should think about?
I mean, I feel like there's like different use cases of like what a chain is, and like I think a lot of the time, like not definitely far from all the time, but a significant fraction of the time, what people are looking for is like basically a branded shard, right? And like a lot of the time, when people tell me they want to, switch to doing their own being on their own L2. One of the sometimes the reason is like like they wants to have like some level of like Ethereum ecosystem wide neutrality, but a lot of the time the answer is just like they don't want to be subjected to other people's gas spikes, and so they like they're fine with like having like if Ethereum did not have like that economic property, or it did have some kind of like fee market that was like application by application, like they would be totally fine. But like that's a specific problem, and so like they're okay with just having like a cookie cutter L2 that's like exactly the same tech wise as like 100 other L2s that are running the same software. They just like wants to have that gas independence.
I mean, I imagine at some scale when, like, for DeFi applications, they'll care about things like MEV or decentralized inclusion. Like, all right, I hope we dream of this world where it's not all centralized rollups, where you have like one person gets rights over censoring people.
Do you prefer
short-term rights?
Do you prefer like L2 decentralized sequencers or based rollups?
L2 decentralized sequencers, in my view, like, I think you want them to go faster. Like. Why don't we? What's the minimum time you need for like sharing data? One internet global round trip for like one person to one validator to tell everyone else something. So for your L1 design, especially with Ethereum, you don't want to parameterize that world, but you would like to give block data from many proposers that quickly, as quick as like speed of light lets you.
Please.
Oh, my mic is dead. I can't talk. Oh, jeez. Yeah, I guess for Uniswap, it's sort of just figuring out. Or actually, sorry, let's walk back here. Uniswap is deployed on many L2s as well as Ethereum. There is no app chain Uniswap. But hypothetically, if we were to explore something, I think it's honestly just a battle of trade-offs, right? Like, we love Ethereum, obviously. Like, there's just so much lore behind Uniswap's just origin. Yeah, but there's like the whole goal of making Uniswap, I guess, more useful is to make it easier on users, and just like letting there be more composability. Obviously, security is top of mind. We want censorship resistance, right? We don't want anyone shut out from being able to use Uniswap and all facets of it. And we want to be able to have like full modularity, right? We want people to be able to like have interop, have composability, and kind of all plug into like what, I guess like the like North Star of like fully what Uniswap can accomplish, unburdened by what has been. Thank you for laughing.
I mean, so what's the concern of being your own app chain? Like, I shouldn't follow this. Like, what's the downside? You can get security via Ethereum via like restaking or So I actually didn't follow. What was the concern side?
Well, it's not really a concern. It's just like I think everything that we, if we were to explore this, right, everything would come with its own trade-offs, right? We're either breaking modularity, breaking censorship resistance, or I guess hopefully not ever, in terms of decentralization. But also, like, what are we actually doing for users, right? So, like for us, it's really thinking about how we're creating the best surface area for access for all users. Yeah. And I think that's a really tough thing to say because I'm using this magic wand of just like all users being like every person in the world. But realistically, that's not, we're not actually, we can't actually touch everyone in the world, but we can try. Mm-hmm. And it's really tough to do that when you do have these like, sort of like pockets of I guess, app chain choices. Yeah, and I guess like we just like have not made a decision. We're thinking and we're exploring, but it's all like a research question of like, how do we actually do it in the best way that's most meaningful and most impactful for our users?
But how do you feel that app chain fragmentation is distinct from like L2 fragmentation from the user's perspective?
Yeah, so I guess like that's a really good question. There already exists like so much static friction on like how users are going to onboard to L2s that it's like, I guess we're kind of if we were to think about like Cosmos, it would be kind of like, how do we now like make a hard right and like shift and do it? And you've seen this with DYDX, and you've seen this with others. And again, like no disrespect, love these guys. But it is like way harder to kind of recreate that mode, to kind of like get the activation energy to move everyone over, to kind of have these users and to have composability. Maybe DYDX doesn't need composability the same way that Uniswap does, but a lot of what makes Uniswap so special and so powerful is being able to tap into everything else. Right, it's being able to like use the liquidity for everything else on Ethereum, and being able to kind of leverage all of the assets, the users, and the order flow.
For order flow concerns, like if it's from the Uniswap UI, it seems like the end state's going to be you place a intent on wherever something on chain from wherever the user is, and then someone competes to fill it as like quickly as possible, and more so than. And then you just have some challenge period equipment times. I don't see how an app chain differs here. Like if you have somewhere to sequence all intents really quickly to make a decentralized competition to fill before whatever L2's block time, L2 they're on confirms. Or maybe to, step back. Like I actually don't see how user fragmentation's changing if there's an app chain to coordinate versus, you want some coordination layer that's very fast and decentralized inclusion. And it doesn't matter if one rollup gives that to you, if you weren't worried about block space. Otherwise, you can have your app chain do this.
Yeah, I mean, I had an experience recently, which I think is worth plugging here, when I bought a NFT on Stargaze using atoms that were on the Cosmos Hub. And so with one transaction from the Stargaze front end, I signed one time. It took my atoms from the Cosmos Hub, transferred them to Osmosis, swapped them for stars, sent them over back to Stargaze, and bought the NFT. So that's like multiple chains, multiple actions, multiple applications, all in one transaction signed, right? So the user doesn't have to care. They happen to have assets somewhere, but it was just like nice. I mean, if you haven't tried this, I really recommend you should. This is what can be the user experience. So it feels like whether it's kind of L2 or an app chain, like we can solve that kind of problem with, like you were saying, like the right simple front end for the user, and then what's happening under the hood they shouldn't have to be exposed to.
No.
No, okay. The mic is dead again, so I can't respond. Kidding. Okay, all right. All right. So there's two different things here, right? You're talking about the user experience. You're talking about actually liquidity. Those are two different things, right? Because you're saying that for the front end flow, everything is kind of moving off chain, which is kind of like the panel right before this is what I kind of poked Vitalik and Ansgar about, right? Liquidity moves off chain, which means that it's no longer like on any chains. It's private market makers being able to fill that. That is a different fundamental issue. Yeah.
Oh, okay. Actually, do you think that's fundamental? I actually would guess.
I do think so. Because like right now, liquidity, there's a lot of liquidity that exists on chain, and what you're saying right now is like if you're filling intents, then you're letting people kind of fill orders from anywhere, right? It can be on chain, it can be off chain, and I will sort of caveat all of this by saying that Uniswap X is only like a very small subset of like the giant market share that makes up like DeFi and even like Uniswap transactions. But again, liquidity moving off chain is inherently sort of something that can like be applicable for Cosmos chains as well, for app chains. And so it does kind of allow us to kind of plug back into this. And I guess I'm not saying that we're committed to one or the other. I think I'm just saying that there are trade-offs here. And I honestly, shout out to Barry from Skip. I've learned so much about what's happening on Osmosis, this LP backrunning stuff, decentralized block building. It's fucking sick.
Thanks. I guess I don't know. Do you want to talk about the liquidity? Is liquidity going off chain? Because this one actually feels surprising to me. I feel like you'd get similar to centralized exchanges. You have some order book already there, and why do you post early? Because you have a first in first out mechanism of people who post things that the market can parameterize off of get to be executed first. So you get this advantage for revealing what your preference is earlier on. And so you want somewhere to coordinate that. The reason I was saying, what I was mentioning with intents was more so that suppose you have one place for people to coordinate whatever they want to be publicly visible. Then you can have intents that are parameterized such that you will get at least as good of a price as, say, Dex app chain. Or the intent gives you filler gives you a better price. But if it's not as, if your price you get is worse, then it would fall back to you oracle into what is a DEX chain, and you oracle, any intent pillar has to oracle into what's the DEX chain would give you, or they could just give you that price by doing the swap there.
But also, or I could be on a based rollup and tap into Aave, some Aave vaults and be able to leverage long my position on optimism, or sorry, on a based rollup where I'm able to kind of use my LP in a more capital efficient way. Right? It's these are all trade-offs, and I'm kind of throwing it out there.
Yeah, true. And the base rollups, you had, the only downside of the base rollup is just what is L1 block time and fee market for DA. Maybe that you have to coordinate on that. Or I guess also, what is the inclusion trade-off? What's your inclusion guarantees you can give users?
Yeah, so I think we clearly immediately fell down the rabbit hole of two DEXs who kind of care about similar things, like intents, and how that's executed. But our Ethan and Vitalik seems bored. So, I think one of the main differences between the two ecosystems, is the sovereignty aspect of application specific. Well, let's set aside whatever sovereignty means, but application specific kind of chains do have their benefit, but what's the downside?
I think a lot of it depends on what level of application specificness you go, right? Because if you have a branded shard, then basically the only downside is you lose synchronous composability, and in the short term you also lose you get a bunch of other UX annoyances that are basically temporary because the wallets still haven't implemented very basic stuff like making the chain ID part of the address. But that's just a UX problem that is going to get solved, right? And so once that's in the limit basically, synchronous composability I think is the only thing that you give up, and then the async. It doesn't even need to be it can even be faster than Ethereum speed async. It can be async, speed at the order of what happens within some of these sub ecosystems. If you try going more application specific, that in the sense of give up the EVM and make application specific logic and so on, then you lose more because you lose access to things like Etherscan and a whole bunch of testing and understanding the chain infrastructure. You might have to figure out a custom light client if you want people to trustlessly access the chain and so on and so forth. And then at some point, if you decide to change the cryptography, then obviously you lose EOAs. Though I'm all in favor of losing EOAs and accelerating the transition to smart contract wallets. I view it as a concentric circle thing, right? It's basically, how serious are you actually taking the be your own chain thing, right? And there's an entire spectrum from basically, being a branded shard to basically just having a server that publishes Merkle roots to Ethereum with proofs once in a while.
Yeah, I think that's right. The main downside of having application-specific chains is that they don't necessarily compose, and they might have different tools and different infrastructure. In Cosmos, we've tried to build a lot of the pieces so that you can use the same tools to access many different chains. You MintScan, for instance, can access pretty much all the chains, but some of them are building their own application-specific state machines, and so that starts to get more challenging. And then we make we talk a big talk about application-specific chains, but then a lot of them start to add virtual machines to them, right? And so then the surface area starts to increase again. But I think ultimately it comes down to that, expression of sovereignty and, having communities focus on specific cultures and building the network that makes the most sense for that. And Vitalik wrote a post about this, not that long ago, about L2s as cultural extensions of Ethereum and allowing the sort of, cultural innovation to happen on different L2s. That was sort of the thing Cosmos was all about kind of from the beginning, is that expression of sovereignty, but also with interoperability baked in. Whereas on the Ethereum side, you have this kind of alignment baked in, their cultural, sub-expressions of the Ethereum ethos, and maybe arguably one of the downsides in the Cosmos ecosystem is that overemphasis on sovereignty can lead to, fragmentation and sort of like more infighting to some extent, and so that's something we're trying to address a little bit by bringing people back together around the Cosmos hub, making the hub the best place to launch a chain. But there's still a lot of very powerful ecosystems, independent ecosystems built that they don't necessarily emphasize the Cosmos branding. You've got like Barachain and DYDX, and even Polygon actually has Cosmos tech under the hood, but you might not know it. So probably a lot of Ethereum rollups would benefit tremendously from adopting the Cosmos stack, from adopting Comet BFT and IBC and so on. Sometimes I feel like a lot of the ETH ecosystem's best ideas come from Cosmos, and all of our cryptography comes from Ethereum. So there's a good,
but I mean, that's a
cross-pollination.
I mean, like I think everyone everyone appreciates I think the great products and especially SDK. Everyone uses it, right? But the thing is, like, do you not feel like you need to accrue something? Like, is it not painful to kind of look at the hub or look at the Atom wanting to do more?
Yeah, I mean, there's an irony here in that, like, the sovereignty, Vitalik mentioned, like, not being subject to other people's gas prices, right? We kind of took it further. It's like, we don't want to enforce any political economic constraint on you, right? It's just technology, you'll be interoperable, you can build your own thing, right? And so that attracted a lot of people because it sort of made it their own. They could, brand however. But it also has arguably led to these issues of fragmentation. And so part of how we're correcting that now is sort of, leading this kind of reconvergence around the hubs, a number of chains kind of coming back to the hub and thinking about how to actually launch or adopt the hub's validator set. I mean, part of the thing about the hub is it didn't really have a development team for like 5 years, right? And so there's sort of like history that's important to this as well that we don't really have to get into, but there's trade-offs in sovereignty, and I think sovereignty is expensive, and Cosmos chains have been reckoning with that as well. But we'll probably see similar struggles kind of emerge among L2s to some extent. But having the aligned base layer, having the aligned ETH token has obviously been incredibly valuable for the Ethereum ecosystem, and it's something maybe we wish we had more of in Cosmos.
Yeah. Something I think is interesting here, though, is like I think L2s and app chains are roughly the same problem, but L2s are I feel like branded as Ethereum focused. I think fast forward a few years, you'll start having like in Cosmos we're thinking about how do you make cross chain standards to like have one chain's cultural policies benefit everyone else. Like if one chain cares about censorship resistance, let's make a bridge standard on IBC to make that make both Osmosis and the hub boost each other's censorship resistance by updating IBC. I think we'll start getting something similar in rollups or like the L2 space eventually when once it's not like rollups mean DA posted to Ethereum, but DA posted to maybe a couple layers, and it's like a full node property of what they care about. But you can start getting more, just more cross rollup properties for, or cross L2 properties for boosting each other's like guarantees. Mesh censorship security is like a thing in Cosmos that's similar to eigenlayer restaking, but not focused on just using ETH as a restaking token, but having kind of each of these chains restake on each other, but also make in-protocol limits. So like Osmosis can have some like bounded relation with the hub of where we want like maybe 20% security shared, and independently have 20% of security up to 20% come from Ethereum restaking. And I think there's been many posts on the topic of like how restaking affects the base layer. But now by putting this in protocol in like Cosmos stack, we can start, or in not stack, just like how people think about it. We can start having protocols reason about to what extent they want to overlap with other chains or other ecosystems, and get all the benefits better explore the trade-off space between how tied they are to any other one chain, and also be tied to many other ones. Like imagine Optimism and Arbitrum app chains being dependent on each other. Like if two apps just share a lot of users and stuff.
Well,
You're
not
being
quite.
censored.
Yeah, exactly. Okay, I think we're okay. Last question. Again, this is to the two of you. So, what when you launch a chain, when do you tell someone else to launch something on you, and when do you, just tell them to use your actual application?
I usually tell people to start simple, like with a smart contract on Ethereum, and if once they find product market fit, or if they need a more advanced control over the consensus, or the MEV prevention, or the gas, or whatever, they can move off either to a roll up or to a Cosmos chain. I mean, I think the path DYDX took is kind of maybe archetypal of how this should go. Start as a smart contract. If you hit limits, you move on to a roll-up. If you hit limits, you move on to your own sovereign app chain.
I'd agree with this. I think that start as a contract where it's easier to deploy and closest to the people you think would be your users, and then scale up to like having more complex bridge protocols or async composability with other.
Maybe more specific. The question is like, do you try to lock them in through like into your own ecosystem, like as an app chain?
I think you try to. I think app chains try to offer like protocols building on them like something convenient, like maybe DevUX things of Osmosis offers you some compelling things as a base layer, like validators provide oracles for you in a very reliable manner, or send like MEV resistance or something. But I think the lock-in, there's no intention of locking them in. I think everyone should feel like they can, once you are big enough, you should become your own app chain. I think is the ultimate. It depends on what you're doing, but if your base layers can't scale for you or don't meet your own needs, then yeah, I think the eventuality is you become your own app chain. Or if your community grows big enough and you have some community values that you want to enforce, take a more sovereign stance. If you care about geo distribution, make a chain that lets you enforce your geo distribution preferences.
Or sometimes make a thing that's not a chain, right? So like the Farcaster CRD2.
Yeah, we don't need blockchains for most of the very cool things, very cool impacts we want.
Well said. All right, on that note, thank you for a great panel. And Vitalik, you're up next.
Okay. But thanks to your note on it's overrated, by people and underrated by the community. It changed the world,
Okay,
and
cool.
suddenly
Okay, everybody, there is lunch being served outside, but please stay in here for Vitalik's keynote talk as well.
We don't vote on the blockchain. It's too heavy.
Right.
It's decentralized by encryption.
Right.
It's decentralized. So with all the artifacts.
Right, but I mean like for what users?
Citizen participation.
Okay.
UN, all the NGOs for the COPs.
Oh, okay, wow.
So they have people represented at the COPs.
Oh, wow, okay. That's
And we do a lot of
impressive.
companies as well just to get funding. So
Okay, well, what's the name of your thing? Okay, hold on. Elect this. Okay.
how can I send you by email something, because we have some specific questions on the chain and maybe we have someone.
Yeah, v5@Buterin.com.
Sorry, V5
At my last name.
V5 at
My last name.com.
Okay, perfect. Do you mind if we just make little pictures of our
Yeah,
booths?
sure.
You're gonna love it.
Sure.
Sorry.
Okay.
Thank you.
Yeah. Okay.
Well, you're throwing us off the stage?
Okay. Okay. Oh, yes, I do, yeah. Okay. Yeah, okay. Hmm.
Who knows Windows and can show a PDF?
I mean, I look out of Windows every day. Yeah. Yeah, it's interesting. Like, I look out of windows more often than I eat apples, and more often than I look at penguins. But my like operating system use goes in the opposite direction.
Let's go.
I eat apples. And then I like it. Okay, yeah. So this is some of like my impression of like how the way in which dApps use Ethereum and the way in which the way like the kind of value that the Ethereum L1 in particular provides to dApps has changed over the last 10 years, right? So I think to start off, I have this. There's this interesting table from a post I wrote about a few months ago, right? That's basically titled like, "Ethereum has blobs. What do we do now?" Right? And the point of that post was to basically say that, look, we actually have scalable layer 2s now. Transaction fees on layer 2s are consistently less than 1 cent. And basically, who here remembers like Bitcoin maximalist people on Twitter, like saying Ethereum is never going to scale? Who here remembers them like basically, hearing me saying that the Internet of Money should not cost 5 cents a transaction and like basically acting like that's an argument against Ethereum? Who here remembers them saying Ethereum is never going to switch to proof of stake? So since then, we have switched to proof of stake. We've switched to full proof of stake, and now we actually have like functioning layer 2 scaling. And now, as of a month ago, both Optimism and Arbitrum are at stage 1, and so they are not just multisigs, and they're at least halfway there to being fully trustless. And some of them are at least saying that they'll get to being like fully trustless pretty soon, right? So I think that's like the next milestone, right? The next milestone is like, a lot of them, they say like only a few months, and then we'll get to stage 2. Anytime someone says something that involves a timeline, you multiply it by 3, unless it involves ZK, Synarchs, or AI capabilities, in which case apparently you divide it by 3. But basically, yeah. The next milestone is like you actually like have actual like peer DOS, so we have like actual DAS for the blobs. Then you have stage 2, so we have like actual full trustlessness for the rollups, right? But when that's coming, then all the critics are going to go away, right, Justin? Okay, that's fine. Hopefully your phone is an ETH phone. We have to actually use our stuff, but the point is, right, that like the way that now that we've hit this like important milestone, it's really important to like really think through like how we actually use Ethereum and like basically really make sure that everything that we're building now like actually does like fit this the paradigm that really makes sense going forward into the next decade, right? And so, like basically, from an architecture perspective, 2010's Ethereum, you build everything on L1, right? 2020's Ethereum, you can either build on a specific L2, or which could even be your own L2 if you want, or you can architect the application in such a way that it supports every L2 that follows some set of standards, right? So, in the case of ENS, for example, basically, they are going to get on their own L2, and then they also are supporting the like CCIP-based approach, which actually like basically lets you have like subdomains on layer 2s. So for like these are kind of the techniques that make sense, right? Privacy. So back in 2014 and 2015, everything is public, and I think this was like the tail end of the era where like people are like saying like privacy is dead and like we're not supposed to care about privacy. I still remember actually. I think even like visiting like some kind of like like traditional web conference in like Shenzhen somewhere, and there were like even speakers on stage even like in 2018 basically saying hey the privacy thing is dead. And I think these days, especially within this space, it's become more and more understood that like some kind of control over like where the information is flowing is like pretty much mandatory. And so the question now is like basically like how do we actually engineer it? How do we get that actually adopted? So basically, the new paradigm is that that we're trying to build toward is like a user's data is private by default, and when you disclose data, you should disclose the data that you need to disclose in order to satisfy some particular purpose. Now, this also involves like a lot of changes to infrastructure. Like it involves a lot of different conceptual changes, right? Because there were lots of dApps in the 2010s that were basically just like dumping everything on chain just in case. They were just dumping more things on chain, like basically just for user convenience purposes, right? And that's in this kind of context, like not really acceptable anymore, right? And for a wallet, for example, like you have to think about not just your key store, but also like where you're going to store like nullifiers and like encrypted values and hashes and like various other things that you have to, like pieces of data that you have to hold on to in order to be able to use your assets. Sybil resistance, so in the 2010s, you must have 0.01 ETH. And then these days, there's like more of a zoo of different approaches. So you can require an ETH deposit. And then you have clients that are offering like wrappers to non-crypto users. And like basically, you have these like centralized wrappers that provide some kind of centralized anti-Sybil in order to reach those users where like that's what they have and they don't have crypto yet. Wallets, so 2010's externally owned accounts, and then these days, you have account abstraction wallets, and then within account abstraction wallets, you have, key recovery, different kinds of access control for different kinds of security levels, sponsored transactions, and blah, blah, blah. And then proof of, community membership, basically, we have, I think, at the beginning, we basically had nothing because like we basically only had ETH, right? But then you started to have things like token gated stuff, and then you're starting to have airdrops, and then for airdrops, you're trying to like figure out like who actually deserves like some claim in an airdrop based on more complicated criteria, and so that's also turning into a more complicated zoo, right? So there's like lots of things that are turning into these ecosystems where there's like a lot more options, and it's more complex, but also at the same time like more powerful, and a lot of the time like responds to a lot of the challenges that we've come to understand over the last few years. So what does this all mean for applications, right? Basically, for applications, one question is, like, where do you build, right? Are you building on L1, on L2, on something that's not a chain? How do you interoperate with other applications? How do you interoperate with infrastructure? Like, what does composability mean? And like, I think there's like this mentality often that like composability means synchronous composability, but I think like over 80% of the time, like what you can, the thing that you want out of composability can be satisfied perfectly asynchronously. And then, there's definitely like even like sub ecosystems where they basically have been arguing for a long time that like, well, actually everything should be asynchronous, and like that's like good for parallelization and so on. So we can look at a specific example, right? I generally think like at some point you have to like stop talking about generalities, and like at some point you have to like talk about specific things just to make sure you're actually like talking about something that makes sense for anyone at all. So specific example, right? Let's do Twitter on Ethereum. 2015, there was this thing called EtherTweet. It was one of the very first applications. I mean, I think it came like actually, like very soon after some of the like really fun stuff that happened like very early on. Like, who here remembers in 2015 Ethereum, we had these contracts that were like, like provably fair Ponzi's, where like basically, you put like one ETH in, and then you join a list, and then whenever, like the 2nth person joins, the nth like with 1 ETH, the nth person gets like 1.9 ETH out. Like, remember this stuff like back in 2015? This was like a little bit after that, we started getting Twitter on Ethereum, right? And I think this makes a lot of sense, right? Because there's, I think it makes even actually more sense now than it did then, right? Because then we were still in this era where decentralization was this like very theoretical thing, but now, if you want to ask the question, like, what's the point of Twitter being decentralized and not being controlled by a single actor, company, nation state, whatever? There's like the answer is it's just like abstract ideology. There's like very specific examples over the last couple of years that you can point to, right? But so EtherTweet was. Basically, it was like basically a demo. And then here you have, Firefly, also, like built by Mask. And Firefly is like this really amazing client that's simultaneously a client of Farcaster and Lens and Twitter itself. And so, you can do things like multi-post. So, whenever you see me tweet out a blog post and then it gets tweeted on Twitter and Farcaster and Lens at the same time, this is what I use. And at the same time, it's like actually a good client, right? And like the UX, actually looks really nice and it looks Web 2 competitive, right? So let's talk about some under the hood technical differences between these two things, right? So where does user account stuff go? On EtherTweet, it's just Ethereum L1. On Firefly, Optimism. Where do tweets go? On EtherTweet, Ethereum L1. On Firefly, they have this structure called a CRDT, which is not technically a blockchain. It does replication, but it does not have any guarantees on order. And they've designed their application so that it doesn't need any kind of consensus on order. And then there's also an anti-denial of service piece, basically, the thing that I called proof of stake hashcash on ETH Research on some occasions, and that's part of the user account stuff. Farcaster frames, so EtherTweet did not have this, and in Firefly, it's on servers. So how do non-crypto users get served, right? So EtherTweet, there isn't really any way to do it at all. If you want to if you're a non-crypto user and you want to start using EtherTweet, you'd have to both start using EtherTweet and you'd also have to start using an Ethereum wallet, right? And so the initial bump in of UX costs to even get into an application was just higher because you had to get into these two separate things. And Warpcast kind of acts as a wrapper, right? So basically, with Warpcast, it basically sets up your own account, and so it also basically at the same time kind of implicitly does this kind of higher convenience, lower security key thing. And then for the account recovery, by default it's Warpcast, or you can set it to your own Ethereum address, and Warpcast has an option for how to do that, and that's what I did. And so I got my 4 out of 6 Gnosis safe, and I can call it a Gnosis safe because I created it before they rebranded, and I think I haven't upgraded yet. The 4 out of 6 Gnosis safe that actually, serves that is the thing that actually does the recovery. And honestly, I trust that more than Web 2 recovery, right? With Web 2 recovery, it's okay, I have my account, and then with my account, it's my Gmail accounts, right? Basically, at some points, I actually did not even do anything wrong. I did not even forget my password. But at some point, they just said, okay, password's not good enough. We need to confirm your phone number. And then they asked to confirm some phone number from 5 years ago that I just don't even have control over anymore. And then, they don't have any kind of other way to get your account back, and so I'm screwed, right? So, this is part of the reason why, I show social recovery everywhere, right? Because, I actually think it's better than, not just the decentralized stuff, but the centralized stuff. So, these are the differences, right? So, basically, a big part of it is, Firefly just does more stuff in order to fill a larger set of users' needs in order to, actually be competitive with, and, often super competitive with, existing Web 2 applications. And there's just more infrastructure that needs to exist in order to make that possible. So how apps handle user accounts, this is one of those big changes, right? So 2015, kind of, like bring your own Web3 wallet only. 2021, I think I definitely saw some applications that were basically saying like, oh, we're going to be mainstream applications, and then we're going to, like do sign in with social. And like this made me like completely die in my heart, because like, no, the point isn't to build Web3 on social. The point is for Web3 to replace the social. But Right, but like the thing that they were getting at, right, is basically trying to like get existing like users and like basically help existing users join the application in a way that's like not super fragile, right? Because if you just like store a private key, like inside of browser local storage or whatever, that's like too easy to lose, right? And so like a lot, like I saw some of that in 2021. These days in 2024, I'm seeing this like very welcome shift toward figuring out a way to support both, right? And I think like Farcaster is a good example of this, right? Basically, if you just use Warpcast, then like by default, it just feels like a traditional Web 2 app, but then you also like it does offer this way for you to kind of upgrade yourself into like actually being a proper Ethereum user, right? And so like I think this is kind of an ideal best of both worlds, right? Basically, yeah, if you don't already have an Ethereum wallet, then like you should not have to download both an Ethereum wallet and an application in order to use an application. But then at the same time, like applications like should be designed in such a way that if you are already an Ethereum user, you should be able to like use the Ethereum application the Ethereum way, and like actually just benefit from the Ethereum wallet just being your root of trust, right? You should not need to have like these like 11 different roots of trust, right? And like and ideally, like have some way to pretty seamlessly switch from one to the other. So right now, this is kind of happening at the application level, and I'm hoping in a few years, once we have better account abstraction, this will even start happening like even more at the smart contract wallet level. Thinking about composability, right? So how do different dApps talk to each other? I think one of the big trends is basically that back in 2015, everything was on chain, everything would talk to everything else by making synchronous calls. In 2024, we see much more use of asynchronous, off-chain, lazy evaluated, like various hybrid methods. Airdrops are a good example of this, right? So the way airdrops used to be done is like if you do an airdrop, then like you just like basically have a bot, and your bot just like sends 100,000 transactions, and you as the airdropper pay a huge pile of gas. And then since then, the dominant paradigm basically switched to being like something like, like you have a Merkle branch, and like you just put the root on chain, and then for someone to claim, they have to claim by providing a branch, and then they pay the cost of the claim themselves. There's other things that could potentially switch over to asynchronous and off-chain methods. So oracles is one example, right? So I think right now there's like a lot of inherent inefficiency in like a lot, even like Chainlink pushing data to multiple L2s because it's like data redundant in a certain sense, right? And one way to solve that whole problem is basically kind of, like real-time asynchronous oracles, right? Like if you want oracle data, then like you provide it with a signature. And then the other, but then, there's a possibility of like a curveball where we actually move back to being synchronous for that sort of stuff, which is the L1 S-load, L1 synchronous call, and like that whole bubble of ideas, right? The ideas where like L2s all, or like most of the major ones just like develop the ability to make synchronous reads or calls into L1 of some kind. So some, like switches into what's happening here. So what lives on Ethereum L1, right? So in 2014 or rather in 2015, it was everything. Today, so what you have L2 root logic. In theory, you have user activity in emergencies, right? So this is like the idea that if something bad happens to an L2, users are supposed to be able to like exit and move to a different L2, right? And this hasn't really happened at scale yet, right? But this capability needs to exist in order for L2s to have good incentives. So Like that's something that L1 needs to be ready to handle, even if it's not handling it very often. High value DeFi still on L1. Key stores, so this is still in idea stage but being developed, right? This is the idea that like if you have a wallet and you like a smart contract wallet and you want your wallet to exist on lots of different L2s, then if you want to be able to upgrade it instead of having it upgraded n times on n different L2s, you just have the logic live on L1. And then staking related services. Staking, so like the various, like liquid staking DAOs and like all of that stuff. Basically, it has to live on L1 because it ultimately has to directly interact with the deposit and withdrawal system. So how do I summarize all of this, right? Basically, like dApps need to plug into this like much more heterogeneous mix of stuff. And that stuff is sometimes layer 1, sometimes it's one layer 2, sometimes it's like any layer 2, sometimes you have other systems, sometimes you have things like CRDTs, then sometimes you have things that are not even like blockchain-y or data-y things at all. So like all of the different like Oracle types. So modern standards for user experience, the desire to like actually build things that can serve like regular users in practice and not just early stage Ethereum geeks leads to demanding more of applications. And that's where a lot of these other components are starting to come in. L1 is still playing an important role, right? Like L1 still continues to have a lot of functions. And so basically, like we're moving from like the Ethereum verse as infrastructure being just the Ethereum chain to it being this kind of combination of a bunch of various stuff, right? And I think one thing that's really valuable to remember is like this has always been the vision, right? So who here remembers like this chart back from the early days and like Gavin Wood presenting the Web3 vision? Okay, so some people, right? But like basically, the early vision, this is like how Gavin would present about Ethereum back in 2014 and 2015, is like you have this concept of Web3, right? And like the idea of branding it as Web3 is basically to say we're not thinking about Ethereum as being Bitcoin, but it can do smart contracts. We're thinking about Ethereum as open source software, but it has a shared memory, right? And like these are two different frames, and like that second frame is like one that's like actually also super valuable to think about, right? And one that lends itself much more to non-financial applications. Like basically the vision there was that you'd actually have like this set of sister protocols, right? So you'd have Ethereum, which does the shared memory. Then you would have Whisper, which is just like a decentralized messaging protocol for passing messages around. And then you'd have Swarm, which does like decentralized off-chain storage and like basically like larger blobs of data that you don't need consensus over, right? And today, this is like actually both of these are starting to happen, right? So you see a lot of things that are being served on IPFS, though I think we could do a lot more to bring back Mist and like actually like verify IPFS hashes directly and all that. Whisper, so rebranded to Waku, is still being developed. It's still actually actively being used. So Status actively uses it. The live Railway client actively uses it. So like that's how your withdrawal messages make their way to the wrapper providers. So the idea of like the Ethereum blockchain being one piece of this heterogeneous stack is like a thing that's I think it's always been the idea, and like this is basically what's ended up happening. But like which specific pieces actually are like the sister protocols is something that like definitely has changed over time, and I expect that it's going to continue to keep changing.
All right, can we give another big round of applause to Vitalik for coming out? 2 panels and a keynote. Okay, up next, we have Jonah from Blockchain Capital talking about proposers and APS and understanding PBS plus designs, execution tickets versus inclusion lists and execution auctions.
Really a mouthful, right? Maybe give like a minute.
Yeah. We can take a couple. Here.
How does this work? Just like this?
I keep doing that, honestly. Yeah, you just keep that.
I know, it's so long.
I think this is great. Also, remember, this is recorded. You're talking to the world. You're not talking to the audience.
I'm not making that joke.
Yeah, that's what I was going to say. Yeah.
Okay.
The public persona.
Okay. Yeah, that's not going to be the joke. That's the one.
It would be this one most likely. Yes. Yeah. Okay, so Jonah, maybe just like a little freestyle while we kill some time as people flood to the exits. What is your position on inclusion lists? Since you're going to talk about execution tickets and execution auctions.
I actually think inclusion lists should be thought of in the context of multi-proposers. I think it's just like one instantiation of a multi-proposer design, right? So there's like Celestia's trying to work on this. Sorry, not Celestia, Cosmos people trying to work on this stuff. But MEV is deeply tied to censorship, and a lot of new MEV capture solutions kind of require no censorship or some good guarantees about inclusion. So inclusion lists are kind of the necessary, or what inclusion lists are trying to do is very necessary for a lot of these new protocols to work.
Interesting. I read a paper recently by the ATOS team, and they were talking about how, if you can have inclusion lists, you can also have exclusion lists, and how this might be an inclusion list might be more of a mechanism for censorship rather than a tool for censorship resistance.
What do you mean by that?
If a validator can say that they will include a specific transaction, they can be forced to only including a specific types of transactions, or they can also have the ability to set up, in theory, we will exclude these lists, like a censorship list.
Interesting. I think the ATHOS model is a bit different. So, I don't know what's
it was more of a research paper about
okay.
they would not than their actual specific thing.
Should I jump into the?
Yeah, we're done with the spicy.
Awesome, very spicy. Yeah. Anyways, there's something very wild about speaking after Vitalik. Like I feel deeply honored for this. So I want to begin by saying this is very wild for me. So anyways, my name's Jonah Burian. I'm an investor at Blockchain Capital, and I'm also a researcher. And as a hobby and a passion, I've begun to do a lot of MEV research in collaboration with some EF folks. And I do want to say it's really an honor as well. Like they're super inclusive. You want to try to put some work out there, you want to do some research, they like take you into the fold, they help you out with your papers. It's really a lovely community. So the topic of this talk is about protocol MEV capture and basically new mechanisms that are being designed for Ethereum itself to capture its own MEV as opposed to leaking it to proposers. So the talk's going to kind of motivate why this area of research is even interesting to begin with. Go into, I guess, the two high-level solutions that have been proposed, walk you through a couple of the trade-offs, and specifically focus on centralization trade-offs. So that's going to be the topic of the talk. So what is MEV, or where does it come from? Well, MEV is a pure function of having a monopoly on the execution payload. And what I mean by that is the execution payload is the object in Ethereum that basically you have the ordered list of state transitions, of transactions. And the ability to control that object and choose the ordering actually has more value. There's more value associated with it, namely MEV. So one of the classic examples is a sandwich attack, where if you see there's, let's say, 1,000 ETH buy, probably you want to put a transaction to buy ETH right before and sell ETH right after, right? That's a basic, the price is going to move, so I'm going to buy right before it and sell right after. But MEV is basically all these games that come with the ability to order and include. That is what MEV is. It's that value. So, everyone here is familiar with MEV, or do you need more of an explanation? Like, raise your hand if you're not familiar with MEV. Oh, this is awesome. Okay. So in today's MEV pipeline, we use PBS. And the idea here is that a validator has a one-slot monopoly on this execution payload, but they might not be sophisticated enough to exploit it or to basically milk out as much value from it as possible. So what do? They have this monopoly right. They sell it. They auction off the right to kind of use that monopoly. That is what PBS is at the highest level. I have a monopoly. I can't really exploit it, so let me auction off the right to use it, which means, in effect, where does the value of MEV flow? It ends up flowing the lion's share of it to the validator, because they hold the monopoly right, so they should, with proper mechanism design, and PBS does this, gives the validator a lion's share of the MEV reward. So in the current pipeline, there is MEV that exists on Ethereum. The fact that Ethereum turns over monopoly to the validator means that now the validator is basically able to kind of win the most amount of rewards from the MEV, and they're basically soliciting builders to do that. So that's kind of what the current pipeline looks like. By the way, I'm using Barnaby's photos from one of his articles, so I'm very thankful to him because I am not this clean at making diagrams. But what are the problems with this mechanism? So there are two big problems. The first is an allocation question, and that is, this is a normative problem. Why does MEV go to the proposers? Like, why is that the right sink? Why do they deserve the value? I think a great argument is that applications deserve the MEV, right? They produced it, they deserve it. And a lot of applications are realizing this, which is why a lot of applications are being designed to be MEV aware. So you have protocols like Sorella that are doing this for Uniswap, right, to capture Uniswap MEV, and a lot of new lending protocols are kind of thinking about this. But so applications are working on it. Future applications won't leak as much MEV, but you'd be pretty hard pressed to find someone that says there will not be MEV in the future. Like, there will always be residual MEV, and the question is, should that go to the proposers? And the answer is, it's value the protocol generates. Probably it should go to protocol holders, namely Ethereum holders. And how do you do that? You have to capture the MEV and burn it, which in effect distributes MEV pro rata to Ethereum holders. So that's the allocation problem. Like, MEV is probably not flowing to the right spot right now. Right? There's a principal agent problem, and the agent of the protocol is the proposer, and because they're an agent, they basically get to exploit this monopoly. The other problem is a centralization problem, and this is a very nuanced problem. And I want to talk about timing games briefly. So there's a really interesting work, Fahad and some others wrote on it, but the basic idea is that the longer amount of time you have to exploit MEV, the more MEV you can exploit. And in fact, MEV scales proportional to the amount of time to the power of 1.5. So monotonically increasing superlinearly, which means imagine you're a naive proposer, right? You have your execution payload, you send it out, great, you earn some MEV, amazing. But if you're sophisticated, you realize if I just wait a little bit longer to send out my block, I can actually earn more money. And it grows superlinearly. So as a result, there's this incredible game you can play, which is, why don't I invest in better networking equipment, co-locate with the testers, and send out my block at the last second I could, which makes me earn a little bit more money. And there's a nice Tim Roughgarden paper that shows that kind of these minor deltas in average APY you can make as a proposer in the long run has a centralization vector. Why? You're just earning more money. So people are able to play these games. It'll be the winners more consistently. They can bid higher and all of that. And eventually, right, it'll have a centralization vector. And not only will it be a centralization vector in terms of who's doing it, but also a geographical one, where there's actually an incentive to co-locate. So MEV in its current state, not only is there an allocation problem, but there's a deep centralization problem, and it's actually an exponential centralization problem, which is interesting. So how do we fix it? Well, the insight that MEV is a function of a monopoly and a principal agent problem can actually help us with the solution. And the best solution to solving a principal agent problem is you sell away the rights to be the agent. Exactly what PBS is doing, just one level higher in the stack. So any new MEV protocol capture solution, what they're doing is saying, what if Ethereum sold the right to proposing the execution payload? So what does that do? It does two things. Number one, it separates the act of constructing the payload from being involved in consensus, which actually fixes some of the timing game questions, though it could produce other timing games, and that's an area of research. But kind of the timing games around with proposing, you just disintermediated the execution payload constructor from the typical Ethereum validator, so it solves that problem. But what it also does If you're selling away the right to the execution payload in protocol, what you've effectively done is captured the MEV. The protocol, the same way that the proposer in the current state captures MEV, suddenly the protocol captures it. And now the protocol ends up with the MEV and they can burn it, or we can burn it, which effectively distributes MEV pro rata to Ethereum holders. So now the big question is, okay, great. So now we have this insight. There's a monopoly. We want to sell away this right in protocol that will help us capture MEV, help us avoid timing games. But there's a lot of ways to design an auction. And there's a lot of trade-offs based on how you design it. So there's been kind of two modems of thinking. Well, actually, let me start with naive auction, and then I'm going to kind of go into the two paradigms that we're kind of working with now. The naive way is just run PBS in protocol. So rather than running PBS from the proposer, you literally run PBS at the protocol level. That's called ePBS, Enshrine PBS. Unfortunately, I'm not going to get into it, but there's a lot of articles on ETH research, so if any of those who are interested, there's a lot of problems with it. There's bypassability problems, it creates weird timing games, it's not a perfect solution. So there's been really two dominant forms of solutions that have been proposed. The first is using an auction mechanism, so similar to PBS, and we call that execution auctions. And a second idea is using a lottery mechanism, which has been termed execution tickets, which is why on Twitter, if you guys see little ET pictures floating around, it's probably in reference to execution tickets, is ET. Okay, how do executions auctions work? Quite simply, what an execution auction is I am selling the right to the execution payload for 32 slots in advance. So it's like, I'm selling the right to the execution payload 32 slots in advance. So at slot K, the protocol sells the right to be the execution payload proposer in 32 slots. So it's like PBS, but your right comes in the future. And if you think about it from a game theory perspective, how much am I willing to bid for that right? Well, up to the expected MEV I can extract in that slot, which means that in this mechanism, and I get into the math a little bit later in the talk, you're basically selling expected future MEV, which means that like this asset you get or this right you get is a function of future MEV, and you're basically selling away MEV and expectation, which means you're burning MEV and expectation, which is very cool. Here's just a little diagram of, again, a Barnaby diagram. Thank you, Barnaby. Let's get to execution tickets. Execution tickets have a little bit of a different mechanism. In the steady state, there exist n tickets in a pool that people are holding. At every block, one ticket is chosen, and they become the winner of the execution payload. Their ticket is burnt, and a new one is minted and sold. So what's an execution ticket? You have a right to a future unknown block where you're going to be the one that proposes the execution payload. So how much are you willing to pay? Well, you're willing to pay the expected future MEV in an unknown block. Is basically what that asset represents. So the core difference between execution auction and execution tickets is that one uses non-determinism, one uses determinism, and one uses non-determinism. So you can like look at this slide, I guess, later. But I'm not going to bore you with the math, but if you just do some very, very basic math on this, you basically get some really clean results, which is both of these protocols, assuming a competitive environment, and this is a huge assumption, and this needs to be studied, but assuming a competitive environment should capture all MEV and expectation. So the expected future MEV that is produced by Ethereum, these protocols should be able to capture, which is very cool. And on top of that, another really nice property is an execution ticket and the right in the execution auction about equals the value of the average MEV per block, which is a nice result as well. You basically are holding on to MEV futures, which is very neat. And on top of that, when you're selling away these rights to the right holders, the variance they experience, so the variance, because they're not getting this MEV, they're getting future MEV, is about the variance of just per block MEV, which means the protocols are not really introducing too much new variance to the mix. So there will be variance discounts probably in the pricing and all of that, but at least you're not introducing too much new variance. But these results are a little bit more complicated. There's a lot of assumptions baked in there, and I wrote a paper on it. There's a bunch of papers online. A lot of people have been studying it. I'm actually putting out another paper in a couple weeks about this. But there's a lot of people have been thinking about this question. This is like super high-level illustrative results, but the core idea here is there's a monopoly. You could sell it away. There's two different mechanisms, and if you sell it away, Ethereum can actually capture its own MEV, burn it, which effectively gives MEV pro rata to Ethereum holders. So we only have a minute and a half left, so we don't really have too much time to compare each of the protocols. What we can do is compare them along one line, and that is centralization. And what I want to talk about is multi-block control. And this is a very interesting question, which is in execution auctions, you have a really weird property, which is you can guarantee buy multiple slots in a row. I can guarantee myself being a proposer for 2 slots in a row. So I can buy slot n plus 32 and then slot n plus 33. And what happens then? Like, is that a bad thing, a good thing? Like, we don't really have that today. I mean, people might win 2 slots in a row in expectation. I mean, Lido wins 2 slots in a row every single day. But to deterministically get it, that's kind of strange. So to understand and unpack that, there's a whole literature, or new literature on multi-block MEV, which is the MEV associated with the control of multiple blocks in a row. We have 42 seconds left, so we're gonna speed run this. The TLDR is multi-block MEV provides you more MEV than the sum of the 2 blocks itself. So there actually exists more MEV from controlling multiple blocks. The intuition has to do with the superlinearity. Won't get into it. But basically, if you can make more money from controlling consecutive slots, if you happen to win slot 32, you're going to be able to bid more for slot 33, and as a result, more for slot 34. So there's actually an endogenous centralization vector in this protocol, which is a very strange thing. We don't exactly have this today. And there's a whole literature on inclusion lists, which basically try to mitigate this. There's a lot of open questions. We began riffing on it at the beginning. But inclusion lists end up becoming a core new primitive that needs to be there to solve the kind of this new centralization vector. So to sum it up, I know I'm at negative 12 seconds. I'm not going to get into these diagrams, but the high level, we want to capture MEV and distribute to Ethereum holders. The current state of MEV provides a lot of problems and probably net ends up with centralization. The new in-protocol designs are meant to mitigate this and capture MEV. There's a ton of open questions. ETH Research is full of fantastic articles by very smart people. And I encourage all of you to read about it, write about it. It's really interesting, and you might get nerd sniped. So I will warn you in advance. The charts, I had to give some more context. Oh, I have 2 more minutes? Oh, damn. OK. Well, we spoke about how in execution auctions, you guarantee yourself control of consecutive slots. Well, in execution tickets, you don't. These execution tickets, the non-determinism of them actually protect you from consecutive slots guaranteed. And the reason is, like, you don't know when you're going to win a slot. And there's a kind of I made this little illustrative chart, but I guess, it's really hard to see on the screen. But the idea here is, let's pretend there's 100 tickets in the pool, OK? And you own 20 of them. So that's this little blue line over here. If you want to win If you want to win, sorry, I'm reading the chart wrong. If you own 90% of the tickets and you want to win 20 slots in a row, you have like less than a 2% chance of doing that. And this chart kind of shows you the percentage chance of like winning consecutive slots. And the answer, and like the intuition that this chart shows is even when you own a lion's share of the tickets, getting consistent consecutive control is very difficult. So the non-determinism of execution tickets actually protects a little bit from kind of native centralization vectors, which is an interesting result. So even though execution auctions are so pretty, right? They're so simple. You're just auctioning off something in 32 slots. They're like EPBS. It's great. They introduce this weird kind of endogenous centralization vector, whereas execution tickets, even though they're a little bit more complex and harder to wrap your head around, the non-determinism mitigates multi-block control in some sense, which is an interesting result because that's kind of what we see today, right? Like slots are handed out randomly, and as a result, we don't see people consistently exploiting multi-block MEV. But there's a whole nother side to this story where it actually, in today's world, people are self-limiting and purposely not exploiting multi-block MEV, even when they have the option, which is an interesting phenomena. But I think that's for a different talk. So anyways, thank you guys for hosting me. Very wild to speak after Vitalik, I have to say. And I encourage all of you to read more in this literature.
All right, that was great. We're actually going to stay on the topic of, well, all these great protocol questions. So I'm inviting up Emmanuel to come up on the stage. I'm going to pull up your slides while you get a microphone. And do you have any thoughts on execution tickets or versus execution auction?
I mean, I try to like stay away from like every research for some reason. It's no strong opinions really. It worked. Okay. Confession, this was like made very hurriedly, so forgive like how shabby it is. So what I really want to just discuss is like L2s as extensions of Ethereum. Okay. So this is like a shameless fork from Vitalik's article on the same topic. I think most people have read it. It's a really great article, and I think it came out like the right moment because you have this. It feels like we've come like roll-ups are bearing fruit. You have like so many projects. You have like 61 projects on L2Bit already. It was just like maybe 4 years ago when like the roll-up central rumor was like releasing stuff. But now roll-ups are bearing fruits. You have in layer 2s, now you have in layer 3s and like other constructions. But now like there are issues we did not really think about before. No one really sat down and said like, in a roll-up centric world, what sort of like social and technological dynamics, what sort of like dynamics come into play? But now we need to start like asking those questions because there are new problems that we need to solve. And yeah, so we've gone roll-up centric. Gas is cheap. There's more scaling. We don't have to like compromise base layer, censorship resistance or like or anything like that. But there are criticisms, there are flaws, there are weaknesses. And some of those criticisms are that you have many roll-ups, you fragment the narrative, and you leave users confused. You have some roll-ups trying to be cypherpunk, you have some roll-ups trying to be institutional friendly. Like there's so many talking points coming out, and it leaves like people confused. In contrast, you see something like Solana, for example, is just fast and cheap. And people are like, hey, that's simple, I should do that. You have roll-ups making different technical trade-offs. So you have like validiums, you have optimiums, you have some weird constructions. You have sovereign roll-ups now and stuff. You have base roll-ups, and all of that really confuses people. And it feels like Ethereum as a whole is weakened by having so many roll-ups because now Ethereum doesn't feel like as cohesive as it did before. Those are like some of the criticisms. And the issue is like roll-ups are like startups. They need to differentiate. It's a positive sum game. I wish more people treat it as a positive sum game, but it's still sort of like PvP in a sense. And that's why you have like each person trying to like differentiate and say, hey, I'm different. I'm doing something different and stuff. And yeah, so this is some of how that differentiation plays out. You have ZK saying doing like horizontal scaling. You have Mega Eighth doing like vertical scaling. And these are like two ends of the spectrum. You also have like cultural distinctions. You have ZK saying something like we want to be cypherpunk and user friendly. You have other chains like Metal. I don't know like if anyone knows Metal, but it's saying like we want to do something around like regulatory compliance and finance. There's another one doing something on like real world assets. So like many roll-ups are trying to like differentiate across technological and cultural spectrums. And that means many talking points. Many talking points. What is Ethereum in 2024? Is it Ethereum RW? Is it Cypherpunk? There is no single narrative that's coming out of the Ethereum ecosystem, and it feels like that's like a weakness. And what we've tried to do is try to frame, so Ethereum is no longer one chain, it's no longer one L1, so you cannot like, if you compare it to like BTC or Solana or like Avalanche, it's an apples to oranges comparison, because now Ethereum is its rollups, and that's what we've tried to like do so far. We do all L2s are Ethereum, Optimism Ethereum, Base is Ethereum. And this is largely true because like L2s have like strong tech and cultural ties. But the problem is rollups in a sense are not yet Ethereum yet, because like you have like these trust assumptions. They're not really extensions at the moment. And also rollups themselves are saying, no, we are changing our own rights. And it kind of like leaves even me myself, like, how can I say like Base is Ethereum if like the sequence is not like, it's just very weird position for us right now. And what we've done so far hasn't been really effective. I communicate to both users and developers that if you're using a rollup, you're using Ethereum as well. So what can we do better? And so open questions is that like, should rollups be independent culturally, or should they be subsumed into the larger Ethereum culture? Should rollups be independent technologically, or should they be tightly integrated with the larger Ethereum protocol and trade off innovation for alignment? Should rollups extend Ethereum culturally, technologically, or should they be treated as standalone chains? Because a lot of times on Twitter, you have this idea of like, why won't Arbitrum just fork away and become an L1? And those questions are becoming, they're coming more frequently, because now the Ethereum culture itself is, the social layer is very fragmented. So like, it doesn't feel like there's an Ethereum social layer anymore. Now it's like an Arbitrum social layer, an Optimism social layer and stuff. But my idea is the original rollup vision was supposed to be rollups should be extensions of Ethereum. I think the vision is for rollups and Ethereum should have like this mutually beneficial relationship. Because the truth is, if you're launching a rollup today, it costs less for you to launch a rollup than for you to launch an L1. So there's no free launch. And you're getting that, and like that means you also have to like pay forward or pay back or something like that. So you cannot like bootstrap social capital from the community and then say, oh well, we bootstrap the social. I mean, because like right now rollups, we've sort of like tolerated rollups being centralized because we believe they're like the long term. So you cannot get all of that social capital and then say, hey, you know what? I'm just gonna like fuck away and become my L1. It doesn't make sense and stuff. So I feel like the end game should be rollups and Ethereum have like a mutually beneficial relationship. Paying security fees is not tax. I know like there are people in the audience who believe like rollups is sovereign. It's not fundamentally incompatible with this. I just feel like in the end goal for us, we want Ethereum to be this base layer. So Ethereum social layer should be enough to like secure all of these rollups. That's like the idea for me. And so like, why should you be a cultural and tech extension of Ethereum? This is just like random points. But first, the idea is we want to have one Ethereum. And in fact, something I've been like trying to push is this something called United Chains of Ethereum, or the Etherverse, in the sense of Ethereum is just, again, it's not just one chain anymore. It's not like dozens of chains. And I want people to come into the Ethereum ecosystem and not see 40 different chains. They should see one Ethereum ecosystem, and that each chain is just a representative of Ethereum. And like from Vitalik's article, he says that each rollup has its own subculture, but then even within subculture, it's like they're taking part of the Ethereum culture and mixing and matching. So Ethereum is just, it's cypherpunk, Ethereum is user-friendly, and then you can just pick your own stuff and make your own subculture out of it. And lower social fragmentation. I mean, one thing at CC, you had like rollups doing this stuff, and the social fragmentation part comes from each rollup trying to be as PvP as possible. And so you have like developers coming to like each ecosystem and saying, hey, if you're going to build on our rollup, if you're going to get something from us, you have to be exclusive to us. And you're forcing people into like this very weird. They want to build multi-chain apps. They want to build on Base. They want to build on Optimism. They want to build on zkSync. But if you're fragmenting that social layer, you're creating problems for like developers and users. And also when it actually comes, so if something were to happen, for example, let's imagine like the Ethereum community needs to like fork because of one rollup. Because rollups are already in PvP mode, it becomes hard to coordinate because now we don't think of each rollup as one big happy family. We are like all competing. So it's possible like, okay, we need to like fork Ethereum because of one big rollup. And the other person's like, oh, well, no, why should you do that? So we want like lower social fragmentation. But on the tech side as well is you want like enshrined rollups are like secure against arbitrary upgrade risk and make multi-sigs unnecessary. At least this is my idea. So like I don't like going too much like too deep into like the rabbit hole, but like an enshrined rollup means like the rollup only forks. My idea is like the rollup only forks if Ethereum forks. And right now multi-sig FOD is very real, and like that's something we like talk a lot. So enshrined rollups like a very straightforward path towards making multi-sigs unnecessary and making sure like the idea that rollups as a secure and trustless scaling solution for Ethereum is really true. And you have like base rollups, they can inherit like, oh, this is me trying to like find out the benefits, but base rollups can inherit liveness from Ethereum L1. Sequential centralization is like an issue. So right now, a sequencer cannot steal your funds, but if the sequencer is going down, there's a liveness failure there, and we don't want liveness failures. And so, I mean, Justin Drake has like done great work on like getting base rollups like production and stuff. But the idea is we don't want centralized sequences. We don't want to have to trust them, because the moment we have to start trusting sequences and other off-chain actors for the function of a rollup, we start to like degrade the fact that the idea that if you're using a rollup, it should be live and safe if Ethereum is live and safe. So that's like a tech advantage of like being an association with Ethereum. Also, this is a really big point because, like I said, rollups in their original form were supposed to be extensions of Ethereum in the sense of if you take an asset to L1 to L2, you should have a guarantee that if Ethereum is operational, you should be able to take the asset back to L1. But if you have a rollup that's saying, you know what, I'm not going to be based, I'm not going to have a decentralized sequencer, then this feels like hypocrisy. And that's something like other L1 communities really capitalize on. They're like, hey, you're saying like your rollup is decentralized and it's better than an L1, but like you have multi-sigs, you have centralized sequences, you don't have permissionless validations and stuff like that. But we need this to be true. If it's not true, like in the end state, there's no way I can like defend rollups because they're just as, I won't say bad, but like as bad as L1s. So we need like that to be true. Yeah, and so like also Ethereum alignment feels like a meme, but like there are positive benefits like Ethereum's culture. There's an article, I can't remember, but I can probably link it. But what are Ethereum values? Decentralization, censorship resistance, funding public goods, transparency, permissionlessness. If you're an extension of a cultural extension of Ethereum, then you can do all of these things. And these things are good. And doing these things is not charity. It's not you just being altruistic. It's incentive compatible for you because when you do them, the community gives you social capital, and that social capital translates to financial capital for you because now developers are coming to the say, oh yes, this, it's not like people are going to like give you a rubber stamp and say, this is the community approved L2. But then we can encourage people and say, you know what, use this L2 because we care about decentralization. This rollup cares about decentralization. Use this one. So you displaying Ethereum values and you supporting Ethereum values is also a net benefit to you. And it's also a net benefit to Ethereum. So like there's this idea of it being a mutually beneficial relationship. So you have a protocol guild. L2s should be funding the protocol guild because now you're relying on L1 infrastructure. It should not just be the EF. I mean, if it's like a quarter of like your sequencer earnings and you redirect that back into like the protocol guild and fund layer 1 R&D, it helps you because if the layer 1 stops working, your L2 stops working. And like in a sense, we want to like avoid that coordination failure that comes from you extracting and not you extracting and not putting stuff back into the system. So the idea is to make this a regenerative ecosystem for everyone. And time's almost, but you have like, so this is like from Vitalik's art school, you have challenges, echo chambers, you have like monocultures, and you have like this particular idea of like the wrong vectors of competition is very important, because now you have like roll-ups, do very PvP stuff, compete for the same developers and users. I feel like we should not be doing that. Let's grow the pie, get more points to the ecosystem, not trying to like get the same airdrop farmers and the same mercenary devs. There's like, crypto is like at like, I think like maybe 5% of the world right now. So it's not like there are not that many people in the ecosystem, but like if all roll-ups came together and said, you know what, we're going to bring more users into the ecosystem, going to bring more developers into the ecosystem, it doesn't have to be so adversarial in a sense. We definitely want to avoid echo chambers. More roll-ups should like interact. I mean, you can make a different set of design choices and trade-offs. Doesn't mean like the other side is making like really bad trade-offs and stuff. I was at this modular security debate yesterday, and like Ed Filton had issues with optimism, shipping, fraud proofs, even if they had issues, and they were like, hey, we need to just ship something that works. It's different cultures, but then there's like, you can learn from each other and not have this cult mindset where like, we are the good guys, the other guys are the bad guys and stuff. And yeah, it's just this. These are like problems we need to like fix. And I think it's really good that the modular, I mean, we all know modularism is here to stay, but like we also need to like solve these things so like modularism doesn't become like Ethereum's Achilles heel. So yeah, thank you.
Thank you very much, Emmanuel. Next up, we have Tarun. Tarun, we'll get you a microphone left. And you also need to kind of answer the walking on stage questions of execution tickets or execution lottery. What's the answer?
What cryptographic assumptions can I make? Because I feel like that changes the answer quite dramatically.
That is up to you. That is.
Maybe that's my answer.
Okay.
I answered with the question. That's good enough. Yeah, sure. Oh, sounds good. Well, first off, I want to say this talk is sort of something I talked about in a 3-hour car ride with Tina, and then she kind of was like, hey, you have to give a talk on it. And I'd already made some other talk that was kind of related, so this is hopefully a kind of mashup of those two things. One kind of interesting thing to think about is sort of some of the risks that exist within the modular stack and how we kind of quantify them. So this is going to be sort of a quasi-technical talk, not a fully technical talk, that kind of gives some initial analysis of this form. So when I think about the economics of modular systems, a natural way to describe them is via matching markets, and I know some of you have probably heard about them. And the interesting thing about matching markets is they are very different than things like auctions that you often see in blockchains, in that they are optimizing for stability as opposed to optimizing for revenue or welfare. If you view things as a matching market, you can actually try to get bounds on what the minimum amount you need to pay for security is for each of these networks or for each of these components. And from that, you can figure out sort of some notion of like what the economics of these modular systems needs to be. Okay, So what are matching markets? Matching markets, show up in a lot of places, whether it comes from kidney exchange or whether it comes from, things like online dating. This is an example where you have one group of people on the left, they each have preferences, another group of people on the right, they each have preferences, and this shows the sets of matchings that are feasible, with one of the matchings actually being blocked by this pairing. So matching markets show up in a lot of places, definitely outside of crypto. They're really one of the most studied sort of models in economics. The main idea is you have a set of inhomogeneous goods. Those goods have some shared properties, but they are unique. And then there's demand from buyers who have a lot of constraints. So for instance, if I need a kidney, not all kidneys can be donated to me. But the ones that can, there might be some preferences based on particular blood types, based on particular other constraints. So there's usually this kind of high-dimensional constraint vector for kidney deposits or donations. So matching, again, is very different than auctions. So auctions are really about maximizing revenue, maximizing welfare. So an auction is, if, say, I go to an art auction, and there's someone who's bidding $10 million, and then that person is removed from the auction, and the next highest person is bidding $1 million, well, the auction has this 10x lowered revenue, right? It's sort of unstable to single individuals. Matching is much more focused on, hey, if I add or remove individuals, can I keep the matching the same? So like if I have a kidney donor who gets removed, can I ensure that the kidney recipients are stable, like the matching doesn't change a lot, like you still have the same matched partner. And so in crypto, we actually, I think we've always think of things in terms of auctions first, because there's MEV auctions or NFT auctions, there's a lot of auctions historically. But I think this world of intense off-chain aggregation, having modular systems, is actually much more of a matching problem than an auction problem. You naturally think of matching in terms of graph theory. You have some notion of a set of supply, a set of users on one side, and you also have a notion of demand, a set of people on the other side, the people who are receiving the kidneys. And when you think of it in this sort of graph theory sense, then it becomes this question of what is the set of matchers? What is the set of ways you can allocate between the two sides? Usually, matching markets are studied in the case where they're static, so people can't join and leave the graph, which is obviously not true in crypto. And the other thing is there's always a central planner. So a central planner who chooses the optimal matching or maximal matching. Decentralized matching markets don't have this. And you can view the modular world as my demand side is people who want to do some sort of sets of transactions. The supply side is the set of each individual modular component, and I want to figure out prices to match them to which components they should be using. So I think inherently, modular systems are sort of simply a decentralized matching market. I think the idea in an auction is also usually there's only one seller. They're selling one seller is selling some set of goods. In matching markets, there are many sellers, and you're trying to buy some subset from each of them. Okay. So a natural question you might ask is, why are decentralized matching markets so much harder to analyze? First off, people can join and leave, so the matches are unstable. Second, without a central planner, you have to use money effectively. Like there's a whole world of people who study how to do matching markets with no money. But in the decentralized world, you can basically show that you have to have some notion of money or rewards or incentives, otherwise it's unstable. And finally, you have to explicitly model your adversaries for when they're allowed to attack and which components they attack at a particular time. So I think one reason this is sort of difficult to analyze is it's oftentimes hard to quantify the exact cost of an attack in a matching market. But in restaking, that cost is actually much easier to measure because it's, hey, in the worst case, it's like, did my entire stake get slashed? So we'll take this lens from restaking, but you should really think of this as applying generically to how you think about fees in modular systems. I think the difference is in generic modular systems, you can use ZK and advanced cryptography to restrict some of the sets of things versus purely economic means, but you can formulate the problem in the same way. So the main model of study is something called a restaking graph. And so I think it's nice to look at it pictorially. So the reason we talked about this matching market stuff is in restaking, you have a set of node operators. These are the validators V. They each have some stake. There's some set of services that these node operators are operating. There's a set of maximum profit that can be extracted if the node operators collude to extract from one of these services. So you could think of a double spend attack. You could think of any attack that is a slashable offense. And then there's a corruption threshold. So this is, in BFT, you want 1/3 of people being honest. In longest chain, maybe you need 1/2 of people being honest. In optimistic finality, BFT, it's 20%. So there's, that threshold is how much you have to corrupt a stake to take over. Okay. So now we have this sort of matching market. These node operators, they choose services. They try to do this in some way. But what does it mean to attack one of these things? Well, there are two real things you have to consider. The first is profitability. If I attack a set of services, what is the sort of worst case profit I could get? And so this is sort of saying the total profit from attacking a subset of services is greater than the maximum slashing penalty from any attacking cartel. The second is feasibility. This is sort of, this attacking cartel needs to have enough stake. If they have too little stake, they can't actually attack the system. And these are sort of the kind of mathematical definitions of it, and they come from sort of these two papers. The second paper is what we'll talk a little bit about. Okay, so one important thing about these restaking graphs is very different than the security model for proof of stake, is that for this graph here, each individual service, so you can think of these services as two POS networks. Imagine one is Solana and one is Ethereum. Individually, they are secure. There's more stake, 6, than the max profit, 4. But if I can attack them together, there's actually more profit than stake. So I can get a profit of 8, but there's only 7 stake validating them. Now, in the case of Solana and Ethereum, because they're not sharing stake, this middle node that's validating both of them doesn't exist. But in these restaking and composable systems, you oftentimes have these overlap, and this overlap is where generally all the risk exists. Okay, so how do these attacks look? So pictorially, imagine that you have a way of taking out a node. Maybe you DDoS the node. Maybe they lost their keys. Maybe they got slashed to 0. So that's this node that's knocked out with an X. And you can think of that as losing some fraction of the stake in the network. So this is sort of a shock of size psi. So maybe this is, I lost 5% of the network. Now, when you lose that shock, that might create some attacks. So some things that weren't profitable prior to the shock are now profitable, and you do the attack against that particular node. And once you do the next attack, that might open up another attack. And so this cascade is sort of this idea of like you take a little shock of stake, and then you see what's the maximum amount you can attack afterwards. You can think of this as the proof of stake version of a lending liquidation cascade, or sort of perpetual liquidation cascade. And it's in these modular components where you have separate services that maybe are sharing validators or sharing some economic arrangement, you always have to worry about this type of thing. So how do you quantify these? The first thing is, imagine we have a sequence of attacks, kind of like what we just saw, where I took out one service, and took out some operators, took out another service, took out some operators. That's what this sequence is. And we define this quantity R psi as the maximum percentage of stake that can be lost due to a cascade attack due to an initial loss of up to psi % of stake. This is what it looks like in symbols, but basically, how much stake is lost, is burnt in the attack, divided by how much stake you start initially, and maximum over all configurations. So in the restaking case, if you could measure this RSI quantity, it sort of tells you how much stake you need, right? Obviously, you know, the $20 billion or whatever that's currently there is probably much larger than RSI for any existing service. But one way of thinking about this RSI is it gives you a way of parameterizing how much stake you need. Okay, I want my service to only lose at most 10% of its stake under a shock of size 33%. This allows you as a user to sort of, a developer to figure out how much stake you really need your service. Unfortunately, this paper, which supposedly is going to be out next week, shows that's not true. There's actually an infinite family of graphs with where the amount that you lose in the cascade is the entire network. So this is like the worst case, right? This is like, I get slashed, it causes all these other nodes to get slashed, and then it kind of the network blows up. The nice thing is this example can be looked at pictorially. So this is another representation of a bipartite graph as a hypergraph. Each black dot is a validator or a node. Each box is a service. So there's 2 services with 6 operators. So those are 2 rectangular rows. And then there's 4 services with 3 operators. And what we have here first is we have a shock to one node, which causes the first node to be attackable. So for each of these, you need 2/3. If you have 2 or 4, you can attack them. And as you can see, you go down the sequence, you get this thing, and you can attack everyone. So the slightly less bad news is they show this over-collateralization condition. You can think of this as the proof-of-stake version of your decentralized stablecoin needs to be sufficiently over-collateralized to avoid a cascading depeg. But the condition is so strong that every service has to have as much stake as the sum of the max profit over all services in the worst case. Concretely, if you have 2 services, one in which you can extract 1 ETH of profit, one in which you can extract 1 million ETH of profit, the 1 ETH service has to attract 1,000,001 ETH to avoid cascading attacks, which is bad, obviously, right? Like, if you're the 1 ETH service, like, there's no way you're paying enough to attract that much stake. Okay, it's a dead end. I know I got a minute, so I'm going to rush. Well, a little over? Okay. The thing that's missing here is the incentives, right? These node operators in everything I said so far, they're just, I gave you this graph. They just chose, you know, nature somehow chose them in that configuration. In reality, that's not true, right? They need to get paid somehow, either by inflation, like in a proof-of-stake network, or by fees. So now consider an incentivized restaking graph. So one where you add rewards that you pay at each service. And in response to rewards, you allow reallocation. So look, if you look here, this initial graph only has both services operated by the middle one, but this other graph in response to rewards has all the services operated by all the node operators. In that attack I showed you before, this rebalancing means that as nodes are getting attacked and services are getting attacked, actually the rebalance allows some of the services to attract new stake post getting slashed to avoid themselves getting slashed. And the reason they're able to attract that stake is they gave enough rewards, someone got slashed who was validating that. Now everyone else's yield went up, which means that someone new can join and still do it profitably. So the idea of this rebalancing is like it allows people to, in response to slashes, new stake to come in and avoid these cascading failures. So the good news, and this is, you know, paper will be out kind of hopefully a couple weeks, is that given an incentivized restaking graph, you can actually bound these cascade attack sizes. And there's sort of a parameter for how much you pay in rewards that controls how much cascade you have. So the simplest interpretation of this is, and so this kind of skips a lot of exactly how this works, but if adversaries who are attacking face some cost of attacking, like it costs them something to accrue stake in multiple networks, if node operators are smart, they rebalance as slashes happen. And if the services pay enough rewards, only a small amount of stake can be lost. And in the modular world, you actually have a very similar thing where if I have a service, say a roll-up, that's utilizing a bunch of other services and they have some economic arrangement with each other, if one of those services loses security, in order to kind of continue operating, we may actually have to have stake come into another service. And so that's, I think, again, the restaking world at least makes, you can quantify this. I think in when you add in proving, it gets a little bit harder, but this is kind of the TLDR. Thanks.
All right, thank you very much, Tarun. Next up, we have a panel, so give us a couple moments while we get some stairs on stage. Welcome, everybody, and then we'll get going. We have that application protocol thesis.
So yeah, thanks everyone for day 2 of Modular Summit. So basically, as context for this panel, so Tina and I, for example, we've been having a lot of conversations about reevaluating things like the FAT protocol thesis as well as the FAT application thesis, which emerged in 2022. Sort of driven by a few different. Hasu had a tweet. There were some blog posts by the folks at Z Prime. Et cetera. And as context for everyone, it's sort of that back in 2016, 2017, there was this big debate about basically where does value accrue, and people were like, well, since we have these assets with really high market caps and no applications on them, clearly there's this fat protocol. Clearly protocols are destined to be fat and applications are destined to be small, and basically, which is an overgeneralization. But the reason they gave was that because blockchains are basically serve as this shared data layer, and then they have tokens, they can build these like really deep network effects around the protocol, and that basically applications are just always going to be smaller than that, than those accrue moats that are smaller than that, et cetera. So then obviously we have the whole period from 2016 to 2020, 2021, and then basically there are the first applications, the first there starts to actually be on-chain order flow and DeFi and all these things, and in 2022, after all of that sort of fades away, people started talking about this idea of a fat application thesis. Where actually, wait a minute, a lot of these applications or basically just smart contracts on Ethereum or on Alt L1s or whatever, they can actually pretty easily go and deploy their own chain, and that had already started happening by that point, right? You have DODX as a chain, at that then, et cetera, so it's a good time now with the modular stack to sort of start reevaluating that, because the sort of a core premise of the idea of making the stack modular is that you basically end up with different inherently thinner basically each smaller component of the protocol can be broken down into a modular stack. And so we basically assembled this panel to sort of reevaluate that and talk about basically how this is evolving and what it looks like going forward. So we have Ben Fish from Espresso, Justin Drake from Ethereum Foundation, James Presswich from I actually don't know what you're working on these days, but
Init4,
and then Viscance from Z Prime. So they wrote some of the best blog posts on this topic. at the time in 2022. And so I think the first question to ask the group is, like, what are the actual lasting modes for a protocol like Ethereum or other L1s, et cetera, in an endgame where applications do control their distribution and users to a larger and larger extent as like other parts of the stack modularize? So I guess maybe starting with Ben.
Yeah. So I do think that fundamentally the value has to accrue to applications because if it weren't the case that let's say an L1 protocol with applications on top of it were allocating most of the value back to applications, then fundamentally applications would just take control of their own order flow, and now you get into competition between L1s, right? And so any platform that is not redistributing value to applications, be it in fact a rollup that has applications on it or an L1 itself, is going to face now competition from from other applications. And of course, the one moat is if you can build a strong enough network effect, then there's an argument to be made that nobody else can compete with you. And I think that the what you call sort of this modular movement has sort of eroded that moat. It's because it's now very easy for applications to build their own chain, but in a way where they're still, to a great extent, benefiting from the liquidity that exists on other chains or applications. There's no longer such a pull to all be in the same rent-seeking L1. But I think that the end game for these protocols is still maybe it's not to take all the value, but if you're a DA layer or a settlement layer or still providing some infrastructure that has a strong purpose and a network effect, you're going to be capturing some value, which is going to be a small percentage of each application's value.
So I guess my thesis is that there's going to be one very obese L1. So you think tens of trillions of dollars, maybe $100 trillion. And then there's going to be fat applications on top of that. The fat applications are going to be because I think there's a realization more and more that applications have actually sovereignty over the value that they create. So each application will have the ability to capture their own congestion fees. Just like Base, for example, today captures tens of millions of dollars of congestion fees, and will also be able to capture the MEV that they create. We have ideas like execution tickets, but there's all sorts of other ideas. Now, in terms of like the value that the L1 provides, there's basically two of them. One is shared security through shared data availability, and we're going to see, I think, very high demand for data availability, which is going to lead to very healthy cash flows. And then the other use case is economic bandwidth. So money, collateral for these applications. The one pristine collateral which is available on the platform, the one where you don't introduce a new security assumption or new governance or whatever it is. And that is going to drive the monetary premium. So the cash flow aspect is going to be thinking of Ethereum like a company, like a stock, and then the money aspect is going to be thinking about Ether as a collateral like gold.
I'm in a little bit of a unique position on this panel in that I've actually migrated an application between blockchains in 2016, 2017-ish. And we didn't do it because of value accrual or some ontology about who's making money and how it gets allocated. Like, people running applications make business decisions. Do we think the cost of development will be higher in the long run? Do we think that we will have access to a bigger user base? When we're talking about these big research questions about value accrual, we tend to forget there are thousands of independent actors in this space trying to run businesses, and they make short-term economic decisions, and they're not rational actors. I don't have a long-term thesis on value accrual because I think it's incredibly path-dependent.
So I agree with James.
I don't have a long-term thesis for Ethereum value accrual. I would say that one of the modes that's maybe a bit overlooked is the mindshare in Ethereum ecosystem, which is represented by one of the previous speakers was mentioning like value alignment. And yeah, well, in the cutthroat world of business, it's like kind of silly to talk about value alignment and these philosophical questions and ideologies and ideals. But at the same time, at this point, I would still say that Ethereum plays a role as a sort of like almost like a Silicon Valley of crypto development, with all the important and interesting ideas that came into crypto in last at least like 5 years originated in Ethereum, and this mindshare and this sort of ethos that was built around it very organically. I think that's a mode that will last for some time, and I would say that this is also the reason why even like very business-minded entities will still try to tap into that mindshare as best as they can. But I'm not sure if this is a mode that's like not irreplaceable in the long run. I think in the long run, like people are leaving Silicon Valley to Texas, right? This can also happen with Ethereum if our streets will become full of shit. So.
Fundamentally, like users don't know or care about value accrual theses. Like people move to Texas.
Yeah.
This is a question for Justin, I guess, or basically everyone after us, but it's basically what, in an ideal world, just how obese should Ethereum be? But then the question attached to that is, which part of the modular stack or the blockchain stacks are fated to reintegrate? Like what's the stuff that feels like there is sort of like a gravity based on what users are doing, based on what they're doing by their own, not thinking about, any of this infrastructure. What parts of the stack or even off-chain infrastructure are fated to like centralize or reintegrate?
By reintegrate, do you mean get enshrined within?
Yeah, or you think of like, for example, if Espresso decided to get into proof aggregation or something, like what are the or the super chain or these sorts of things.
Right. I mean, I think all the technology will get commoditized. The only thing that's really valuable is going to be the network effects. And there's network effects around money, which are around access to liquidity and access to TVL. So, if you want to look at the technology, so if there's this notion, for example, of a native rollup. Used to be called an enshrined rollup, where all the complexity of building an EVM equivalent snark circuit or an EVM equivalent fraud proof, all of that will be encapsulated in one single opcode that will be very easy to do. The proof aggregation, that's just pure technology. There's no reason why there should be value captured there. The settlement layer, same thing here. It's like a constant amount of gas that you need to consume per unit of time per slot. So you might imagine like 5 different proofs that get verified on chain per slot. Like the thing that's kind of difficult to maintain is the congestion fees, the demand that basically stem from network effects. The more activity there is on Ethereum, the more of a desire there is for application developers and users to join in. I think it's going to be winner take most, this kind of obese L1 thesis. And not only will there be network effects on congestion, but also network effects on money. But everything else is commoditized.
Can I build off what Justin said? So I think that network effects, in my view, fundamentally have to do with some kind of provision of coordination. Right? I think that any fat protocol, so to say, with a network effect around it is providing some necessary coordination to applications. Okay, and that could be through shared liquidity, through shared settlement, through composability between applications. The core tension, though, is always going to be between providing this necessary coordination and then reallocating value accrual to applications. And any protocol that figures out the best way to provide this coordination while at the same time redistributing value to applications is going to have the strongest network effect. All the applications are going to there because they have the best of both worlds. And so in my view, this is a mechanism design problem. It's how do you have applications running on kind of a common system where you have users on the one hand, or even builders or block builders or types of users that are bidding for some kind of constrained resource, and you're selling this constrained resource. Because this constrained resource is shared among applications, how do you allocate it and attribute and redistribute the value to them? And that's, I think, a core problem that Ethereum is going to face. It's a market mechanism design problem. You can view it as an auction problem or a lottery problem. That's also the problem that like Espresso discovered very quickly we needed to solve, because if we're trying to provide some kind of shared resource, then we have to solve that market mechanism.
I slightly disagree with this take. I think that the most successful applications, like these sort of super apps or fat apps that will emerge, I think they will take matters into their own hands and will capture their own value on their own terms rather than abide by some protocol rules.
We can also kind of rule out the case that there are many applications on an obese protocol. Block space is constrained on any blockchain you buy it from. It just is. That doesn't matter if you're sharding, data availability sampling. There are constraints. All applications compete with all other applications to buy block space. When block space is sold out, when the constraint is hit, when the supply is all sold, fees go nonlinear. This happened in 2020, 2021. We saw fees go from 5 gwei to 500 gwei or 5,000 gwei. Most applications cannot survive a nonlinear fee event. When the fees go from 5 gwei to 500 gwei, most applications die. And only applications that are willing to pay that price are allowed to survive. So when the protocol gets obese, it narrows the scope of applications you can build, applications that can survive. And all block space goes to the users and the applications willing to pay the highest value for that block space, the applications with the highest marginal value of transacting. So when we're talking about giving value back to the applications, we're talking about a situation in which a small number of applications with high marginal value of transacting receive the value. And so we should be clear that they squeeze out all other applications. When we talk about an obese protocol, it means a protocol with 1 to 2 applications.
I mean, one thing that I expect will happen is that as we have more and more blobs and more applications that consume parts of the blobs, then any given spike in 1 or 2 or 3 applications is going to be smoothed out by all the other applications that don't have a spike. And so the volatility of the fee market should go down dramatically. It won't go from 5 to 5,000.
If I have a $5 marginal value of transacting, I will pay $5 for all gas in the block.
Right.
It doesn't matter that there are other applications that will only pay 4. They're just not allowed to buy block space.
Yeah, I agree with that statement. But basically, what happens is that when there's one application that starts to dominate, it consumes all the gas. Whereas when there's 1,000 applications, each of which consume 1/1000th in the normal case, but 10x more in the unusual case, in the spiky case. Well, the difference between 1 and 10 when units of consumption, when you have 1,000 units of supply, is not that bad.
Well, that's anchored in the spiky demand that we see right now. Like, if all we're doing is building platforms for apps that go up and then down and then stay there, like, we should probably be building something else. We have to assume that eventually there will be stable applications with businesses behind them that bid a stable amount for block space. And block space costs rise to the lowest threshold of stable demand. It's not balanced out by spikiness across a bunch of different apps. If we are successful, there will be apps willing to buy out the chain. and they will pay a high price to do so. And they will prevent other apps from transacting. You can see this very concretely. If one rollup buys 6 blobs in an Ethereum block, no other rollups are allowed to buy a blob. This has been demonstrated. This is just simple economics: constrained supply, unconstrained demand.
But what about when we have 6,000 blobs?
If one rollup is willing to buy 6,000 blobs, then they buy all the blobs.
It won't need it. That won't be the economically rational thing to do. It will buy 60 blobs instead of buying 6, but it won't buy all 6,000.
Why not?
Because it doesn't have to. If there's some sort of NFT spike, for example, there's only 1 million NFTs. Each NFT.
We're still anchoring in the spiky case. If we are successful, there will be real businesses that have sustained demand. And if we can't meet sustained demand from real businesses, then we will have a nonlinear fee event and we will rise to the point where no one else can transact.
I agree with what you're saying, but I think it's still a question of supply versus demand, and so it's also reasonable to expect that the supply of block space will exceed demand, especially with newer innovations coming out. But the original point that I was making, I didn't want to make it so narrowly about a constrained resource like block space. There are other things that you can think of as a constrained resource, like access to order. Okay, there's always going to be arbitrage, right, between different applications, and so this is something we can look at as an example. No matter what, even if you have every application running its own chain and there's no fat protocol in that sense, then there are still going to be arbitrageurs who will want the right to take advantage of arbitrage simultaneously across all different of these applications. And again, this becomes a coordination problem. And so if there's a market that is selling jointly this arbitrage opportunity over all these different applications, it still needs to figure out how to reallocate that to the applications. Otherwise, the applications are going to run their own marketplaces and there won't be any coordination. That was the point I was making. Yeah.
Another point on the spikiness of fees is that you can sell block space futures and you can buy block space futures. So just like gas, like actual gas that you put in the tank, this is hedged on a very large size, and Ethereum gas will have similar markets to physical gas.
Yeah. So I worked on hash rate and block space futures platform back in 2018. The problem with this as a concept is that while block space futures have logical buyers, there are no logical sellers. When we have a futures market in real life for things like flour, oil, not onions, that's not allowed. You have people who know they will produce flour, and you have people who know they will consume flour. And they know they will do that at scale. You have people who know they'll produce oil, and they know they'll consume oil, and it's at scale. And so the futures market exists to resolve the timeline differences. We have people who know they will consume block space, but we don't have a market that knows it will produce block space in the future.
They're called proposers.
Proposers know how many days in advance?
Well, you can have, well, first of all, there is this notion of a look ahead, right, where you can, for a few minutes, sell in advance, but you can also sell at larger intervals with, for example, execution tickets. So with execution tickets, you could have a pool of millions of tickets that are sold in advance, and you know what fraction of those you have, and so you can probabilistically provide block space futures with a look ahead of many days.
Probabilistically providing futures is not very useful to me when I'm running a business.
Well, I don't know. So here's the thing with Arbitrum. So Arbitrum has this isolationist approach where they're not really interested in composing with other rollups, and they're willing to basically delay settlement for various reasons. One of the reasons is that they want to batch as much data as possible to have the best compression ratio possible, and then only settle on chain. Now, if you settle, 2 minutes in the future, or 2 minutes and 12 seconds, or 2 minutes and 24 seconds, it doesn't really matter from the perspective of Arbitrum, which would be one of the biggest consumers of block space.
So you're looking at these futures markets in the perspective of like, 5-minute markets or less.
No, it could be on a matter of days as well. So you could say, Arbitrum wants to buy, 20% of the blob space for the next week, and it will just be able to do that.
I'm excited to see Special Mechanisms DOS attack on this.
Yeah, thanks. I guess one question more for Friskan about, you guys obviously wrote this blog post about the fat application thesis and stuff, like after, in 2022. Like, where do you actually think, what actually has played out as you expected, like from your guys' perspective?
Not much.
Yeah.
It's still too soon. I think what played out is that now many people agree with us, but they agree with their words and with their tweets, but not with their money. They are still funding infrastructure and protocols more than they are funding applications, and we see this in the valuations, in the rounds, even throughout this cycle. I guess one thing that people forget when we are talking about like applications and protocols is that we already have super apps, and they are Coinbase, Binance, OKX. But the thing is, they don't have, they don't have like too many rounds because they became profitable quite fast, and they are not really on chain too much, but they use many chains. They abstract away the chains, and some of them are already launching their own layer 1s, layer 2s. And it's fair to say that at least for Coinbase and like before even for Binance, like they were able to make their L2s and L1s much more used and successful than like all of these other competitors that are building the infra first and then they will figure out how to bring the users. They had the users first, and this seems to be the winning sort of vector for the super apps. And maybe the example it's still like, it's not clear if it will work out, but it seems that Telegram is another one, another competitor that has this angle of like, yeah, we have these 900 million users, they are using our chat. What if we just like put some blockchain underneath, give them a wallet and see what happens next? And yeah, now it's like one of the most hyped things. So I think this is kind of still very early to say if it's a successful path, but I would say it has bigger chance of success than building like 5 layers of weird infrastructure and then waiting for someone to come and build some like important application on top.
Yeah, I guess the question there, I think, and I was talking to someone about this earlier, is like, what is the adjustment time? And like, so if you think of it as like, there's this weird market structure around crypto stuff that like causes, tokens being one of them, right? That causes, a very large, like pretty unarguable, like overinvestment infrastructure. Like, what is the actual time to make an adjustment to that, and like, what is good enough? Like in the sense of like, what is what is the level of readiness, or like, what is the minimum viable like set of like protocols or infrastructure or state of the world that will actually bring about a change in that like market structure to cause like an investment in a greater investment and attraction by application builders, et cetera. Like, what is that order of magnitude of time is the kind of the question.
I don't know, by the way, if all of us agree yet that
go ahead.
I mean, saying on the one hand that applications are fat and value accrues to applications, and for any given application, 99% of the value of that application is going to the application and not to the protocol, that doesn't necessarily mean that any given application is more valuable than infrastructure. I mean, infrastructure is taking a small piece of all applications. And again, going back to what I was saying before, if there is some fundamental coordination that needs to be solved, or some fundamental shared security that needs to be provided, which in my view is the whole point of Web3 in the first place. I mean, if the fat application thesis were so strong that protocols diminished to basically insignificant insignificant levels, then we were perfectly fine with Web 2. So I think fundamentally infrastructure in Web 3 provides a coordination mechanism that's necessary, and any piece of infrastructure that's successful will be taking a small piece of all applications. As applications scale, value does accrue to that infrastructure, so any given piece of infrastructure could be valued a lot more highly than any individual application.
Yeah, so that's like what Ethereum looks like today. But what do you like if you look at Solana, for example, right? Like how do we make sense of Solana in this world where they actually do have applications that are like single applications that are, bigger than what Solana is.
You're saying bigger, like the value of an individual application in terms of market cap is bigger than
just the fees, like even just the fees on like a
the revenue of the
Pump.fun.
application. Right.
Yeah, well, no, actually, like Radium, really, but
Yeah.
Pump.fun is also in the top 5 or whatever.
I think you're going to, first of all, I think that looking at any given example, you're going to have anomalies of like any theorem is a theorem, right? And then there's going to be counterexamples of that, and there's so many confounding factors that it's very hard to pick it apart. But I can't say, what exactly is going to be the case, but I think that there's an argument to be made that infrastructure still can be more valuable than individual applications, especially assuming there's sufficient competition between applications.
When we purchase infrastructure, like running a company, when you purchase AWS, you do it for the predictability of the service and the predictability of the price. These are things that we don't have strong evidence that blockchains can provide, right? We get inconsistent pricing, we get inconsistent service all the time. And AWS is an extremely valuable company, but it's not clear that its value is on the same order of magnitude as all the things built on top of it, right?
I mean, there's this commodity called gas, physical gas. It's worth $100 trillion. It has very unpredictable prices, and still people use it on a regular basis.
Right, and they have futures markets on the order of months to hedge their risk, yes.
You just said collective, you're saying that AWS is not more valuable than all the applications combined on top of it. But if you compare AWS to any individual application, the vast majority of applications that run on AWS are not as valuable as AWS.
Right. What I'm saying is that it doesn't capture a significant percentage of the value that are created by applications on top of it. The applications do capture 90+% of the value.
Yeah, I don't think I disagree. I disagreed with what was said earlier, I don't remember by who, that investors need to adjust, the valuations of applications relative to infrastructure because,
I think that markets are reflexive. So as long as we have people buying infrastructure tokens for much higher valuation than they are buying application tokens, we will have more of the investment in the direction, but maybe a couple of breakaway applications that become successful, and we will see the markets to re-rate just because markets are reflexive, especially in crypto.
Yeah. So yeah, that's all time for this panel. Thanks, guys, for coming on, and let's see how it plays out.
All right, that actually ends chapter 2, Protocol WTF. We heard from Vitalik, we heard from Tarun and Emmanuel and Yona, and then also this great panel here. Always entertaining when Hudson and Justin go back and forth. Next up, we're going to start the MEV section of demystifying the end game, and we're going to start with Yuki talking about the state of MEV. This is chapter 3.
All right. Hello, everyone. This is Yuki. I'm founding research and growth at Sorella. So today, we'll be talking about the state of MEV. And just to kind of like show the flow, we'll first briefly go through the type of MEV that we'll be discussing about today. And then we'll also discuss about the source of MEV, which is where, Oh, okay. And then we'll discuss more about the destination of MEV, where the MEVs are going. So there will be a bunch of data that I will be presenting here today just to give some numbers and hopefully some context for you guys. So first type of MEV, which is also the biggest type of MEV that we will be showing today, is atomic arbitrage, which is oftentimes an extractable value that is derived from ordering of transactions, and ordering transactions that are maybe perhaps arbitraging between different pools that have price discrepancies. And then also this atomic arbitrage is a very broad term. It also includes things like triangular arbitrage, cycle, cross pairs, and many different types of long tail arbitrages. So I kind of just like concluded as like a one big type. And then another one, as you guys already may know, sandwiching, which is oftentimes when you have uninformed users, traders who are putting down a trade, and then these trades get picked up on by other searchers who potentially would front run you and then will back run you to extract values from the trades. And this is also a very major type of MEV that we will see later on. And then another type that has been also very much prominent, if not one of the bigger MEV type, is sex-sex arbitrage. This is where when you have exogenous information, like for example, Binance exchanges, and that exchange price changes more frequently than the blockchain prices, let's say on Ethereum. And that stale prices on Ethereum is often what's causing a lot of people to try to capture this spread between the off-chain price and on-chain price, and that results in this kind of a sex-sex arbitrage. The last one that I also wanted to touch upon is JIT liquidity-based arbitrage strategy. I wouldn't say this is like a specific type of extractable value, but it's more like something that we have observed over the past few months in terms of the kind of strategies that a lot of the big trading shops have been adopting to extract values. This is where the traders, those searchers, arbitragers, attempt to front run those user incoming orders by actually providing this JIT liquidity, just-in-time liquidity, for the corresponding pools. By doing so, they actually earn some fees in the meantime, so that would help them increase the cost margin for the later arbitrage that they're gonna do. So this is kind of like a combination of JIT plus whatever arbitrage strategy that follow, which it could include things like sex-sex and sandwiches and whatever other arbitrage options out there. But in general, we have seen a very interesting behavior in terms of like JIT plus whatever arbitrage strategies. So let's talk about the source of MEV. I would love to kind of like take a look at this graph and then just think a little bit in terms of what's exactly is going on. So this is the sort of accumulation of all of the MEVs that we have analyzed and observed on chain since the merge. And you can see that there's a USDC DPEG events that happened that spiked up the merge for that specific period. But I also have colored sort of like different types of MEV that we have seen. To just kind of give a key takeaway here, essentially the atomic arbs here accounts for roughly like 60%. And then you have, sorry, not 50, like 40%. And then you have 66 arbs that are closing in around like 35%. And then you have the sandwich that is amounting to about 25%. So this is kind of like a current proportion of how much MEV belongs to what kind of MEV that we have observed on our MEV tracing protocol called Brontes. and also I would note that there are some extra MEVs like the JIT, sextex, JIT sandwiches. These are more like complex type of arbitrage strategies that we are still kind of like building more capacity to better categorize this, so that potentially this could be a bit more than the actual number we have, but still some work to be done to accurately deliver that. And then we also have studied the MEV type by builders since the merge. So I kind of created the heat map where you see the builders and then you see the different types of MEVs. Is it too small? It is a bit small. Okay, so basically from the left, it's atomic arb, and then the second column is the sextex. And then I'll just say the last column is the sandwich. So I will kind of just describe it, and for anyone who's interested, please come to me. I was definitely happy to share the data. The key takeaway here is that we have observed that the trading shops like rsync and Beavers have displayed a fair amount of like 6-6 arbitrage within the type of MEV that they have captured historically. Meanwhile, you have Titan who are not so aggressive on the 6-6, and they're mainly focused on a lot of the atomic arbitrage. And then surprisingly, they're also like have Bloxroute who are capturing quite a lot of like 6-6 in its early days. So where are those MEV going? This is sort of like a rough profit distributions of the MEV. The red is proposers, the green is builders, and then the last one is searchers. Searchers includes those trading shops. And this is obviously like, mostly is going to proposers, right? And then, yeah, surprisingly, builders not capturing a lot of money. And then for the builders, this is a split between the builder profit on the MEV, builder profit from the MEV and builder profit from non-MEV. Non-MEV means like priority fees that people pays, right? And this is about half-half, 50-50. That's kind of like the distribution that they have. And this totals around to like, what, 300 million, I believe, to date, since the merge. So we also kind of studied what's the searcher profit looks like. And this is also like a rough searcher profit since the merge type of data. The total amount amounts to about 693 million for the whole pie. And then the top ones are SCP, Win2Mute, someone I don't know, and Jared from Subway. All right, Jared is doing a pretty good job here. But I have to say that since there's a huge pie on the other section, there's a very good chance that we haven't found the wallets, the EOA wallets that we don't even know the label for. So there could be like a lot of SCP and Jared that is hidden in the blue part as well, which is, you know, anonymous. And then we also have picked up from the labeled ones, so the ones that we know, like SCP, Win2Mute, Jared, Jump Trading, Jane Street, and then also kind of like try to understand what's the profit distribution look like for them. And this is what it looked like. Basically, SCP is making a lot of money. Win2Mute and Jared is also like doing a fairly good job, and then the rest is like, you know, maybe not so much. Lastly, I kind of wanted to touch upon this like builder profit distribution. This is so you'll notice that the Bloxroute have a lot of profit, and this is likely because Bloxroute in the early days they have done a lot of 6-6 related arbitrage strategies. So, or maybe perhaps not they have done it, but at least a lot of the searchers who are interacting with Bloxroute builders were doing it. So that's why there's such a big portion, but others are Beaver Build and Titan and rsync. Now, the rsync profit is a bit lower because this profit should also be added with the searcher profit, since they kind of do both the searcher builder. So their total profit is supposed to be rsync, like their searching business plus the builder business. Just note. So what are some of the takeaway, and how do you think the MEV will change in the future? So one thing I believe will be the case in the future is that the proposal revenue will decrease as the DApp work to internalize a lot of the MEV. All of this 1.5, nearly $2 billion of MEV, we will internalize all of it. Well, maybe not all, but like a good chunk of it. And then from all of this, you will notice also that credibly neutral builder is actually very scarce and frankly quite valuable. And it also adds to the censorship resistant property of Ethereum transaction supply chain. L2 MEV will not be the same. We haven't presented here, and there's still more work to be done, but there's more data. There will be a lot more difference dynamics in which the MEV will be extracted because of the lower block times and potentially less 6-6 arbitrage profit as well. And then the last one is that 6-6 percentage will likely increase as more sophisticated traders and market makers will enter the space that may have different edges than Win2Muse and SCP, and so forth. So yeah, hopefully, we will change it, and MEV, as we talk, is also changing. Thank you very much.
All right, thank you very much, Yuki. Matt, you're up. Please welcome Matt Cutler of Block Native.
Thank you. We're going to be talking about a very new research finding. Literally, we made this finding last week. It will change every one of your trading strategies, or just you'll actually have a new piece of decisioning logic based on this, and it may introduce fundamental instability in the base fee, so we're a little worried about it. We're not crazy worried about it, but it's like worth paying attention to. So I'll spend the next 15 minutes or so talking about new sources of base fee volatility. I'm Matt, I'm founder and CEO of Block Native. We've been involved in this ecosystem for quite a while, and we love to share what we're working on and finding. We are, as this shirt would suggest, very focused on gas, and if you want one of these shirts, DM me and we'll mail one out to you. But real simple, gas is one of these things that people just don't really spend a lot of brain cycles on, and I would say you're sleeping on it. And the reason is that spot demand for block space sets the spot price for block space. So, hey, we're all on Web3, block space is a commodity, the price of that commodity matters, and you should really think deeply about the quality of the price signal that you get, because the signal today for gas prices across the whole ecosystem is not very good, and it's getting worse. And the reason why it's getting worse is very easy to understand. Spot demand is largely in the public mempool, and we all know the public mempool is shrinking. So as the public mempool becomes a smaller and smaller portion of all demand, we all collectively, every user of every chain, has less visibility into spot price. And that affects pretty much everything. By the way, multidimensional, volatile, emergent. Gas matters to everybody. It doesn't matter who you are. You got to deal with gas up and down the whole stack. And it matters all the time. And it's this highly levered metric. And I like to make the point like, hey, look, arbitrage is determined in part by the gas spread. And so if you have additional scatter in your gas price, you will have additional scatter in your ARB break even, and that will affect every price on your venue. So like gas is one of those things that kind of cranks through everything else, and we all kind of assume it's right, and it turns out it's not, okay? And we're gonna talk about how it's not right, because basically all of Web3 is staying on top of these gas markets that aren't really well researched and aren't really well understood, and this is what we at Block Native are increasingly focused on. So just by way of analogy, you build new instruments, you can make new observations. This is the moons of Jupiter. This is a whole galaxy cluster, obviously. And then what happened here, what we'll be sharing with you is we made an upgrade to our own platform. So we have this thing called Ether now. It provides a transaction explorer that's like Etherscan for mempool data. It used to look like this. Now it looks like this. It's publicly available, by the way, made possible for a generous grant from the Ethereum Foundation. Your Ethereum Foundation grant dollars at work is right here. And we basically put gas at the center of all of this. And in doing so, we saw something we didn't really expect to see, and we started to scratch at it. And that's what I'm going to share with you now. So, okay, first off, growth in private transactions. So private transactions, these are privately transmitted transactions. By the way, I tweeted on this, and a whole bunch of people got all wrapped up that there's no such thing as private transactions on Ethereum. Like, just, I want to be really clear. These are privately transmitted transactions, i.e. those transactions that don't appear in the public mempool until they show up on chain. Okay? This should be familiar to everybody in the room. And they've been percolating along at about 10% of the network, but pretty recently they started to accelerate, and now they're fully 30% of the network. Okay? There's this very important phenomena called mempool pressure. So the mempool is a continuous flow environment. Anyone can submit a transaction at any time, and blocks are a discrete environment. It's like the difference between an elevator and an escalator, right? And so, you don't really think so much about it. Pressure builds up on the mempool, and a new block comes in, and the pressure dips down, and then more mempool transactions come in, and a new block comes in, and the pressure goes down, and every now and again we have a missed slot. What happens in a missed slot? A block doesn't get created, and that pressure on the mempool builds up. So in the slot that immediately follows a missed slot, you have double the number of transactions, and that block is going to be twice as full, right? Makes sense, not hard. Except now with this, there's two forms of mempool pressure that matter. There's public mempool pressure, which is observable, and there's private mempool pressure, which is not observable. So that's kind of an interesting thing, but by itself, probably not that concerning. But then it crosses with something completely unrelated, and it starts to create base fee instability. And this is this new thing. So with this tool that we have, you can look at blocks, and you can see the percent public versus private in the block and their distribution. So in this case, the light blue are public transactions, and the dark blue are private transactions. It's actually really cool. You can look at the ordering, and you can see sandwiches occur, and all this sort of jazz is all available. But as we literally built this, we're testing it on staging internally, we start to notice blocks that look like this. And you'll notice it's all one color. These are 0% private transactions. That's sort of strange. We realize, like, oh, these are vanilla blocks, or altruistic blocks, or self-built blocks, right? We talk about this. And in fact, you use rated network or anything else, and you'll know 90% of all blocks on Ethereum are run through MEV-Boost. But what about that other 10%? Turns out that other 10% doesn't have access to the private transaction flow, which historically wasn't that big of a deal because there wasn't very much pressure on the private mempool side of things, and now there is. So there's two weird things, 30% private mempool pressure and 10% of all blocks are produced in an altruistic self-built way. And so if you really start to think about this, you go, wait a sec, this should cause some volatility in the base fee because you're gonna have blocks that are artificially small followed by blocks that are artificially not small. And that's gonna affect us all, and it turns out that's exactly what happens. So I'm going to show two examples here. This is a real simple breakdown. This is 6 consecutive slots along the bottom. This is all real data, by the way. And the blue in this chart is percent private. And the one that we're really paying attention to is this blank one. This is an altruistic self-built block. Contains no private transactions. And you'll notice that the slot immediately after the altruistic slot spikes high. So you can't quite read it, it's a little bit hard, but basically baseline is 30% private. This particular block is about 60% private, doubles up like you'd expect. And so what happens here is the gas used also follows this characteristic spike. So this altruistic public block is only about 15 to 20% full, and the block immediately thereafter is literally 99.7% full or something like that. So you get this artificial dip in gas utilization due to altruistic self-built blocks not having access to private mempool flow. And so now you have inefficient utilization of network resources here and overutilization of network resources here. And for those of you who are familiar with how 1515 mine mechanic works, is this, of course, alters the base fee. So, by the way, just by way of terminology here, we have this idea of a self-built block, and we'll be talking about that. But then there's a special thing called the recovery block. I don't know, we might change the name of it, but the recovery block is the block immediately after a self-built block. And they're bigger than normal blocks. This is highly repeatable. I'll show more expanded data. And what happens here is basically you have this swing in gas used. So the publicly built altruistic block has a dip in gas, and then there's this big spike in gas. Literally, it's like a 400% swing, and this is the smoking gun. This is what the base fee does. The base fee is sort of percolating along. Immediately after the altruistic self-built block, the next block, the base fee dips because this is an underutilized block, and then the recovery block spikes it back up, okay? Now, Another interesting factor, and this has been mentioned a couple of times, there's strong evidence of timing games here. This is a little bit hard to interpret. These are 3 different blocks. The yellow is an altruistic block, and the blue and the green are the block before and the block after, both MEV boost blocks. And it turns out that what happens is, due to timing games, that the builders are building for the full 12 seconds, and the altruistic self-built blocks generally only build for anywhere from 8 to 10 seconds. So not only do they not have access to 30% private mempool pressure, but they also don't have access to the full time for mempool pressure to build up. And so literally, they get double squeezed, which explains why these altruistic self-built blocks are significantly smaller than the MEV boost blocks. Okay, so now let's zoom out a little bit. The first question you should ask yourself is, so how common are altruistic self-built blocks? And it turns out way more common than I expected. It's basically like just under 10% of the network. So this is daily data. The orange at the top are the altruistic self-built, and the blue is everything else. And so literally about 1 in every 11 blocks has this characterization. And do they really consume less gas? Yes, it's like pretty black and white. MEV boost blocks, altruistic self-built blocks, this is gas use, okay? Now, this one's a little bit harder to interpret. The colors change around. These are those recovery blocks that I mentioned, the special ones, and these are MEV boost non-recovery blocks. So literally, you split apart, and so the blocks that immediately follow a altruistic self-built block do have measurably more gas consumption than average. And this creates this effect, which is, how much does it move the base fee on average? And the key here is the little one. The green is the average MEV boost block that is not a recovery block, barely budges the base fee, because they're generally pretty close to 50% full. They're pretty efficient. But you know what? Those altruistic self-built blocks drive the base fee down, and then the recovery block drives the base fee up. And this is this new form of volatility in the base fee that does not accurately reflect spot demand, okay? Now, 2 really important things to know about this. The nature of 1559 fee escalation means that the way that it works is it's much easier for the price to rise than it is to fall. So 1559, maximum interblock change is 12.5%. And the block-to-block change is 12.5% at 100% full block, and the negative 12.5%, the minimum, sort of the maximum reduction, is at a 0% full block. So ask yourself, how likely are we to get 100% full blocks? Pretty accurate, pretty common. How likely are we to get a 0% full block? Not very common. So what winds up happening here is the base fee dips and the base fee rises, and then the base fee decays back to a baseline before it does it again. And that's at 30% public mempool, or private mempool pressure, 30% private. So what will happen will be, as the private mempool grows, 30%, 40%, 50%, at about 50%, my guess is this gets a lot worse if current trends hold. And the reason why is you'll have 100% of a block on the private side and the recovery block plus all the public. So it will take 2 blocks for the backlog to clear. The base fee will rise across 2 blocks, and then it will have less time to decay. Now, there's some pressure relief in here. We've been working with the EF on this stuff a little bit, going back and forth with some researchers. There's, I think, some mechanisms that we need some more research on, but that ultimately, the base fee is getting less and less reflective of demand, and it affects us all. Hey, by the way, if you transact regularly, do you check if the last block was self-built? Because you should. Because if the last block was self-built, you know the next block is going to have an artificially low base fee, and the next block after that's going to have an artificially high base fee, and it swings about 20%. So that's a good source of alpha for all y'all here. So by the way, if you listen to the common narrative, is if you're a proposer, oh, build altruistic blocks, do the right thing by the network, watch out for MEV, and oh, don't be a bad MEV boost user. But it turns out that this data would suggest the opposite, that you actually, the happy path may be the opposite. And I'll close on this. This is Rated Network. And Justin Drake actually helped me sort of get into this. Some of the data we see, we sort of scratch our head over. Like, we see a lot of Lido vanilla blocks, self-built blocks. Like, you'd think Lido, like they're the big guys. But if you dive into this, you will see that Lido on average is 7.2% vanilla. It's a shocking percentage of all Lido blocks exhibit this capability. And you can actually click into it further, and there's specific providers inside Lido, like Attestant and ChainSafe, that are like 76% vanilla. So there is probably some stuff we're going to need to do about this. The good news is I think that there's some folks we could talk to probably make things okay. So one, we just want to let everybody know I'm here to sort of disclose this to a room full of people who can do stuff about it, and we think there's sort of more research required. We're going to be documenting all these results and publishing next week. We were here, so we couldn't do it, but we're going to get this out so everybody's aware. I think we all need to start thinking about what happens when we hit 50% private transactions, and you'll notice I didn't say if, it's when. Because we really don't want the base fee to get non-deterministic. We think that'd be bad for network health. And that ultimately, we're probably going to need to drive down altruistic blocks. By the way, there is this whole other factor on min-bid. And so as this grows, min-bid may come in, and so we may naturally get fewer altruistic blocks. We're not entirely sure about that. Or we could have less private flow. You tell me, was less private flow something you're interested in? If you're a searcher, that's a good thing. If you're on the other side, it's not. And there's all sorts of interesting dynamics. And maybe we need to start thinking about adjusting the 1559 fee asymmetry that exists today. And that was Gas Matters, new sources of base fee volatility with 10 seconds left. There you go. Thanks so much for listening. Appreciate it, everybody. Cheers.
All right, thank you very much. Presenting something new as well. Love that. Good alpha. Next up, we have John Adler joining the stage. Here he is, approaching, with the merch. Which the merch, looking good.
Okay, good afternoon, everyone. GA, I guess, as it was. I'm John. I'm here to talk about resource pricing yet again. This is the third time I'm talking about this at a conference that's EthCC or adjacent. Okay, thank you. Okay, so where did this series of talks start? So they started at EthCC4, I believe in 2019, 2021 down there. You can see the picture of me here. So in this talk, I started talking about blockchain resources from the perspective of a multi-dimensional market, and that there's multiple independent resources in blockchain systems and blockchain state machines that need to be metered and priced in various ways. Some good, some bad. I will later in this talk kind of go into more detail on some of these, but there's kind of an overview of what was described in these talks if you want to go back and take a look. After that, I described how on Ethereum, gas is used prior to EIP 4844. Gas is used as this kind of uniform way of metering resources on Ethereum and resource consumption on the blockchain. Other blockchains do things potentially slightly differently, right? Bitcoin also has some mechanisms for metering things, and it also has some, not a gas schedule, but some sort of resource consumption schedule. For example, on Bitcoin, signatures that use SegWit are priced 4 times cheaper than, well, not signatures, but witness data is priced 4 times cheaper than non-witness data. So that's an example of, a resource schedule. And using these limits, we can kind of, using the schedule, we can impose limits on the resource consumption of the blockchain on full nodes. Okay, so I can talk. Oh, my bad. Okay, so I can talk. So this one was at ECC 5. Unfortunately, I don't have the one with the title slide, but it's okay. Next year we'll do one with 3 levels deep, and I'll put it on my T-shirt as well. We'll start a trend. So this one here was the second one in the series. I talked about how the free market, which is, if you have a market for block space in the form of the gas price, it's a free market, or maybe it's not, but it's some market. Free markets are not very good at pricing in negative externalities. In other words, things that happen to not the market. An example of this that I gave in the talk was pollution from plastics, right? Like manufacturing plastic is fairly cheap, using plastic is fairly cheap, but it has very serious long-term effects that don't directly affect and don't immediately affect the producer or consumer of the plastic. Rather, they have effects on the planet and everyone in general, and these are long-term. So, if you appropriately priced plastic to account for these negative externalities, it might be much more expensive. Who knows? But as it stands, the free market is not very good at pricing negative externalities. Why is this relevant to the blockchain space? I'll get to it in a second. So, and another point that kind of ties into this, that we'll kind of synthesize together, is that on Ethereum, you have a single market for resources. You have gas, or at least you had at the time. And that's not exactly a very good way of metering multiple resources that are independent of each other, such as, at the time, there's things like storage, state growth, bandwidth, compute, etc. Having a single uniform metric for these things and a single market is not exactly very great. And that's why, in more recent years, various blockchains have been, and various ways of building blockchains and blockchain stacks have gone towards a more multidimensional approach for resources. And the way that looks is you'd have separate markets for different resources. Okay, so in any market, you have supply and demand. And where the two meet, you end up with a price. This is obvious, but also this is how the gas price or the transaction fees work on any blockchain, assuming that they have a free market and they're not permissioned. Assuming they're decentralized and permissionless, right? There's going to be a free market for inclusion on the blockchain, for use of block space, and therefore for use of resources on the blockchain. And you can't really control demand directly, but you can control supply, and you can control how that supply is used through what I called at the time, and I would still call it that, which is regulation. Right? The gas schedule and how it changes is a form of regulation, and it directs people to using blockchain resources in a certain way. Right? If you make one resource more expensive through regulation in the form of social consensus, then that resource will be used less because it's more expensive. Great. Let's see if there's any other notes. Okay. Next slide. Okay, now we're going to kind of dive into the meat of things. So what are the different blockchain resources? This is not necessarily a comprehensive list, but there are various kinds. Right? You have CPU cycles. This is commonly called compute. You have power, which is not many people talk about in the blockchain space, but if you're running on, let's say, a phone or a low-power device, then power actually becomes a non-trivial concern. Just because something runs fast, if it uses a lot of power, that could be very bad for a phone, for example. So in certain contexts, that could be a consideration. You have network bandwidth. You have memory. This could be both memory usage, memory capacity, and also memory bandwidth, which are two different things. And then you have disk, which could come in the form, again, of disk I/O and also disk storage, long-term storage. And the storage could come in flavors of hot storage, like in state, or cold storage, like chain history. So as you can see, there's various different resources, and you have to somehow price all of these different resources that aren't necessarily dependent on each other and how they're used. Like you could imagine a system that uses a lot of storage, but that uses very little compute. Like you just a DA layer, for example, right? A DA layer doesn't process complex things, but it just stores a bunch of data. Okay. So how do things work in the old EVM pre-EIP 4844? It works with a single dimensional resource pricing model, gas. And the way it works is, rather than focusing on like resource pricing, really it's resource markets that is the important thing, right? You can hear people talk about resource pricing and whatnot on Twitter, but the real thing that's important here is how many markets are there. And in this case, there's one market, right? Pre-EIP 4844, you had one thing, you had gas. There was one market for gas, no market for anything else. And this gas, the way it modeled the usage of different resources in this regulation is there was some sort of fixed ratio, in costs between different instructions in the EVM, right? Storage was 20,000 gas under certain conditions. You know, an add might be, I forget, I think it was 3 gas or something, right? There was some fixed ratio. This ratio could be changed through changes in regulation. You know, those changes in the social consensus of what is Ethereum can change the gas schedule of the EVM. But ultimately, there's a fixed ratio. Okay, then how does it work in a multi-dimensional resource pricing world? You have multiple markets, right? That's kind of the key differentiator. You have multiple markets for the different resources, and the ratio of pricing for those resources, at least within those markets, because it could be the case that one market, for instance, storage is available in one market, and it's also available in a different market. But they're two different markets, because one market might have storage plus some other stuff, and the other one, say, it might be just storage, which, you know, is sending an EIP 4844. So the ratio between these, you know, the resources on the different markets, it's implicit and it's floating. You know, depending on what price the market decides to set, the intersection of supply and demand, that's kind of where you get the implicit ratio, the implicit setting of price for these different resources. Okay, so let's think about examples. Celestia and EIP 4844. I'm not going to cover in this slide just yet the dynamic, EIP 1559 style resource pricing for EIP 4844, because that's actually orthogonal to the fact that there's different markets. You could have built a system like EIP 4844 with blobs without that. Obviously, you wouldn't have, or potentially you would. But for now, I'll just talk about the fact that there are two different markets. So the way they work is they have one market for execution, and they have another market that's purely for data availability. In other words, not storage as in state, but storage as in like historical blocks, block data. And there's kind of a difference between these two. One of them is that EIP 4844 is a single chain, Ethereum, that provides these two markets, while another one, Celestia, is multiple chains that provide these markets, in the sense that Celestia doesn't provide a market for execution, but rather the market for execution is available on a different layer rollups. For what it's worth, Ethereum also has such a thing, so Ethereum doesn't just necessarily have two markets for resources. It actually has, one, the base layer Ethereum, then another, also the base layer Ethereum in the form of the EVM, and of course, the rollups have their own markets. Okay, and if you want a kind of very formal treatise on resource pricing and multi-dimensional resource pricing, there's an amazing paper along with a follow-up by Theo and his colleagues. Is definitely one to look at. Okay, now let's do some case studies now in the last 10 minutes, and let's see how DA markets interact with the base fee. And this is EIP 4804, the thing that I was alluding to earlier that I didn't talk about in the previous slide. Okay, so for EIP 1559, and when you have any sort of dynamic fee system, where the base fee of the system gets modified over time completely programmatically and completely based on the usage of the market, how do you set the target and the limit, right? We'll see how to set it concretely later, but first we can talk about what are the resource constraints, and we use that to set the limits. So there's two different types of resources. One of them is burst resources. The other one are sustained resources. And these are kind of the two constraints that we can use to determine what our limits are. So what is a burst resource? It's something that happens over one block. In other words, something like, can I even execute this block within the block time? Can I verify this block within the block time? That's an example of something that would be a burst resource constraint, right? It could be the case that, say, a block is just too large and you literally cannot verify it within the block time. Then, of course, if your block is larger than whatever you can verify in the block time, the blockchain just won't work, right? So you'd probably want to set some limits based on that. The other one is sustained. So this happens over multiple blocks. So burst resources are only one block, not two blocks, and not three blocks. It's just one block. Anything that occurs over multiple blocks, things like state growth, for instance, the growth of history, is some sustained resource, and that introduces a constraint. So the target for EIP 1559 style dynamic pricing, you want to set this using the sustained resources. The burst resource constraints don't matter at all for setting the target. Where they come in is when setting the limit. You want to set this as the minimum of what you can, the resource constraints that are burst and sustained. Of course, you want it to be the case that you never exceed the burst constraints available to you, because if you do, then the blockchain just won't work, right? And also, you don't want to exceed over a period of time, which is where you set your limit. Well, actually, where you set your target, really. You don't want to exceed over a period of time some usage of resources, such as state growth. Okay. Now, EIP 1559, the real bottleneck thing, and the reason the target was chosen, and the limit that was derived from the target is state growth, which is a sustained resource. Right? You want the state to grow at most at a certain rate a year, because the state continues to grow and never shrinks, because we don't have things like state pruning or things like state rent, right? People have talked a lot about state rent in the past, and it kind of didn't go anywhere. Sorry, Alexi. But like the bound that we choose for the target is based on the state growth. Okay, now what if we don't have any execution? What happens if we want to price, such as an EIP 4844, what if we want to price data availability? There's no state growth. Right? State growth doesn't matter for data availability because there's no state, it's just block history. So what resource would we use? And what would be the limits for the burst and sustained resource constraints for data availability? I won't actually answer this question. I'll leave that as an exercise for the reader. Okay, let's do another case study, which is very interesting. I had to ask Anatoly and Mert on Twitter about this the other day, because it turns out Solana doesn't work the way I thought it worked as of a couple months ago. But how does Solana implement state rent? Like I mentioned, a lot of Ethereum resource pricing, a lot of the regulations, as it were, around resource pricing on Ethereum are derived from the state growth parameter, ultimately. Right? That constraint is something that's really, really significant in how resources are priced on Ethereum. Solana has some form of state rent, or does it? We'll find out. So how does state work on, or how does resource pricing for state on Solana work? Accounts on Solana, which are similar to accounts on Ethereum. There's some differences, but they're not relevant for this. Basically, accounts periodically pay rent for the state. Paying rent decreases the balance on the account over time. Eventually, it'll hit zero and be pruned from the state. So in this way, you don't have to worry that much about state increasing forever, because it means if you have some state, some contracts or whatever that just aren't used, well, eventually they'll stop paying rent, and then they'll just kind of leave the state. This is amazing. But actually, that's not how it works at all. But accounts can be rent exempt if you make a deposit. If you make some sort of minimum deposit, then the rent logic doesn't apply. And I say large in quotes because it's actually not that large. I think it's a few dollars, I don't know, but it's not a significant amount of funds currently. But then again, Solana is doing its thing. But the state rent, as of a few months ago, this whole logic that I described in the first line here actually was removed. The way it works is that you can post a deposit, same as you did before, and any transaction that tries to reduce the balance lower than this threshold It just doesn't work. It just fails. So in this way, you don't need state rent. Rather, you need all accounts to maintain some sort of deposit. And this is actually interesting because implicitly, like a second order of consequence of this is that you've effectively capped the size of the state, because each state element isn't just free to write to, and then like that fee is recycled into the system. Every account on Solana needs to have some sort of bond associated with it, and that is very finite. There's no recycling. So you effectively cap the size of the state, which is an interesting solution. Now, there's a caveat here, because apparently there's some cases where instead of periodically deducting state rent, it just kind of happens all at once based on certain conditions over time, which we won't go over to. But what is the challenge? And this last line here around garbage collection and preventing replay attacks was a big challenge for implementing state rent on Ethereum. Basically, state rent on Ethereum, they wanted to prune an element from the state, but in order to prevent replay attacks on Ethereum, you need a nonce. Right? Each account has a nonce, and if you completely remove that account from the state, now its nonce would reset to 0, and then replay attacks would be possible if someone ever started using the account again. So how does Solana do it? They actually don't use a nonce. Instead, they just say, okay, a transaction has some sort of time to live. It's fairly short. Transactions within this time window, which is canonical to the chain, it's a consensus rule. There can only be one from this account. So that's how you prevent short-term replay attacks. And there's no long-term replay attacks because every transaction basically has a very short time to live. So in this way, they don't need nonces, and not needing nonces means they can actually completely prune things from state. And that has allowed them to have this different model of pricing state than Ethereum. Now they can do this thing like the state rent stuff, where they expire things from state that Ethereum can't do, because Ethereum uses nonces. Okay, now how would things work with a modular layer? Such as you have Celestia with rollups on top, or you have Ethereum with rollups on top. That's an example. So this one is interesting because you have two independent markets. Rather than having a blockchain that provides atomically two markets, you have two blockchains or two systems, or more than two, that each have their own markets. And this is, let's go back. This is different, of course, and it has some challenges. One of the challenges that we've seen in various rollups on Ethereum, for example, the challenges around how do they actually price the resources that you pay for on the L2, right? Arbitrum has a notion of L2 gas. I think Optimism has the same, right? And like how you price L2 gas in terms of L1 gas, and therefore in terms of the fiat dollars that are required to actually run the system, is very non-trivial. Okay, last slide, I believe. Yes, last slide with the last 20 seconds, which is how as an application developer, how does resource pricing affect you? Right, you're not actually necessarily tied to just your hands aren't necessarily tied. You can do some stuff with resource pricing. One of which is whenever people do manual contract optimizations, they're working around the regulations of the gas schedule. Second one is gas token. Someone said, hey, there's a loophole in this regulation. We can exploit it to reduce the cost that we pay under certain circumstances, and turns out those certain circumstances were quite numerous. And gas token was eventually killed because regulators don't like loopholes. Or you can change the regulations. T-Store is an example of there were resources available, memory, but using memory in a certain way wasn't available in the EVM. You could not. This is not like T-Store doesn't actually use storage. It entirely uses memory on a physical computer. But you couldn't actually use this memory in a certain way because it wasn't exposed in the EVM. But through changes to the EVM itself, to the state machine rules, application developers pushed this through, and now you can use memory much more cheaply. What happens if you're building an application-specific chain, like using Cosmos SDK? You can actually go in and, depending on what your application does, you can go and change the gas schedule application to make it more optimal, based on things we talked about today, or things that you see around, or if you use one resource very heavily, or one less heavily, for instance, well, you can be your own regulator. Okay, and then that's the end. Thank you, everyone.
Thank you very much, John. It was great. I mean, we are now 4 talks into Define the Income, Chapter 3, and we've heard now twice about pricing, so I think it's time to pivot back into some more theoretical discussion. So, gonna welcome Evan Forbes, come on up, and talk about fork choice and based.
Yes. Nice. Hello, everyone. I hope you're having a good Modular Summit. Before I even start my talk, thank you all for coming. And also, it's easy to wake up in the morning and work all day when I get to work next to, like, adjacent to, or even with some of you. Just because you guys are so smart and so much fun, and we have so many shared goals. So I deeply appreciate that. And the motivation for this talk was, one, I'm admittedly a bit frustrated why we're not prioritizing some of the things that I think we should be prioritizing, and the vibes on Twitter, at least in Cosmos and Ethereum land, have been way off. So I'm hoping to try and energize people, get people a little amped up on some of the innovations in the space. So anyway, I'm going to start off with a quote. Apps that can capture their own MEV will outcompete those who cannot. They will outcompete those who cannot. Now, just because Abe Lincoln said this doesn't mean it's true. But if it is, this means something. This means that things like this, where this is the validator tips, so the tips to the validator for Solana, I believe, this means that this is going away. Because if apps are capturing the value, now validators are not. This is a change. This is a change in the status quo. Same thing for Arbitrum. This is how much ETH, at least in revenue, that Arbitrum has captured, and they're not going to be able to capture all this anymore. It means something else too. It means if you are the person or the entity that's doing this infrastructure that is allowing applications to capture their own MEV, guess what? You win. Your margin is my opportunity. I drink your milkshake. Cucks, meaning the people who are enabling applications to capture their own MEV, so they're seeding their ability to capture MEV, will eat your margin, and ironically, there's nothing you can do but watch. Now to the title of my talk, based rollups and fork choice rules. Based rollups, along with the fork choice rules, I argue, are some of the most powerful tools that we can give applications to capture their own value. So applications are going to capture their own value. It's inevitable because they're going to be able to outcompete the other ones. And here are the tools that we're going to use to do it. And anyway, there's one blocker. Technically, arguably, maybe 2 or 3, but really there's only one, and it's censorship-resistant sequencing. This completely unblocks being able to programmatically capture MEV, because the status quo is apps must execute only the transactions that I want, because I'm the proposer in my basement. I'm this like basement Karen proposer in the order that I want. It's absolutely ridiculous when you think about it. It's completely antiquated. It's like, why? Like, it just makes absolutely no sense. It's completely just like this tech debt that we've just inherited, and it's time to fix it. So we have some people who have been talking about this for quite a long time. This is agnostic Chad. So apps should be order agnostic. When you have censorship-resistant sequencing, you can have apps pick the right transactions that they want. That's best for them in a programmatic way. You don't have the proposer pick it. You have the application pick it. This is credible comparisons. Most of the time it's framed as a credible auction, but fundamentally this is just a credible comparison, right? In an auction, I'm just comparing the best bid, right? And only apps know which transaction's best for them. So here sort of illustrates the point. We have, at the top here, we have these transactions that are censorship resistant. Normally, the Karen proposer would pick the poop emoji one, but our application picked the fire one, because that's good for the application. So if this was like in the case of like a liquidation, for example, the proposer is going to pick the liquidation that pays it the most money. It's kind of trash. Where the one here picks the one that's best for the application. That could be burning the applications token. That could be a million different things, and it's entirely arbitrary. So now we're going to talk a little bit about based rollups. Based rollups are incredibly powerful because they inherit the censorship, the finality, and the reorg resistance of the sequencing layer. They just inherit the entire sequencing of the sequencing layer. And it's actually really easy to do. You literally need one thing, and it is just to be lazy. Being, in this case at least, being lazy is a superpower. I'm not going to execute the transactions until they've already reached consensus on them. Once I have that, then you already have a base rollup. I think every single Cosmos SDK chain already works like this. You already use deferred execution. So it's not even something like that difficult to have a based rollup. And based rollups, since they inherit the sequencing, they're just like a smart contract in that way, where they can be, you inherit this, like when I deploy a rollup, I don't necessarily always get all of the censorship resistance or all the liveness, because you can have a centralized sequencer. But with a based rollup, that's not the case. It's just like a smart contract. Simultaneously, it's not even nearly as limited as a smart contract, because now I'm almost close to a full L1. Not quite. I'm limited by the sequencing that I'm inheriting. But besides that, I have all the normal access that I would to, like all the customization that I could make with a custom chain. For example, you can build the block however you want. I don't necessarily think this is a good idea, but you could simply order all the transactions in a deterministic way. You could literally just order all the transactions that are censorship resistant, right? You can order them by gas price in your token, because you don't care about the base layer's token. You can execute the transactions in whatever VM you want, in whatever easy way you want, but this end block one is actually really fascinating. It makes things like order agnostic applications really simple, because most of the time with an order agnostic, like in the case of a liquidation, right, you sort of keep track of all the liquidations, and then at the end of the block, you just pick the right one. The protocol picks it. It makes gas price easy. Like your users don't have to like run these crank transactions to sort of pay for all the gas to do all the comparisons. You just do it at the end of the block. You have block validity rules. Block validity rules are some of the most powerful things that you can do that you can never do with a smart contract. So you can stop all valid blocks from being produced if you don't have, for example, like an Oracle update. So this is something like Slinky that already exists that you can use in Cosmos. You can do the same thing on a rollup. Oh, and you can reduce your reliance on multi-sigs. This is like, sadly, most of the state of the industry at the moment is we make heavy reliance on multi-sigs. Instead, you can use hard forks. You can kind of see this guy's quads. They're very large, where if you go back, if you look at those quads, hard forks. Okay, fork choice rules. Fork choice rules rule. They're kind of insane because you can mix and match some of the properties of proof of stake and proof of work, which is like really mind-blowing that I don't really hear people talking about this. You can have permissionless block production. You're inheriting the sequencer set, right, of the L1, but if it's truly censorship resistant, anyone can produce a block. You don't need a token, right? This is what the proof of work people complain about all the time with proof of stake, is like, oh, well, no, it's not really permissionless because you need to have a token. You need to be able to delegate to you. You don't need that for a base rollup. You can have credible comparisons, but like before, where we were just talking about like having individual transactions and picking the correct one, except for you can do this for an entire block, right? Anyone can produce a block or a header for your block, and you can use a constraint, so however you define your constraints in code, can pick the best block. All you need to do is you timestamp and publish your transactions, and then anyone can produce a block that is the most optimal because you just compare it with your fork choice rule. However you define what an optimal block is, again, this is incredibly arbitrary and incredibly, incredibly powerful. A lot of people talk about like using convex math to convex functions. I think that's what they're called, convex functions, in order to optimize things for AMMs. You can do that here. That's your optimization function. You can have tunable finality. So you are limited in finality. For example, like if you don't have single slot finality, then you're sort of limited. But if you do have single slot finality, then as a base rollup, you can change that. You don't need to have single slot. That's the minimum. But you can have even greater, because in some scenarios, it's actually beneficial to reorgs. Reorgs are not always bad. They could be good. In most cases, probably bad. But in some cases, they could be good, especially if your block's like half a second. If your block's 12 seconds, maybe not. But if your block is half a second, then maybe reorgs could actually be good. You could just have a simple rule that's if you improve the function by so much %, now you're allowed to reorg. Or if you can fit more transactions in from the original transaction set, you fit more trades in, you made more people happy, now you can reorg. And one of the last things that I'd like to talk about is that Celestia is actually the perfect protocol to do this. Everyone has the things that they optimize for. There's trade-offs for everything, no hate. Ethereum, at least from my interpretation of this, tends to prioritize solo staking, or Celestia tends to prioritize light clients. And this changes the design space, at least for so far. Right? With Celestia, we have fewer validators, and we have some stakers. But the most important piece right here is light clients. Light clients can hold the validators accountable because they do data availability sampling, because they force the validators to have fraud proofs or validity proofs for every single thing. And because of that, you can have fewer validators and still be decentralized, because the decentralization doesn't come from the number of validators, it comes from the light clients. It comes from us verifying things on our phone. So because of that, the design space is much different. We can have way faster blocks. We can still have efficient, robust, and optimistically fast gossiping. And even if the topology changes, like you can have a stricter topology here. So here we have like a validator directly sending votes to to all the other validators. And the reason why you would do that is because it's super fast. This is how you get like half a second block time. But even if that doesn't occur, the only thing that changes is blocks slow down a little bit. You're still just as robust, even if the network isn't in the most optimal way. But as the network becomes more optimal, the faster things get. And even if things are, and I would like to note that fast here, I do not mean high throughput. High throughput is always a base thing. It will always happen. But speed is in like, I sign a transaction, I look up and it's already included in a block. That's what I mean by fast. Okay, so sometimes I feel like when we hear things, we sort of gloss over them if we hear them too frequently. And a lot of times we hear this every single week. There's new paradigms that have the promise to change the way we interact and transact. I feel like in crypto, many of us, we get into this space because we want to improve things. We see the status quo, and we're not satisfied. It's so easy to become disillusioned with the status quo. And we really have an opportunity to change things. I'm not saying that I know how to change things for the better, but I do know what doesn't work. And I think it's like feasible that when you have all of these systems that are constantly trying to capture value at every single interaction, every single transaction, that it compounds into complex problems that seem like you can't solve them. So we saw this in Web 2. People said nice things, don't be evil, right? Of course, didn't really work out that well. What we want is can't be evil. That's much harder. We have to encode these things. But I really think that we can get there. And with can't be evil, like, again, I don't know a perfect solution, but I do know, just from like anarchist values, that even you can't really pick like a perfect solution for everyone, but at least they can pick a solution for themselves. And if they're not happy with the outcome, they can pick a different solution. At the very least, we can aim for that. That seems like a safe bet. And we don't have to pick these systems that are constantly trying to extract as much value as possible. I was stuck at the airport, like many of us were recently, and I ran into a VC, and they got me talking. We started talking about Celestia, and they asked me, they were like, oh, how does Celestia capture value? This was like the first question that they asked me. And I was like, bro, it's like, you totally missed the point. I was like, we're supposed to build a system that doesn't capture value. That's what we're here for. We're not here for capturing value. It's absolutely insane. So, I don't know, when people are sad on Twitter, just, I don't know, remind yourself that there's like a lot of people like us out here. We're trying to improve things. We kind of don't care. No matter what happens, we're going to build these systems. We're going to forego profits, and we're so determined that we're just going to outcompete everyone. It's like, we can have public goods that are designed by people like Satoshi and Vitalik and Mustafa. We're just going to use those, and we're going to build them, and there's nothing you could do to stop us. We have fancy math, and we have fucking computers. And so we're going to do whatever the heck we want. So fuck the status quo. And fuck the status quo, and cucks are chads. Okay, that's my talk.
All right, for everyone who saw his talk last year, you get the follow-up here as well, but maybe we'll have to do like V3 next year, the cuck update. All right, next up we have Shay. Shay, as you come up and get a microphone, I will pull up your slides.
All right. Hi, everyone. I'm Shay. I'm from Flashbots, and my talk today is going to be an optimistic and futuristic talk about what MEV on Ethereum could look like in 2025, thanks to, in particular, new technologies like trusted execution environments, or TEEs, that have sort of fundamentally changed the trade-off space in MEV. First, I want to briefly explain why you keep hearing people talk about TEEs, why now, and why in MEV we care so much about them. Second, I also want to look at how TEEs can upgrade the MEV supply chain, so from block building to searching to relays, and even how we actually kind of define those roles to begin with. So, why TEEs? I think it's long been clear that the optimal MEV application, like a block builder, will have 3 properties. It'll be fast, meaning it's performant, it lands transactions quickly on chain, which is very key for UX and high-load use cases like searching. It'll also be private, which means that it keeps sensitive data from being leaked and front-run, which is important because information actually has financial value in MEV. And finally, it'll be decentralized, meaning that it keeps no one party can control the system, so everybody can trust it to treat them equally, which is really important actually because in block building, value increases combinatorially, not linearly with the amount of flow that you have. So a decentralized builder will be able to create more valuable blocks, because it can capture more flow from parties that would otherwise compete with each other and sort of maximize the natural economies of scale. There's actually a lot more to say about this trilemma, but for now, I'm going to move on. I did give an earlier talk at ECC if you're interested. But I think the TLDR from this is that the reason we call it a trilemma is because so far it's not been possible to get all three of these things at once. All we really have today are partial solutions. So centralized builders are fast and private, but not decentralized, and you actually have to trust them for privacy, which doesn't really scale. The public mempool is decentralized and fast, but obviously not private, which means that users tend to get front run and then they fragment their flow to private mempools. And finally, cryptographic privacy could actually solve this, but it isn't performant enough today for MEV use cases where basically every millisecond counts. So the reason that you keep hearing people talk about TEEs is that we think they can solve this trilemma because they give us privacy and integrity without having to trust someone. So instead of trusting a centralized builder, you can just safely send flow to any TEE operator. Like a trading firm, for example, could send their bundles to a builder run by another trading firm. And because of this property, we can actually get a lot of people to spin up a lot of these nodes, which gives us architectural decentralization. You'll actually probably hear a lot more about TEEs in other talks, so I'm not going to go into detail about how they work. What I actually want to focus on is the properties they give us and what that means for applications. Specifically, can you actually run applications in MEV in this, like block building? Are TEEs fast enough, basically? So we tried this. This is the Flashbots Rust builder. It's a new block builder that we open sourced about a week ago, and it's fast, builds blocks in sub 100 milliseconds. But we basically wanted to know if you take this really fast builder and you put it in TEEs, will it still be fast? So not to front run myself, but we did that, and it was fast. It built blocks in sub 100 milliseconds. So once we saw this, we thought, well, okay, that's very interesting, but benchmarks are easy to game. We don't know if we should trust this, so we should actually test it out. We should put half of our production builders in TEEs. So we did that, and they actually started landing about the half as many blocks as our vanilla builders. This is actually a screenshot from a couple months ago. Recently, it looks a little bit different because of some unrelated quirks in our infrastructure. But what's very interesting is when we normalize for that, they're actually on par. The final thing I want to note is that even Flashbots can't see your bundle data. So the code that we're running is actually open source, which means we can attest to what's running in the TEE. So if you submit a contribution to our builder, you can prove that it's running in prod on one of our TEEs. And if you submit bundles, you can check exactly which version of the code is live. And as this slide says, we actually have a working builder with attestations today. So if you send to it, we don't even know what you've sent us. So the answer is actually yes, you can run block building in trusted hardware, and we're doing it today in near native performance. And this is one of the reasons that you've probably been hearing about TEEs so much, because we can finally use them to performantly and securely run some of the most intense MEV applications. And this really opens the floodgates, I think, for what we can do. So what should we do with this? There are three main things that I want to look at: builders, relays, and searchers, and how we can upgrade all of them with TEEs. So I'm going to start with block building. Recently, we have heard from a number of users that the current MEV auction on Ethereum is not serving their needs. Generally, to speak in some high level, what most of them want is a sealed bid second price auction, where bids are private and users are refunded, so they only ever pay the second highest bid. And the reason many people want this is because it tends to be simpler and cheaper for users. So what's interesting is one property we get from the TEE builder is that it is a credible private auctioneer. TEE operators can't tamper with your transactions or selectively censor them, and it's easy, obviously, to encrypt bids and keep things private. And this means also that the TEE must execute the rules of the software, like an auction as you define it. So we built this. As of this week, we're giving second price refunds to everyone who submits to Flashbots. So if we could include you at a lower price, you get a share of our builder profit. That's it. It's pretty simple. What's notable about this refund rule is that it's open source and we can run it securely in TEEs. So this is a screenshot from our public docs. And that means that there's no way for anyone to tamper with the auction because the TEE builder actually can't change it without invalidating its own attestation. And this means we basically have a credible second price sealed bid auction, that's a mouthful, implemented via refunds in this TEE builder. And like I mentioned, a lot of people have been asking for something like this for a while, so I wanted to look at two cases that I think are pretty exciting. The first one is searching. So searchers really want to pay the second price on their bundles, and there's a very good reason for this because they make more money. We looked at a bunch of markouts recently for some SexDex firms and tried to estimate what would their profit have been if they paid the first versus the second price. And we saw that in about 3 months on just one pair, so this is ETH/USDC, the difference in those prices is something like $1 million for the top firm. So paying the second price is kind of a big deal. It's actually such a big deal that many of these firms today are vertically integrated and run their own block builder, because if you run a block builder, you can make the MEV-Boost auction second price by basically observing all the other public bids and kind of adjusting your own bid accordingly. But while this is a very rational behavior, you make more money this way, it has a bunch of negative externalities. If you're in this room, you've probably heard us talk about these, but you know, vertical integration tends to be centralizing, causes order flow to fragment, leads to rent seeking on user transactions, and it just kind of degrades the whole market structure. So what's exciting is that with a TEE builder, we can let everybody participate in a second price auction, so searchers can make that $1 million or whatever in extra profit without actually running their own block builder, which actually could be key to reducing some of these like very core centralizing forces in MEV. And searchers also aren't the only ones who could benefit from an auction like this. There's a lot of demand from rollups too. So if you remember a few weeks ago during the Layer 0 airdrop, there was a massive spike in transactions from users on rollups who were trying to claim their airdrop. And this caused the L1 blob market to spike because rollups were trying to post DA, and it basically stayed that way for hours, which meant that blobs could not get included quickly, consistently, and they all paid really high fees. So this is a funny example. They actually sometimes paid more than call data, which is what blobs were supposed to replace. So this is, I think, Blast paying something like 5 ETH more for their blob than they could have paid in call data. I think Matt from Block Native shared this example, which I think is funny. And there are a lot of reasons why it's hard to land blobs. Also, like, a couple of these things have to do with what I'll call the UX. So basically, you have to only choose 1 blob transactions per slot. They're really expensive to replace. They're big. They're slow to propagate. And people are working on this part. But I think even if you solve the sort of like UX side of the problem, there's still a more fundamental issue, which is actually the auction. The worst externalities that we see during periods of congestion with blobs, like people overpaying like this, or waiting hours for the market to clear, these things usually happen because of how the L1 MEV auction is structured. Specifically, it is a public first-priced auction. It's the MEV-Boost auction. And you know what it takes to do really well in the MEV-Boost auction? Well, it's to be as sophisticated as a block builder, and most of those builders are also searchers because of vertical integration. So when blob prices spike, rollups basically have to turn into searchers, and they have to watch each other's bids and manually adjust their strategies, which is extremely tiresome and also just orthogonal to the sort of expertise you want to focus on as a rollup. This is a direct quote also. But what if this auction was second price and the bids were private? Then rollups could just express their true willingness to pay and know that the auction will refund them if they overpay relative to market, which could avoid some of the massive overpayments that we've seen. Also, if the auctioneer is credible, then rollups are protected against manipulation by maybe other sophisticated actors like builders that get involved. And what's nice about a TEE builder is that it can provide both that credibility and, with second price refunds, actually enforce the optimal auction. This is exciting, I think. Preventing centralization in vertically integrated searcher builders, scaling Ethereum through an efficient blog market are really important goals. And the TEE builder basically gives us a path to improve both of these things. Okay, so that's the builder. Now I kind of want to look ahead to other parts of the MEV supply chain and how we can use TEEs to upgrade them. So I think a natural next step here is the relay. Today, if you're not familiar, MEV Boost relies on centralized relays to connect validators with a market of block builders. And these relays provide very essential guarantees, things like data availability, validating blocks, preserving privacy. But in the long term, it seems pretty suboptimal for Ethereum to rely on a few centralized actors to lend something like 90% of blocks. So for this reason, replacing the relay has been a sort of long-standing goal in PBS. But if we want to replace the relay, we need something that gives the same guarantees. I think TEEs are the tool that can give us the same guarantees. Specifically, with TEEs, we could actually change MEV Boost to allow validators to connect directly to block builders. And the flow could look something like this, where TEE builders generate a TEE proof, which demonstrates that their block is valid, and they send that with a header to a validator who can then validate this proof to confirm that the block is correct. And this would actually remove the need for a relay in the get header call of MEV Boost. And on top of that, it actually gives you better guarantees. So it gives you better privacy because the builder never needs to reveal its payload to anybody during get header. It just sends a proof. And this is actually much better than today because relays have to see the payload during get header. It also, I would say, gives us better integrity because the risk of a malicious relay submitting an invalid block is probably much higher than the risk of spoofing a TEE proof, which basically you'd need a bunch of different people to collude to make that happen. So we could actually have better privacy and integrity guarantees and no centralized relay in the loop. I'm actually just focusing on the get header call like I mentioned today, but I think it's exciting to think about what MEV could look like if you actually don't have a MEV Boost relay. Might look like this. You could effectively combine the builder and the relay into a single system. And if the TEE builder can be decentralized as we think it can, then so can this sort of combined TEE builder relay. And also, if you run all of this in one place, then you don't have the latency penalty that we have today with relays. There's no extra hop between builders and validators, and because you have less latency, you can actually produce more valuable blocks. One other interesting consequence of this is that the TEE builder relay might actually also give us something on the Ethereum roadmap, which is encrypted mempools. We want encrypted mempools for a bunch of reasons, a big one being censorship resistance. And if you have a unified sort of TEE builder relay system, then transactions would be entirely private from when they're submitted to this network of TEEs to when they're revealed to a validator. So, in sum, I think these developments on the relay side could give us a path to address two very important challenges. First, the centralized relay in MEV Boost, and second, encrypted mempools. And I think with this step, there's like a picture that starts to emerge of what the next phase of the MEV supply chain looks like, which might actually not be a supply chain of discrete actors as we're accustomed to thinking about it, but more of a single, unified, and decentralized system. So to complete that picture, I want to look at one final important actor in MEV, which is searchers. Okay, so far we've been concerned mostly with public verifiable code, open source code, running in TEEs, but you can actually also, we think, run private programs in TEEs. We've been researching some techniques to do this. I'll call them sandboxing, to give it a word. And sandboxing basically lets you create an environment with very specific constraints so that a private program can run in it so long as it adheres to certain rules. So something like we add restrictions about how inputs can be sent in and what outputs can be sent out so you don't have data leaks. But okay, that's like cool, that's very researchy, you know, what private programs are most interesting? Well, what about searchers? Imagine you could put a whole searching program inside of a TEE with sort of constraints around what it can accept and what it can output to protect both the searcher's alpha and user data. Then you could imagine a TEE builder which sends opportunities to the TEE searcher that generates some new bundles and sends them back. And this actually also unlocks something that we can't do right now, which is searching with full information on private state. So Today, searchers don't actually have access to full information about every opportunity. In an order flow auction, you might only see the pool somebody's trading on, and in other cases, nothing is available. So an interesting example here is at the bottom of every block, there's often an arbitrage opportunity, and these arbs can be quite valuable, but there isn't a secure way to search on them without leaking state information, so many builders just don't capture them today. But if we could make opportunities like this available and give searchers full information when they search, you could actually generate a lot more profit, something like 5 times more. So take bottom of block arbs, for example. With TEEs, builders can safely outsource these, so we could actually get privacy in both directions. The builders and their users get privacy from searchers because they're kind of constrained by the sandbox that they're running in, and the searchers also get privacy if they're submitting back to a TEE builder because it can't see their bundles. And this is actually one of the next things we're working on at Flashbots. This is an internal screenshot of a prototype, so it's very cool. We're also excited about how TE searchers can upgrade other products like order flow auctions, or even maybe create new types of OFAs between searchers who have very sensitive data. So this can make OFAs like MEVShare, which this is a screenshot from MEVShare, 5x more efficient, we think, than they are today. The other thing I'll note is that most of the things I'm saying here, I've been saying searchers, but they can apply to solvers too. So, searching for arbs at the bottom of the block, for example. Okay, so in the limit, you could imagine that the end state of searching starts to look more like this, which is a nexus of TEE searchers all cooperating and passing opportunities and bundles between a TEE builder and themselves. And by doing this, they can actually access net new opportunities without risk to either users or their own alpha. And over time, you might even imagine the TEE builder start to outsource more of its responsibilities to searchers. So even moving on to core functions of block building, like bundle merging. And even beyond that, you could imagine other block builders today kind of joining in and running parts of this computation. And at that point, I think the distinction between builders and searchers starts to blur. It just starts to seem more correct to think of them as being just different nodes in a unified but distributed system of TEEs. So, to close, I think that in 2025, the MEV supply chain might look less like a traditional supply chain and more like a sort of distributed, decentralized network of many different programs that are running in TEEs, with certain guarantees and rules like sandboxes that constrain searchers from exploiting user data, or integrity and availability guarantees so validators receive good blocks. And this could let us sort of break out of today's mold where we've created these divisions of roles for safety and to prevent one actor from centralizing MEV. But now with TEEs, we can actually safely unify essential functions in one place that's both more efficient and more decentralized. You might even call this a single unified auction for value expression, or SWAV if you want to be fancy, but I think what's very clear is that whatever you want to call it, this is where MEV is going in 2025. So very excited to build it. Thanks.
All right, thank you very much, Shay. Oh, did you want to take a question? Yeah, we got one while they're setting up for the next talk.
I'm wondering if you can get everything out of sufficiently robust cryptography that you can get out of TEEs. And if that's true, then is there like amount of time that TEEs are just accelerating what would be a cryptographic future just ahead? Because that's kind of the idea of TEEs, right?
Yeah, I think one of the problems we have today is just performance. Like cryptographic solutions, there are probably parts of this that you could sort of start extracting and replacing with cryptography instead of trusted hardware. The problem we have right now is that the type of privacy you need in MEV is really specific. So you need like basically privacy for shared state and shared computation, which is like fairly specific, so that already kind of narrows what we can use. And then in that realm, the things we have tried, the runtime is just insane. It's like 5 hours to do something you could do in a TEE in like however many milliseconds. So I think that's the biggest barrier that we see, but in our roadmap in the future, I think we've been doing research on more like math cryptography rather than hardware cryptography, and we want to start extracting things and using them, but I think it'll take some time.
I just realized I can't clap and hold the microphone at the same time. So next up, we have a great panel of Hart, and all the panelists can come up and get that started.
All right. Thanks, my favorite impromptu panel crew. I was looking for words. Amazing. Yes, you are. Thank you for informing yourself. Appreciate it. For reading and finding where the agenda is actually listed. All right. Well, just so that our moderator, Hart, is aware, the point of this is to really come up with cool, amazing, mind-blowing, useful application, like stuff that you can help applications. And that's why we have Dan. As you know, my friend circle has like less than 5% application people. So sadly, if you're working on applications, please raise your hands. We'll be best friends. Yeah, so
there's no application builders here, Tina. It's just infrastructure.
I've never seen any application builders in any of my conferences, unfortunately. So let's change that.
Okay, Tina, how long do we have? That number?
Sure.
Okay, so this is a last-minute panel. I have not really prepared questions because I didn't know I was going to be on this panel until about 5 minutes ago. But we're going to do a real-time brainstorm around what application innovation can block building, solving, sequencing uniquely enable. First, we should do quick introductions. I'm Hart Lambert. I am the co-founder of UMA and Across. And Across does use solvers to do cross-chain intents to facilitate very fast cross-chain bridging. So I might insert a few comments along the way. Dan, why don't we start with you and just say what you're up to, and we'll go this way.
Hey, I'm Dan Olitzer. I'm founder of Nascent. We're early stage investors and builders in the space. We invest at the pre-seed and seed stage. We're involved with a number of projects doing stuff in the kind of MEV flow and intent space as well.
Hey, I'm Josh Bowen. I'm one of the co-founders at Astria. We're building a shared sequencer network, and that implies it's like a decentralized sequencer, and we assume, because it's a lazy sequencer, that we have kind of roll-ups doing block building before submitting to the sequencer, and maybe that implies cross-roll-up block building.
Hey, I'm Marcus, founder of Propellerheads, and we build solvers for all kinds of intent auctions, such as UniX, CowSwap, 1inch Fusion, and others.
Hey, I'm Dan, or DMars. I'm a credible auctioneer at Flashbots, and we're building all the super cool stuff that Shay just presented before this.
That was really efficient, guys. So let's keep going. But it was really efficient. All right, what I thought of in my 5 minutes of prepping for this is let's start with what applications have actually been uniquely enabled by block building, solving, and sequencing. And since you guys all haven't really thought about this very long either, I do want to make this be a collaborative brainstorm. But what do you guys think we have actually built that required this type of thinking?
This is still like an infra perspective, but I think one of the things that's interesting about specifically maybe like cross-chain things is there's always been this idea of like an atomic cross-chain lock, whatever. I'm going to use like the wrong word, whatever. And the implication was that had like a liveness requirement on like a third party. And we've always known that is like a better than bridging in that it doesn't require like a wrapping and like a trust assumption on the other thing. And I view intent bridges as being like a form of solving that. And the thing that happened is just like via searching, building PBS, we have essentially incentivized the creation of like crypto native market makers who are able to satisfy that. So I think that's one of the interesting things that have become enabled via more of like an institutional development rather than but it was forced by the incentives that we constructed through building.
Yeah, I mean, Josh, you're talking my book here, but Across in solving cross-chain intents, it uses solvers to, in my mind, emulate atomicity. And it's maybe atomicity's the wrong word here, but it by using a third party who fronts their own capital to fulfill a bridge transaction, it appears to the user like it happened almost synchronously, even though it didn't. And I think that is that is a application that like very fast cross-chain bridging is enabled by this like solver-like thinking. What else do we have today?
Gasless transactions.
Yeah.
So we have through all the order flow auctions or intent auctions, we now have universal gasless execution enabled not by account abstraction, but by solvers basically fronting the capital and acting as paymasters and taking part of the out tokens or in tokens to pay for the gas. I think that's now become ubiquitous and standard without anybody making a big fuss about it, which improved UX. And we also have batch auctions. Like we never really had batch auctions in TradFi, and now they are a large chunk of all order flow that's being settled, and they work, and yeah, they function well.
I think if we look back at what we're all circling on, it's UX, right? And a lot of the hard stuff we're trying to do on a cryptographic level is going to take longer. It's going to be slower. We talked about the previous speaker was talking about what can be done in T's, what can't. But we get to a better UX faster for what I would consider retail transactions of all types. And it's still fine if you compare to TradFi institutions. If you're moving $1 million or tens or hundreds of millions of dollars, you're fine waiting a little longer and having stronger guarantees and doing things differently. But because you can actually like price risk around using some of these solver frameworks, and there's professional market makers effectively taking on ultimate settlement risk in some cases, some of the main pain points that we see at the retail user level get solved a lot faster with this type of construct.
I think another example too is like customized trading logic. So I don't know which perp dex this is. If someone knows, let me know. But I've heard there's a sequencer that basically is able to like recognize cancellations, which just allows for like more efficient trading on the dex.
Yeah, I don't know what that is, but it is cool. I'd add a couple others. Like if we just want to talk about what block building has enabled. I mean, PBS and MEV Boost made Ethereum usable, right? We were going to drown in MEV priority gas wars without it. And sequencing made Ethereum scalable by having rollups sequence. So maybe the point here is that a lot of these innovations have been infrastructure improvements that have enabled applications to actually be usable, like Dan, to your point about good UX. So maybe that's doesn't answer Tina's question about finding applications, but it does push. I think like the current applications would not function without these concepts.
I think we're looking for like new applications. It's not like a new application because like I'm like a bias. Like DeFi is like the point, or like finance is the point of the blockchains, but if we look from like swaps as like an application or like a product functionality, like we're highly reliant on AMMs, and my somewhat like DeFi naive understanding is that like one of the points of that was the ability to provide liquidity without like a liveness requirement, which is again like a similar thing to like the atomic swapping. There's like a question in my head, and this is like more like shilling Aori's book now, but like, you know, why are we still using AMMs if like basically every single swap that is going through the chain is having like a market maker as like a counterparty to the thing? We're trending that way with, you know, solver networks and like both in like cross-chain and then like in like the aggregation, you know, solvers and Uniswap-X and whatever. You know, should we be moving towards like an order book mechanism on chain versus AMMs? And is that like a new application, or is that just again like we now have more infrastructure that we have incentivized, and now we can provide more efficient just design spaces that provide better UX to users?
So maybe you're saying solvers will actually delete applications. We'll get rid of AMMs and replace them with solver networks?
Yeah, solver network, you know, maybe it's like still backed by something as like a settlement on chain, but that settlement on chain is like no longer an AMM because it's assumed to have like a live entity like interacting with it. It doesn't need this like naive passive liquidity. And like, is that deleting an application? You know, from the user's perspective, they're like, I have token A, I want token B, click the button. I don't really give a damn what happens in the middle. Like, do that as fast and as cheaply as you can for me. But, you know, to date, we have like generally poor capital efficiency from like how much liquidity you must get in like a pool versus like how much volume you do over that pool. So this is again like infrastructure enabling better user experience so that we don't have, oh, I want to go provide low slippage for a user. I have to go get an enormous amount of liquidity to do so.
I think that's an unfair comparison, like taking like V1 AMM implementations on like arguably V1 chain implementations and comparing them to an off-chain centralized order book, and then saying that, oh yeah, obviously that's like better, and we need to move our liquidity there, because if we do that, we're gonna lose decentralization and liquidity, right? And that arguably is an important part of DeFi. And if we don't have that liveness and decentralization and the liquidity, you are probably risking a lot of the structural stability of DeFi.
Yeah, I just think that like there's been a lot of like app-specific sequencing talks and like directions of like apps. I think like the apps are trying to fragment the liquidity and like take the decentralization out of the liquidity regardless anyways. And that like you see like, you know, again, this is not like the purpose of the panel, but like Sorella is like a very good example of them saying like we want the app to have more control over the sequencing rules, and they are doing that in a way to like change where the liquidity goes, but that means that liquidity has to be in their pools to run their custom rules over it. So I think there's somewhat of like, maybe this is pessimistic, but like an inevitability of like the liquidity being more fragmented, trying to capture more value. If that is the case, we should certainly do that in a way that provides the highest quality user experience using the infrastructure we have, and not do that in a way that results in fragmented liquidity, but also a poor user experience, which is somewhat historically like what we've seen, and maybe what we're seeing across rollups.
So Josh, maybe like I could take the annoying like Silicon Valley like bundling, unbundling type framework here, but if we put like a little tiny bit of historical context, we invent AMMs, like a very useful application, and then we invent a bunch of them that are different but the same. And that creates a shitty user experience because now where do you go? Like liquidity is fragmented, user doesn't know where to go. Okay, so that happens, but we've invented something very cool along the way. Then the solver network and what 1inch Fusion and Uniswap-X are trying to do is rebundle all of that by using a solver network to aggregate these different sources of liquidity. And this fits like very much in the modular thing here. So we now have all these different modules, but we now, to make the UX usable, we need to aggregate them back together. And the solver networks seem to be doing that, in a sense, inventing a new application, which is like the better swapping experience. And then, yeah, I don't think it ends there, right? It's like, it's one of those things where we'll invent new AMMs and we'll go the other direction or something like that. But I guess, like, okay, to push forward, so, because we're trying to think what applications can be enabled, where do we think this goes? Like, besides the AMM example and like unifying, or solver networks unifying AMM experiences, what else do you guys have? Like, we got to brainstorm these questions on the spot here, so.
Well, we're seeing a number of teams working on things on the security front, right? Ways that you can look at preventing hacks and pausing protocols and doing things like that before you actually have state updates on chain. And so that's an interesting area because I think we can all agree one of the biggest problems DeFi has is security. And so when you start seeing hundreds of millions of dollars, billions of dollars a year being stolen, if we've got a new tool in our toolbox to be able to prevent that from happening, like that can be a game changer, like adoption-wise.
Yeah, and I'm familiar with the general like Phylax and like comparable like security things that essentially are doing. Again, this is taking advantage of the infrastructure that there was a past dependency in bootstrapping this ecosystem, but now we have economically incentivized like sophisticated entities who are willing to do pre-simulation prior to settlement of transactions. One of the things they can do in that is they can check for various invariants and say, oh, okay, this transaction is going to move this many funds out of this pool. I will set a rule that says you're not allowed to do that. And I think this points to, again, I'm showing your book, but there's an enormous amount of intersections between modern bridging constructions and modern block building, relaying, whatever constructions, where if you look at bridges who have circuit breakers or whatever you want to call it, where it's like, oh, I see one transaction, it wants to withdraw like, $1 million out of a bridge, you just say, no, we stop that transaction. We're essentially seeing that on sequencing or potentially like block building or whatever, where it says, hey, I see some invariant violated that can ideally be defined as some more simplistic kind of predicate. that is like less complicated than, because the risk is someone makes maybe a bug in like a Solidity contract, but you have a more simplistic form of designing a predicate such that you can say, just if this bounce changes by a value over this number, just like reject that transaction, don't ever settle it, and then, propagate a user. So I think the broad category I see of like, block building or whatever we want to call it, is saying we have sophisticated actors that are doing pre-settlement execution and simulation. What benefits can we take advantage there by having this kind of robust entity of actors? I think it's worth noting that we have, less of these actors than we have people that are actually going to do the post-settlement validation, right? We're always going to have more validators and we're going to have builders, searchers, market makers, whatever you want to call them, but we should take advantage of the fact that they are present in the transaction flow for 95% of the blocks.
So yeah, Josh, it feels like you could summarize that as saying we've got, we're tapping into sophisticated actors in the block builder solver type world that give us a better user experience, that we can use the sophistication of these sophisticated actors to do a bunch of things so the user doesn't have to think about them, which I think that seems like a very useful concept. Although it does seem like it's in making better applications, not exactly in creating new applications, but these things now seem very correlated to me.
It also, like, there's certain applications that were possible before on the margin, but they were extremely hard and clunky, and that are now much easier to do, like expressing complex order types, for example, that were hard to implement, like buying a portfolio of assets, and buying a portfolio of assets in flow over time, or liquidating a portfolio of assets, or expressing a pair trading strategy preference amongst a set of assets and weighting assets. All of this was theoretically possible, but you'd have to launch your own pool and then provide incentives to searchers to rebalance your pool. And that's very expensive and hard to maintain. But now with solvers, you can basically inject these conditional order types and have them execute that for you. We already see that in like a prototype version of searchers, or rather like liquid funds, like expressing arbitrage on every solver's API. So everyone who publishes a routing API has the same problem. Someone will come and DDoS you with orders. I want 1,001 USDC for my 1,000 DAI, and you get plenty of those. And they actually go through, like they find opportunities through the solvers. So the solvers are already being abused for, not abused, but they're being used for finding opportunities with liquid trading. But I think that will progress into expressing all sorts of portfolio preferences.
To me, it seems there's like two categories of things you can do here, maybe with specific sequencing rules. So the first is like cool, complex order types. Maybe your like AMM makes sure that like every trade goes the opposite way, and there's like other fun designs like this. But I think all those like end up being pretty financial. There's probably like game specific sequencing you could do that like is like very specific to this, whatever the rules are in the game. I think the second category though would potentially be things you could do between rollups. So, but I think that like opens the boundary a bit because it's not just a single app anymore. But I don't know. It would be cool if you could like make a tweet and then somehow like auto register that in like a prediction market or something like that. I don't know.
I mean, at some point that just looks like webhooks essentially, and you can't. And I don't want to like necessarily encourage. I'm trying to think of like I want to encourage that pattern, just having been in a world where like the webhooks get slightly out of hand, kind of thing, where you now have to trace like one event fires and like how many events fire off of that and what is your traceability of that. But there is these kind of like again flows where one of the things that is like kind of historically been intentionally or not kind of missing from blockchains is sometimes the game people talk about like the missing of like a crank. In Cosmos SK there's a concept of like an end blocker, and you can create like an end blocker code, but in like Ethereum it's often like you're not triggering something that happens on some kind of cadence. But with these sophisticated off-chain entities, you could say I'm going to define some kind of signal and I'm going to register that with you in some mechanism, whether that's on-chain or off-chain. If I do this action, you should take that as a signal to also do this action. And this can kind of chain. This looks structurally a lot like what we see with like multi-hop IBC. Again, there's a lot of analogies between bridging, where essentially I submit one IBC transaction, I have additional forwarding data. That encourages a relay to go do another thing. But we can see that within a single state machine, within multiple state machines, whether those are sovereign Cosmos chains, whether those are rollups. And it does kind of broaden a design space where it allows you to do, multi-block asynchronous execution, where that could be useful from, a UX perspective again. And then from a product perspective, I just am not on the app side.
But I think there's something here to play with, right? So DMARS, you're right. Like, we're on this panel generally thinking from like a financial perspective, and the solver networks let us use sophisticated actors to figure out better, I'll call it financial routing. And I mean that in transaction sense and different constraints and all that stuff. That seems kind of cool. But if we play with this webhooks idea, like DeFi 1.0, people got all so excited about composability. It's like in a single transaction, I could take my flash loan and then swap it here and then deposit in a lending pool and do this kind of stuff too. If we call them webhooks and we talk about it that way, between rollups, and we start having applications that are like app chain specific applications or app chains, the idea of us using a solver network to hook between them at a consumer scale kind of use case, that does seem like it's kind of interesting too.
Well, I still think we're talking financial applications, though, because there has to be an incentive for the solvers to actually step in and take these actions. So it's hard to think of like a pure non-financial application being able to make use of this infrastructure.
Maybe, but if we have like paymasters and that kind of thing set up too, and the costs here are cheap enough, is there a set of things where if I had if we take Web 2 applications, if I have like my Twitter and I have my Gmail and I have I don't know, something else, and it's like an action happens in one and it triggers a set of things in others, kind of like a turbocharged if this then that type setup. Is there cool composability things that emerge there that are a new paradigm that we haven't played with yet?
I think it'd be awesome if there were, but my instinct is probably not, because if you don't need the kind of trust minimization that you have in these kind of permissionless financial applications, just do that with your own centralized service. It's going to be fine. There's no reason you can just do that on AWS.
I mean, it's starting to sound a lot like Anoma.
Tell us.
This architecture. I mean, one of the things that they published was Public Signal. It's an article I don't think I fully read it, but the idea, as far as I understand it, is you can use these intent networks and to invert the economics of the classical economics of systems that we have. You could have credible pre-commitments to purchase a product and use these pre-commitments to trigger a funding of a product at a certain threshold. So it's like an inverse Kickstarter, where you source the needs of people, and then you propose solutions. If the solutions fulfill the needs, you automatically get funded, and you can then do your project. And this could potentially make economics a lot more efficient, because people would freely express their set of needs or their set of wants, and could probably do so privately as well. And only if there is sufficient wants for a certain product, then that product automatically gets funded and you receive the benefits. So you could have a more efficient matching of the worlds that people want to live in. And there's many of these coordination problems today. They're all over the place. I want to go and live with friends for 2 months in a cool place, but the coordination problem is just too hard to do it without someone coordinating it. But the need is definitely there, and it would just happen. If the system existed, it would just happen, if this makes sense.
I wonder, this is just, I'm curious if anyone's going to push back on this. Having these building and sequencing and intent frameworks, it doesn't necessarily unlock anything completely net new that you couldn't do fully on chain, aside from the efficiency gains that you get in doing so, right? We reduce what needs to happen on chain largely to the state updates, but anything that we're the example you're talking about, we could do that on chain and fully enumerate it within a contract.
But today it would be very hard.
Efficient. Yeah,
it would be very hard to because there's a big information flow control piece that goes with that. I don't want everyone to see. I don't want default transparency on all of those. I want like default control over the information. If we had fully encrypted, if we had a fully encrypted chain, then I would agree. But today, I only have one choice, which is full transparency.
Mars.
Yeah, I would push back a bit on it being like not that different than I guess like just composability between apps on L1, mainly because if you're dealing between different rollups, then you can have different execution environments, so they can just do wildly different things. Like you could have one send a tweet out or something, which is just like not even feasible on L1.
Okay, so is our conclusion that block builders, solvers, and sequencers do not enable any new applications? They just make them more efficient and more usable.
Yeah, but the analogy I'd do is like energy or whatever, right? Like you get like an order of magnitude cheaper energy. There are applications that like on the margin were impossible before. People were aware of them. It's not like a completely novel idea, but now people will actually be able to do it because it is sufficiently like easy, cheap, whatever.
Yeah, I like that. And I've always thought the idea if you take a product and you make it 10x better, it's actually a completely new product. And I think there's a lot of use cases here where using the solver block builder sequencer sophistication allows us to build Web3 applications that are 10x better than what you can do on chain today. And hence that application is actually something totally new and different.
And you gain a completely new user group, right? If you make it 10x easier, if you make it easy enough that it's below a certain threshold, that it's within the reach of the average user, you now have also decentralization and public access. Like, there's a searcher example I gave earlier is maybe a simple example. It used to be incredibly hard to search for atomic opportunities. Let's say there's a new AMM a new UniV4 hooklet launches, and there are now arbitrage opportunities there. No searcher has them integrated yet, but maybe a solver has. To find these opportunities, you need to build the entire routing infrastructure. Okay, it's a huge ask. Maybe there's like 20 teams that do that. Now, today, with the solver infrastructure, it's like one API call that you need to make. So maybe with ChatGPT, that's like within reach of almost everybody. But you could even imagine like having a liquidity pool struck in front of that, doing these API calls. And now it's within the reach of everybody, because you can just provide the liquidity pool, and all the yield gets commodified. And you now have a common good where people can just capture this. And so with ease of use, I think you're bringing things back into the commons as well.
All right, guys, I think we took our last minute panel, started with no idea how to answer this question, and came to a conclusion that we don't directly invent new applications. We just make things 10x better, which invents new applications. That feels like a good conclusion.
So sad, disappointed. This is what happens when you have like 4 infra people here.
There were. They're 10x better.
That's such a lame conclusion.
Skills issue.
Burn. Wow. We were not allowed to include TEs. If we included TEs in this discussion, we would have plenty of new applications.
Yeah.
There's a talk on that later.
Do we have Bucky? Yeah, I guess my microphone got censored after I trolled our panel. But where is Bucky? Oh, perfect.
What's up? Get bucked. Y'all got bucked this morning. You're about to get bucked again. Cool. Thank you. Yes. All right. Hit it. Yeah. Cool. Thanks, everyone. So I'm Ethan, co-founder of Cosmo, CEO of Informo and Incubating Cycles. I'm here to talk about how to win friends and TEE fluence people, the case for TEEs in blockchain. So really, I want to lay out a kind of mental model for how to think about TEEs and why we need TEEs and why we can actually use them in a way so that they're only strictly better than what we currently have. And of course, you can use them in other ways too. There are things you can do with them that you can't do with just cryptography. And this isn't an attempt to like dismiss any of the amazing work that's happening in the cryptography ecosystem. All of that is essential, and we need to see that all of that moving forward. But even with all of that, there's still a case for TEEs. And in the meantime, while we're advancing the state of cryptography, there's a strong case for using TEEs. So what are we even talking about? Well, we're talking about private computation, right? And this is the thing that's on everyone's minds. This is pretty fundamental stuff. Privacy is a fundamental human right. So is the right to transact. I mean, that's really what Bitcoin, Ethereum, all these Cosmos, all these kind of fundamental global settlement solutions, that's really what they're securing, this fundamental human right to transact. But to transact privately should also be a fundamental human right, and so we need to add support for that. And so, yeah, right on. But how do we do it, right? There's all this talk about ZK. I mean, ZK tech has exploded in the last 10 years. 10 years ago, it was like moon math, some stuff that we may or may not ever really figure out. And now it's like very practical. It's in production. People are using it all the time, and it continues to accelerate. But ZK is not enough. And the problem with ZK is that it really only gives you privacy when you, as the user, have enough data to produce the proof, right? So it doesn't give you privacy for more global computations. So it works really well when the prover already knows all the inputs, right? And these are examples like Zcash or Penumbra, these sort of shielded pools. The only relevant data that you're publishing a proof about is data you already have. It's your user data, right? And so then you get these very incredible privacy-preserving solutions. But in many of, say, the ZK rollups or in other kinds of applications where you want to do some more global computation, the solver or the prover actually needs access to all the data, right? Just saying they're producing a ZK proof, well, maybe verification is private. You're keeping data private from the verifier, but the prover themselves needs to see all the data, right? So it works for privacy when the user has all the inputs they need to produce the proof, but it doesn't work on these global computations. And so, ZK has kind of become, more synonymous with like, proofs of correctness or integrity or validity rather than necessarily privacy. And it's actually kind of interesting that the original constructions were really about proving succinctly that a computation occurred, and privacy was actually kind of like a trivial add-on to that, right? But we don't really have time to talk about that. Okay, what about multi-party computation? This actually does solve the problem, right? This is like true encrypted computation. This is great stuff. But you're basically encrypting values to polynomials, distributing them across n agents. No single agent can see can see the inputs or the intermediate values or the outputs, so it's great. But you have to trust k of n agents to be honest. And the problem with this is that there's very high overhead, right? It's very expensive at an I/O level, and so if you want to increase, and there's this trade-off between how expensive it is and how many agents you have, because you have to trust some of the agents not to collude. And worse, if they do collude, you have no proof that they colluded, so it's unaccountable, right? So you're going to want to use a large set. But then that can become impractical for certain computations. Now, turns out MPC seems to be actually quite practical today, especially with smaller sets for certain kinds of computations, right? And more projects are using it for for signing and things like that, and that's great. And I strongly encourage more of this. But for large, kind of more global computations, it scales exponentially, or quadratically. So that's challenging. What about FHE? There's a lot of hype about FHE, but actually it's not an independent solution, right? You still need MPC for managing the decryption keys. One way to think about what FHE achieves, it allows you to trade off the I/O overhead of MPC for the compute overhead of FHE, right? So you trade the network overhead for a compute overhead, but you still need to use MPC when you're doing kind of global operations for a blockchain, right? And once FHE is actually gets really faster or much faster, then it will help accelerate MPC, but you can't use it independently of MPC. And it's actually it's kind of useless for blockchains if just a single key can decrypt everything. So that has led our friend Makera, Bad Crypto Bitch, to produce a succession of memes and and to really show this. FHE is the MPC is coming up on it, right? Never ask a woman her age, a man his salary, or an FHE team how they're going to split the decryption key. Yeah. So follow bad crypto bitch. All right. So what are we going to do about that? Well, so ZK doesn't give us private compute. That's too bad. MPC is expensive, and it doesn't give us collusion resistance. That's too bad. FHE is expensive, but at least in principle, it's going to make MPC cheaper one day. And this is like, all of us waiting for MPC, or not me, but some of you waiting for MPC and FHE to be fast enough. So the question is, what's a practical solution that we can use today that gives us sufficient guarantees and that we can combine with other techniques as necessary and as they're ready? You guessed it. Pick TE, dummies. This one's mine. Big fan of Amy Santiago here. All right, so let's talk about trusted execution environments. Basically gives us private compute in trusted hardware. It's practical, it's fast. The isolated enclave means that no one can access the data, even the host. That's actually the goal. It gives you proof of correct execution, right? Similar to how ZK gives you proof of execution. And it gives you relatively straightforward signature verification. But of course, there are somewhat significant downsides. It's vulnerable to potentially devastating, mic drop, side channel attacks. And you have to trust the central issuer, right? Which is generally Intel. So let's talk about Intel. Intel SGX, it's not like a separate chip or anything. It's a set of instruction codes that are available on existing CPUs. And in addition to those extra opcodes, it gives you, hardware-based encryption of memory. So an area of the RAM is actually encrypted and can only be accessed by, passing through the special opcodes, right? And it's that encrypted memory that really constitutes the enclave. So it's not like it's a separate chip. But the assumption is that the operating system itself is untrusted, and then there's a root of trust baked into the chip that essentially goes back to Intel that allows you to remote attest to executions that are happening on the enclave. So a signature can be produced out of the enclave that says, this is the binary that ran, and these are the inputs, and these are the results, essentially. And of course, that will just leverage the traditional TLS style, HTTPS style certificate chain like your browsers use, but ultimately rooted in Intel. There was an amazing talk yesterday by Sylvain, I think his name's Bellamore, on how we actually move past SGX and have secure by physics chips. And so I encourage you to watch that when it's available. Those talks will be available, right? Yeah. Soon. Okay. Soon TM. Okay, so what about, I said potentially devastating vulnerabilities. What do we do about that? So it turns out we can mitigate these side channel attacks by using blockchains. Blockchains are actually perfect for helping us address the issues in TEEs. And the way you do this is you stick a light client in the enclave. Everyone loves light clients. People are running around, Modular Summit with, light clients of the Celestia blockchain on arbitrary devices. Well, you can stick a light client in the TEE, and you require that all the execution that happens in the enclave has to go through a round trip with the blockchain. And the reason that's important is because this can constrain who runs the enclave, how often they run it, and what data that they run it on. And so the way these side channel attacks are typically exploited is that you run, remember there's encrypted memory, and what you're trying to do is get it to leak something, right? And so what happens is if you can run the binary over and over again and control the inputs that go in, then the attacker can kind of keep trying until they start to get something to leak and they get a little bit of information out, and after enough runs they can they can maybe leak a whole key or leak some data or whatever, right? Because the operating system is untrusted, but the operating system is actually responsible for allocating memory and stuff. We don't have to get into all the details, but so if you can lock it down, if you can prevent the host from being able to run the enclave arbitrarily however they want, which you can do with a light client, right? Then you can actually prevent them from from trying to exploit these side channels. So this can actually potentially help us lock down side channels that we're not even aware of yet. And then this is the kicker. This should hammer it home why we should use these things, is because you can actually use zero knowledge proofs still. You can still just produce a zero knowledge proof out of the enclave so that you don't depend on the enclave for integrity or correctness or validity at all, right? So all you depend on it for is privacy, which you don't have otherwise. And so if Intel completely rugs you, or there's some side channel attack, or none of this works, you just fall back to what you already had before, which was transparent blockchains, right? And so the TEE used with a proper zero knowledge proof gives you strictly better guarantees than what you would have had otherwise, right? So that's the core idea. So The TEs are always leaky. How do you solve it? You slap a light client on it. Now, when I first put this meme together, I was like, oh, what does this meme mean? Is this like actually a permanent solution to this problem, or is it like a temporary thing? So I went and looked this thing up, this flex tape stuff, and the guy is like pretty convinced this is permanent. So he takes a boat, like a literal boat, and he cuts it in half, and then he tapes it back together with flex tape, and just goes like cruising around on the lake to prove that this stuff works. So the TEs they're gonna keep leaking until we make the like secure by physics. They're always gonna be leaking, and so we can slap light clients on them and fix those babies. So summary. Ultimately, complete design will combine everything, FHE, MPC, ZKP, TEE. We love our three-letter acronyms. But even FHE plus MPC plus ZKP will benefit from using a TEE because it prevents collusion. The TEE can actually help add additional guarantees that there won't be collusion. In the meantime, it gives us practical private compute and rapid prototyping, which is great. Can reduce side channel attacks with blockchain design, protocol design, and we can reduce the dependence on the TEs for correctness by using zero-knowledge proofs, and we can do defense in depth with different kinds of TEs, different kinds of ZKPs, and so on. So another one of these bad crypto bitch memes. There was a summit the other day, ZKP's FHE, MPC, and that's what it looked like. And then there was the TE salon, and yeah, that's I think Tina's sitting in the middle there. So we're building a framework called Quartz for bringing TEs to CosmWasm. CosmWasm is the sort of native Cosmos smart contract environment. I'm not going to go through too much detail because I'm sort of running out of time. But it essentially does everything I just talked about: desired properties, replay protection, forward secrecy, censorship resistance, and integrity. All the usual stuff we'd expect. We put it all together: light client proofs, encryption. It's really wonderful. This is essentially what it looks like. You have encrypted intents, and you could just throw those into a DA layer. You have execution happening in the sidecar, and then you have settlement happening on chain, processing everything. There's, like I talked about, this light client thing, just a little bit more detail. All communication with the enclave happens through a light client-based round trip, right? And so if you do things like this, you can really lock down execution in the TEE, right? So you initialize via a handshake. You want to prove the blockchain to the light client, to the enclave, and then you want to prove the enclave to the blockchain, right? And as long as you're doing both of those things, you can have this handshake, and you can have all the computation in the enclave be gated by what's happening on the blockchain, so that the enclave's binary won't run unless the blockchain gives it permission. Very powerful. Now, why are we doing all this? Why am I up here talking about TEs? Well, we're building what we think is one of the most compelling applications of blockchains. It uses the multilateral atomic settlement properties of blockchains to build a very useful application for people. It's called Cycles, cycles.money. It's an open clearing protocol. It's designed to clear the most debt for the most people with the least amount of money, right? And most people think that the way to take on banking is by going after the assets. If only the power banking is on the assets, and if only we can build permissionless, counterparty-free assets, then we can we can beat the banks. But the banks are like laughing all the way to the central bank with that kind of thinking, because the real power banking comes from the liabilities. And the banks have been gathering in clearing clubs and clearing huge amounts of debts with almost no money at all for hundreds of years, and the rest of us are systematically excluded from that. Maybe you've used Splitwise. That's probably the only time you've ever had any experience with clearing, but that's just like, that only works if you're with a trusted group of friends in a small trusted environment, right? Whereas what we're building with Cycles is gonna bring that kind of experience of clearing to everyone, anywhere, at arbitrary strangers with arbitrary debts, clearing the most debt for the most people with the least amount of money, but doing it in a privacy-preserving way. And so in order to do this kind of thing with privacy, we need to operate on a global graph, right? And so we have to collect intents from a large number of users and then run a graph flow solving algorithm, and then produce zero-knowledge proofs of what we did. But we don't want the solver, we don't want the prover to have access to all that data, because then we'd have to trust some particular prover. So we do it in a TEE using the framework I just described, Quartz, and that solves it for us. So that's Cycles. Check it out. That's kind of it for me, unless you want me to wrap. But this is me. This is informal. We're building Cycles, and we're hiring. So we need a lot of smart, passionate people to help us build this. We're a very ambitious project to transform finance. We need business people too. We want to make this thing real. So reach out, talk to me, go to the website, and yeah, thanks so much. Oops, yeah.
All right, thank you very much, Ethan. So I guess we now know that it's more efficient to run searchers, solvers, and builders in TEs. I guess Ethan just told us why, and now you're going to tell us how.
What, do you just need like the permissions? Oh, you have the link, right? I can fix my slides. Oh, I just never set the permissions, I don't think. Yeah, I mean, it's got to get from Mountain View to Brussels. Sure, we can make a short URL. Oh no, all the animations won't work. Here, try the short URL. Oh my gosh. All right. Super. All right, so I'm going to talk more about TEs. I'm going to try to make a point, which is, so you've heard why TEs are really important, why we really need them. Just waiting for cryptography is not a long-term, let alone a short or medium-term solution. I want to build on that in a moment, but the overall message that I want to convey is that we have a lot of work as the Web3 and blockchain community to do in making the software stack that builds around TEs actually realize the potential that we can do. This is a really important opportunity because actually the TE world, which has applications beyond just blockchain, actually often needs blockchain for many different things. Ethan went over why blockchain plays a role in replay protection and even side channel mitigation in TEs. That's one good example. So that's what I want to talk a bit about. Normally, I try to give like a nice nuanced argument, but Ethan already covered that, so I'm going to let loose. I just want to convince you that TEs make everything better. TEs are basically a magic box that you can put any software whatsoever into, and it makes the software better and more interesting. If you take a smart contract VM and you put it through a TE, you get a smart contract system with programmable privacy. That's better. This means that any of the apps that run in smart contract VMs become better as well. So if you put in a humble Uniswap automated market maker, you get a dark pool out. If you put in a margin lending protocol, you get a private portfolios margin lending protocol where you have resistance against snipes trying to tip the price on just the collateral that you're sensitive to. You heard from Shay about what happens when you put a builder into a TEE. You get a trust minimized builder that gives you a guarantee it follows all of the simulation and ordering rules and bidding rules that you'd expect. If you haven't finished your L2 with fraud proofs yet, but you put it in through a TE, then you get proactive validation for, it finishes your L2 for you, and you even get proactive ZK validation without having to wait for optimism. If you already have a finished L2 with proactive ZK proofs, then you get a multi-factor 2FA prover. It can downgrade if either your snark circuit's broken or the TEs get broken, you have a backup. If you have the multi-party computation approach and you're already paying for the extra cryptography there, then by putting this through the TE, you get the collusion resistance, which is addressing the main, besides performance, the main remaining challenge of MPC. In general, if you put any Web 2 application in the TE, it comes out with Web 3. You'll see a bunch of examples of this, but the basic idea is that you get the whole TLS stack as part of what comes along in your in the trusted code base in your enclave. So you can make TLS requests to TLS servers, and the enclave is guaranteeing that it actually carried out the certificate validation and it's talking to the thing it's supposed to. You can serve websites over TLS from a TLS server in the enclave, and now you can even get the certificate transparency to work for you. You can say, well, this domain has only ever had one certificate issued for it, and that certificate came from a TEE, so the private key for that never left the TEE, and so you're always getting, trust minimized front end, for example. So let me talk just a little bit about what goes into the software stack around trusted hardware. So trusted hardware is a thing that's part of Intel, AMD, and NVIDIA chips, lots of others like that. The point is that it's something that's supported by hardware. It's part of the instruction set. So it's something that at the lowest level, you have to write x86 instructions to make use of the SGX specific, the extra instructions that are added to support SGX. Most people also use a higher level layer, so either SDKs, which maybe involve a little bit more work, or a libOS like Grameen, where you can really take existing process descriptions and those will run. Also, there's like confidential virtual machine layers, so you can run Docker containers or VM images. This is especially with AMD SEV or Intel TDX, or more of the virtual machine style. And on top of that, we often want to do coordinating decentralized systems with redundancy and matching of these. So the main appeal of these is that this is why you get to run legacy code. So in principle, there ends up being a lot of caveats, but I don't need to discuss those for now. In general, you can take legacy existing code that was not made with TEs in mind, but now you can run it in TEs and you get all of these privacy and integrity benefits as well. And that's really the appeal of this software layer. So the hardware providers are responsible for making the raw thing that makes this work, and that's at the hardware instruction level. They often provide some software interfaces as well, but you can also modify your own software. The way that the most important software packages today work that make up this framework of the software stack around TEs, these are made by open source projects. So there's like the Confidential Compute Consortium, that's a Linux Foundation managed thing. A bunch of the projects that we use and frameworks that we use come from there. There's the main reason why we need to be involved in this is because there is a fundamental mismatch in values between what we want as Web3 decentralization and the ordinary enterprise and cloud setting that's the main driver so far between TE software and hardware support. The main goal that you're supposed to get from TEs is that you can deploy an app to the cloud and you don't have to trust the cloud because the cloud's running the TE, so you don't have to worry about it. But that's a very Web 2.0 thinking because it's assuming that the app developer, the app admin, is the one who's being protected from the cloud, and that's it. What we care about is that your users don't have to trust either you, the app developer, or the cloud. Right? So we want to pass these guarantees down onto users. That's really the main point between what I want to say is needed in this software. So it's really likely that, and for that and for all of the other reasons like Ethan mentioned, there's a lot of reasons why it's actually better when using trusted hardware to use trusted hardware in conjunction with a blockchain. It's actually a good idea to build, even if blockchain's not your goal, it might be a useful solution, especially for things like key management and coordinating many nodes and assigning tasks to nodes and handling the failovers in a way that doesn't create race conditions. Using a blockchain is great for resolving those. So I think there's a real need for TE frameworks to incorporate blockchain features, and that's the sort of thing that we should be building. I will come back to this shape in a moment. All right, and I covered that too. I only want to talk about one slightly in-depth, still at a pretty high level, but technical topic. And this is about something that I think is pretty important that we should extend to. It's in the vein of sovereignty, so it can fit the vibe of this summit. And this is about what rights are extended to users, especially during software upgrades. So the first way that you use a TE is very rigid, and it's the main premise is you can say, I'm going to send my sensitive data encrypted to this enclave. I actually specify the hash of the program code that I'm expecting to allow to run. So it's like the hash of the program binary. So I'm saying I can only let this program binary run on my sensitive data. That's where I get these guarantees from. But this is, of course, really rigid. What happens if the program that I sent my data to turns out to have a bug? I want the devs to be able to patch and upgrade fixes to this. The next simplest thing that you end up with is using code signing. So you can say, well, I'm going to trust it, send my sensitive data encrypted so that any enclave that's signed by the code signer can access it. This is, I think, a really bad setting that we should move away from, because this basically means whoever has the code signing updates could sign, for example, an enclave that just outputs in plain text everything sensitive that was sent to it. So this is a bad setting that we don't want to be in. What the next best thing that is in the direction that we want to get to is that you can say, well, I will use this blockchain environment and I will have something like a DAO governance. I'll encrypt my data so that only this smart contract can define the policy that the enclaves will run. The magic that makes this work is, like Ethan said, you want to run light clients inside your enclave. Running a light client inside a trusted hardware enclave, that's a huge source of power, and it's good for the enclave, it's good for what private software you're going to do with it. So now the app developers still can influence the program and it can change, but they have to go through the governance rules. So this at least means that they have to do it in some kind of transparent or visible way. This is roughly the structure that Oasis and Fala have, and some other systems have something similar to this. But what I want to draw attention to, and that's in the vein of user sovereignty, but this is still to improve on, so we should work on these kind of things and find others like this. What if the user is concerned that the devs, even the majority of devs, even the governance of the contract, want to rug the privacy of this user, right? What if they're about to change the enclave to something that is not what the user is okay with in terms of privacy? Does the user have any rights in that case? Even the best practice with ordinary non-private smart contract updates is a notice period. Like the update shouldn't just take effect right away. Maybe it goes through an update period. You could implement the same kind of rules and then actually use the enclave to guarantee users that these rights are enforced, that any changes go through a minimum notice period. And ideally, even that if users really don't like that policy, they should be able to opt out and revoke their private data altogether. Maybe they don't get to keep using the system because the system has evolved and governance has changed it. But maybe users get the ability to opt out before having all of their sensitive data disclosed. Okay, so that's the example of user sovereignty. It's something that I think we should be trying to pass down to users, and that's very much along the lines of the difference in values between our Web3 world, what we expect from TEs, what the enterprise world currently does. So we should be influencing this. The best way that we influence things is by just ripping parts out of the stack and redoing it ourselves. So I think it's absolutely the right idea that we should be adding our own blockchain-based key management and orchestration and administration of trusted hardware networks. There's also good reasons why we may want different variations of security properties that may require us to go and dig into stuff at the lower level. So for example, side channels are not something that you can run your legacy code automatically in something like Grameen and it runs in the TE, but just because it ran in the TE doesn't mean you're getting all of the potential of the TE. Right? It's not automatically secured just because it's running in the TE. There's also a lot of steps you have to take to mitigate side channels, and if you just port some code without thinking about it, you don't necessarily get these mitigations. There's lots of caveats to the trust models and such, but we often will say, well, no, we're very suspicious of the cloud. We're very suspicious of any of the physical operators. We want the strongest possible guarantees. That may require us to basically reach into some of the existing frameworks at a somewhat lower level, still software, and change it ourselves. If we have to, and this is where Sylvain's talk is relevant, and there's this, I think, emerging movement that I'm pretty excited about to do. We'll talk more about it, I think, today on open TEs. I think we should be willing to threaten and deliver, and it's not out of the ordinary. We've done blockchain native hardware of other kinds before, VDFs, ZK accelerations. We should be willing to make our own blockchain native hardware if we have to, and that way we can actually add stronger defenses. We can make open source versions of these so you don't have to trust the opaque manufacturer. We can build in things that make it easier to audit so you don't just have to take the manufacturer's word for it. That's the status quo. That's not great. We should strive to do better. That's in our nature, right? We should be willing to go dig in any of these. So my goal is to basically embolden you to, learn about TEs, accept the idea that they're necessary and very useful, learn a little bit about the software frameworks that are there so you can kind of see how that works and think about where you would want to dig in to try to improve things and shape this cool technology so it fits our values and not only those of the Web2 world. That's all. Thank you.
Thank you very much, Andrew. Great work. We're going to keep cruising through. We got DMARS coming up now. And microphone's yours.
Amazing. Drop issue. Okay, I'm gonna get started. What's up? I'm D Mars. I'm gonna be showcasing not only my ability to make puns, but also how you can control your information flow using TEs. I'm gonna give you a little bit of a story for why applications need to control their information flow. I'll briefly mention how you can use TEs, but the rest will be left to your imagination. Yeah, so first I'll sort of motivate why MEV should be part of the modular stack. I'll then go through a story of 2 OFAs, which stands for order flow auctions. And then lastly, I'll talk about what do. So MEV in the modular stack. So why did we invent the modular stack? We as in the community and Celestia, but you know, it doesn't align with the ethos of the space to have everything be monolithic and controlled by one person. That one's pretty obvious. Cars aren't monolithic. You know, high performance machinery does not all get controlled by one person and have interfaces that aren't able to be swapped in or swapped out by other people's products. And then lastly, division of labor. If we specialize between different teams, then you know, someone working on DA or someone working on consensus or settlement or execution are all able to benefit from each other. So how's it going? I would say largely it's going great. This is a screenshot from Conduit's Rollup as a Service UI. There's a bunch of other Rollup as a Service providers as well. And it's pretty awesome. You have like 4 options already, or 3. You can pick between 2 different stacks. You can choose multiple different settlement layers and execution layers, as well as data availability layers. If you were to be building a blockchain about 4 or 5 years ago, what you probably would have done is like went to Go Ethereum and forked it, or you would have used the Cosmos SDK, which is also a bit more modular than forking Go Ethereum. So although it's going great, pressure is definitely growing in certain parts of the stack. So on March 14th, this is an example of a high transaction revert rate on Base. On this date, I don't know what it was, some type of NFT drop or something, but over 20% of the transactions landed on chain were reverting. We dug into this a little bit and we discovered that a large portion of these transactions were on-chain searching. On-chain searching can basically be described as, well, we can compare it to L1. So on L1, when you're trying to execute an arbitrage, you send a transaction to a block builder. That transaction basically either succeeds or it reverts. All modern block builders will just remove your reverting transaction if it reverts. This allows you to basically compute a bunch of prices off chain, do some execution, and then you know, let the block builder take care of it. We don't have this though on L2s, or honestly most of the modular stack. So what's happening is searchers are basically encoding their arbitrage functionality into their smart contract, and they're just pressing that button like a shit ton. They just keep hitting it all day. You can think, so what they do in the contract is essentially they will check between multiple different pools. They will see if there's an arbitrage. If there's not, they revert. That revert then lands on chain. These chains are quite scalable at this point though, so we're seeing about 2 cents for a revert on a bunch of rollups, Base, OP, and many others. Which if you think about it, just to make $1 profit, you can essentially try 50 different times to press this button. What happens then if transaction fees go even lower? Can you try 1,000,000 times just to make $1? So yeah, this leads us to the conclusion that if you don't have an efficient auction off-chain, then your auction moves on-chain. And this basically is the motivation for why we think you know, this meme should have an MEV layer inside of it. Cool. So before you want to just you know, slap another layer on this diagram and say like, oh, we'll just take whatever OFA the market decides, whatever mempool, whatever block builder. I'd like to take you through a little story of why this like ad hoc composition doesn't work as well as you'd think. Yeah, and so disclaimer, I am not commenting on the security model of these components or their implementation. My lens is purely compositional. Okay, so let's start with the user, Alice. She wants to trade on some type of chain. We'll call it Explode. She's looking to trade long tail assets, as the kids call them. So yeah, she just sends a transaction and profits, right? Well, no, there's like a bunch more complexity, especially for chains with a lot of on-chain volume. But I'm not here to mansplain you the transaction supply chain all over again. But I'll walk you through some options. So first, you might go through like a Telegram bot. Somehow that ends up at a block builder. You don't really know. You just like type some words in a keyboard and suddenly your trade like maybe or maybe isn't on chain, which, yeah, the rules there aren't very transparent. The other option is like an in-wallet swap. Maybe like where you hold your private key gives you a little pop-up that's like, hey, we trade better for you. But you, again, don't really know how that gets to the block builder, nor do many other people know how that flow gets routed. The other really popular option, order flow auctions. There's actually like multiple in production. What essentially happens here is the user sends a transaction to one of these OFAs. They're typically behind an RPC in your wallet. The OFA will then send your information about your transaction to searchers. Searchers will then construct a back run, send it back. The OFA will say, oh, okay, you gave all the value back to the user, or maybe 90%. They'll then pass it on to the block builder. The rules there are a little bit more transparent because there's like actual open source code and public rules, but they're mostly socially enforced at this moment. So yeah, one lesson here is that like increased complexity of modular components in this MEV layer creates the need for aggregation. So because of all this complexity, there's been a bunch of people that have tried to make this simpler. So one example is an OFA multiplexer that exists. It makes a ton of sense. Like if you want your user to get the best refund, you might send it to like multiple venues. But like, let's dive into this. So, you know, there's a hypothetical one called MEV reducer. It has this rule where I send my transaction through and it reveals this information to the searcher, but you don't want the searcher to front run you, right? If they have the entire transaction, they could just grab it, front run it, send it to a builder. Now the user's actually worse off. So what they do is they send fake transactions so that the searcher doesn't actually like know which one is real. Searchers try to backrun all of these. Only the ones that are real end up on chain. There's another one, MEV distributor, another hypothetical one. It only reveals partial transaction information. So potentially Alice is like swapping some token pair and the size, but it doesn't tell you which direction. So now the searcher has to send a backrun for the one direction and the other direction. So that's really great, but this multiplexer will then send it to both of these. And if you're a smart searcher, what you can do is you can just watch both of them. You see a fake transaction in the first case, you then query the API on MEV distributor to see if it's there. Oh, it's not there, that's the fake one. You grab the full one, you then search it here, boom, you see that that's the real one because it's also in the other OFA. You can also do this in the reverse way too, but the point here is that both of the security models of these end up weakened because of the fact that we're trying to compose these two mechanisms off-chain. So yeah. Composing order flow auctions resolves to the worst security for both of these order flow auctions. Here's like my Tumblr-esque take of this. Yeah, do not stack mechanisms into the modular stack, but rage against ad hoc composition. Okay, so what do we do about this? So option one, we could say, oh, this is like, you know, the status quo in permissionless auctions, and we should accept it. I think that's like actually a valid take that, you know, if the base layer wants to be maximally decentralized, we totally should advocate for like max competition on these things. But I don't think we should stop there, especially if we're trying to bring in, you know, the next 100 trillion users. That includes bots. So option 2, build integrated applications. This is a meme from Neutron. The idea is you can essentially, if you have a rollup, you can own the entire stack. You know like which RPC the user is going to go to. You then make your sequencer such that it only accepts transactions from that RPC. And then you have like very tight control of where the information enters and exits the system. You then can do you can basically pick and choose any one of your OFAs that you desire, and that totally feels modular. So those are basically the two main options I think of, but there's probably some type of spectrum that exists here between permissionless auctions and integrated applications. And I think one of the like key observations from this tale of two OFAs that I just shared was that information leakage is the issue. So my contention is something in the middle is probably able to control information in like a permissioned or semi-permissionless setting. So yeah, what if we could control the flow of information across the stack? Then maybe it might look something like this. We just have more boxes, like cool. And I didn't draw a box around the settlement layer because I'm still a bit confused what a settlement layer is. So what technology do we have to put inside? What technology can we use to wrap these boxes up with another box? The first thing you might grab in your toolkit is ZK. If you have been around for any of the presentations today, you might see how that's an issue though. This doesn't work well for multi-party compute or private global state, which is exactly what we're doing. There's multiple different parties involved. Maybe if this is, yeah, I mean, it's hard to even imagine like a DEX is without multiple parties. The next thing you might reach for is MPC, and I think that's like a totally valid option. The problem is it's not speed-wise, it's not really here yet today. We've actually done a bunch of research where we did like an MPC backrunning bot at our Flashbots research. And I think it was like 20 seconds or something to compute a backrun, which is like quite slow. And definitely not suited for L2s at the moment. And then as well, you have this like K-event trust assumption, which was talked about earlier. And then, misformatting. So shill alert. I think someone said we haven't been saying the word shill enough, so I'm trying to help identify where I'm shilling. At Flashbots, we think TEs are the answer, obviously. So we think that if you could put these different components in a TE, then you're actually able to control the information flow between them. And this gives us a bunch of the properties we want. It's fast, it's private, it's cheap. Some cool ideas you could think of doing with this new technology. You could do encrypted mempools and order flow auctions, and then you can enforce the boundaries between the two. So basically, your encrypted mempool could ensure that it only sends information to an order flow auction that it trusts or has like permission to be able to use it. And I think that's super cool because as we saw with that other order flow auction scenario with the tale of the two OFAs, there's no way for us to control the information between those two. And not that we need to in all cases, but it's probably what you need to do if you want best execution for the user. Execution layer privacy is another example, like block builders and other people who are doing the actual execution are able to work on top of encrypted data. Something like shielded DA, I haven't really thought about that much, but I think that would be like a really cool idea if someone could think of that. And then as well, TE multi-provers. Oh, what's that? Did someone hear something? New applications also could emerge if they exist on this layer. That's interesting. I wonder what they are. But cool, that's the end of my presentation. Thanks.
You got 1 minute if you want to take a question.
Any questions? Is anyone excited about TEs? Nice. Cool. Does anyone want to hear about new applications on TEs? I think I know a guy somewhere. Oh, there he is.
Okay. Yeah, let's start. Oh, I see. Okay. Should work.
No, just now.
Oh, okay, amazing. Finally, okay. Okay, yeah. So as Dimas introduced, the question that we are wondering is what applications are uniquely unlocked or just unlocked by the TE stack. From the past two talks, I believe everybody has like a general understanding of what the TE stack is, and in general, what are some unique properties. But before we begin diving into the applications, I want to kind of like do a recap of the properties. First of all, the answer. What unique properties does TE have? I argue the first one is like this type of, I took the word from game theory. It's like called conditional recall, which essentially means that you are able to commit or credibly signal that you're forgetting some information after inspection, right? So I think in Andrew's talk, he introduced the TE stack as something that you can allow two bots that negotiate to enter into the same room and do all of the negotiation, inspect the other person's item, and then kind of forget after you leave the room, right? So that is kind of captured by this meme here, that you can unsee something after you see, right? Because that allows you to strategically or intentionally forget information. Okay, and the second property is this, I think, the unique differentiator between TE and ZK is that TEs allow computation over shared private state. And if you think about information age, right, like people talk about intents, what intents are is essentially like it's moving the boundary of property and the value from the action level to the intent level. So like, for example, this has been happening a lot, like in Google's case, right? In Google, the Google captures value at like the intent level. It mines the user's data and uses that data to kind of do better recommendation models. And that data is purely informational. It's not in action level thing, right? An action level is more like, oh, I have this skill, and then let's say like I fix plums, and then like the way for me to exchange value is to actually do the action. So then as we move more and more into this, value at information era, then high-speed computation over shared private state is really required for scaling, trading, and exchange whenever value exchange happens. Okay, and the third one is kind of like a combination of the previous two properties. We can name them something like encumbrance, right? So what encumbrance means is essentially you can put some secret into the TE and then allows an agent to act on the secret, and that agent can credibly signal to anybody else outside the TE that it haven't done any equivocation, right? It allows the agent to commit to non-equivocated actions. So in other words, in the left curve word, this just means like you can commit to no rugging. Okay, so using those three properties, what is like the application we enabled? High level, it's like programmable authorization for Web2 accounts. Essentially, they allow you to make like one-time programs for your account, right? So how this concretely can happen is that you let the user log into some Web2 account, and then inside the TE you change the password, or you generate a new secret that controls the user's account, that allows the user kind of to do delegated actions to the agent inside the TE. And due to the benefit of computation over shared private state and encumbrance, this also means that the user is able to program more authorizations. So essentially, at a high level, this just means that we are able to bring Web3 composability and programmability to Web2. Okay, of course, and this idea is not new. I'm like kind of, we've been exploring this area for quite a long time. So this paper, I think, is from 2018 called Delegate. So the prime example you're seeing here is like Netflix account password sharing using TEs. And of course, I think in DevCon, dark DAOs and designing smart contract with free will was like a follow-up work on this as is complete knowledge. And then finally, with Tom Cryer, I think he's seeing, 2016 is really old work. So what he does is essentially it allows you to do a TLS connection from inside the TE to prove some Web2 data was credibly fetched, so therefore allowing you to move valuable state from Web 2 to Web 3. So this may also remind some of you guys about the work on TLS notary and multi-party computation-based TLS. I want to stress that the difference between that and the TE approach is that that approach doesn't allow, doesn't allow or haven't really been any exploration in that area to explore credible writes. Like, so usually over there, you're using TLS notary to achieve this like credible read. You are like moving an oracle on chain. However, here, we are saying like we don't want to be mere mortals. We want to control our own fate, right? It's not like you're letting a god tell you what to do through an oracle. You want to, you want to say, here's something that I want to do, and then have that thing be realized. So then that's kind of like the opposite of an oracle, right? You're like letting an on-chain data or an on-chain agent to credibly control a Web 2 account or a Web 2 action. So what's that? That's kind of like a prophecy, right? If you're like a prophet, when you say something, then that thing becomes true. Okay, and all of the previous work, I guess, can be kind of captured by this work in 2008 called One-Time Programs. It's like a classical cryptography paper, and if you actually look at the paper, the prime example used in this is actually, I think, email delegation, right? So the scenario is like you go on vacation and then you want your agent or your friend to take over your account, but then obviously you don't want your friend to look at your other emails or like reply to emails that don't have the right title. So then you can develop a one-time program secured by cryptography to say something like, oh, the assistant Bob can only have the power to decrypt and sign emails dated September 2008. And upon realizing this, I tried to brainstorm some use cases with cloud, and it actually refused to talk to me. So what that means over here is that TE applications are so powerful that it's against the AI safety policy to even discuss it. So everyone here should realize that what powerful technology we're building, and the giants like Anthropic and OpenAI are actually afraid, such that they forbid the knowledge from spreading. Right? They're trying to have you unsee it. Okay, and then next I will demonstrate the power through like two very quick demos. So first one, we're at Modular Summit, must pay tribute to the Celestia people. So Mustafa previously, I think, tweeted something like, wanted a platform where I can anonymously submit banger shitpost ideas to unknown city accounts that I don't want to tweet myself. I'm going to demonstrate quickly using TEs how you can achieve this. Okay, so over here I have my Twitter account. And then here's an app running fully inside TEs with attestation. I can share the hash in my link to my talk. So then I can kind of create a new NFT. So what just happened is that the front end redirected to a server running inside TE that does the callback to Twitter URL and then stores the OAuth token in OAuth 2.0, which is used by Twitter credibly inside inside the enclave page cache, which is in encrypted memory. So then it allows you to kind of mint an NFT that when redeemed allows somebody to tweet from your account. So over here, I'm fully testing on my own account. And of course, when somebody tweets from your account, you don't want them to tweet some random stuff, right? So then you can additionally define something called like a post safeguard here. So I can say something like, I guess, only TE posts. and then I can mint the transaction. So currently it's like on base Apolia. All of the costs, even to like the on-chain costs to base, are conducted inside the TE, by the way. Okay, so I think the NFT number 59. So this is like the NFT. So then I can kind of copy the invite link, and suppose now I'm opening a new browser to simulate what would happen if I send this to my other non-crypto friend. Okay, maybe the internet needs some time to load. So then let's just directly redeem under this account. Okay, so only TE posts. Let's see something like. Okay, let's say TE app accelerationism. Now let's redeem the NFT, and then it should like tweet from my account. Okay, yay! So this kind of works. So over there, what is essentially happened is that it did the whole Web 2 to Web 3 flow inside the TE by encumbering or storing my Twitter account inside the TE. Okay, and one real quick final kind of demo is that so previously there was this game called Mischief Plays Demo. So the game rule is really simple. It's like players can pay $10 to join before the start of the game, and the prize pool currently is like 112K, and then every hour people can vote to get other players out. So then naturally you can create some kind of DAO to collude to win this game, right? For example, you have a DAO that everybody joins and the members commit to not vote for each other. However, since this is a Web 2 game, the DAO's implementation is a bit hard. By the way, you can visit proof.codes to see it. So how we implement the DAO is essentially we simulate a browser and hosted an email server inside the TE, and then you encumber or like delegate or take control over the user's account by an email link to change the password, so the user cannot log in on their own and deviate from the DAO strategy, which is vote for others. Then inside the TE, you have an agent that takes actions on the user's behalf, which is like vote every hour for members outside the DAO. And all of those actions are done by in the simulated browser. So here are some architecture graphs. So all sounds great, but what really interesting just happened before this talk is that yesterday I did the same demo, and I think Andrew got very excited about this, such that he tweeted about this. And what happened is that, how's it going? Ethereum is a dark forest, but Twitter is also a dark forest. This is so crazy. Okay, we got literally Twitter or Mischief MEV'd. So before this talk, I got this email from Andrew saying hey, help, they are coming for me. Make the TDX, which is a type of TE, do something. So, okay, you guys have to realize what happened here is that Andrew tweeted about our strategy about using TEs to collude. And one of our coworkers happens to also play this game, but they are not inside the TE. And they, I think it's some Discord server where people are playing those non-TE based, just plain old human coordination servers found out, and they voted Andrew out. So he just dark forested the hell out of himself by broadcasting his intent or our intent to collude in this game. And what's sad is, he tagged me and my ID in that post. And then what happened? This is the hour after Andrew got voted out. You can see here I received 120 votes to get eliminated from the game. So over there, what we can learn is that information does carry value, and broadcasting your intent into the public mempool really gets you screwed over. But on the good side, we're the sacrificial lambs to demonstrate the beauty of decentralized private coordination, right? We died, but the tech stops there. Because, okay, so the beautiful part of this is that people don't know what other members are in the DAO, because the DAO is running inside the TE, so there's no way for them to vote anybody else from the DAO. By the way, before coming to this talk, I've received the news that some Discord servers saw our, bad fate and wanted to integrate. So that really shows, TE product market fit starts from trolling people on games. Yeah. So if you want the space to be more interesting, do acceleration of apps via the TE stack. And okay, so what's next? Aside from apps, is we still have to remove infra choke points in the system, like security, liveness, and open hardware, which leads to the next panel. Thank you.
All right, thank you, everybody. We will be prepping the stage for last two panels. No, it's one more. There's one.
No, Tarun's hosting this. Do I see Tarun? Can someone text Tarun? I guess we don't have to wait for Tarun.
Okay.
Can be a rotating, hot seat. Just so that we know that this is probably the most impromptu panel of the day, of all the impromptu panels.
So far.
Ooh. You have some information I do not know. Perfect. And I think part of this is the beauty of why we're discussing this, because we just met yesterday, and now he's sitting here because we realize he can probably save us months, if not years, of just making mistakes. And so I think Andrew will share a little bit about the Open TEE initiative. At first, it's just us live streaming, open sourcing TEE work, but then it grew larger and larger. 2, 3, 4, 5 initiatives. There's manifestos written, and it just kind of all merged together. So that's why we're having this panel as the second last. There we go. There's our second host.
Come host us.
Oh. Well, I got thrown on this very last minute, so I'm. This will be funny. Yeah. There's a third one coming. All right. Maybe just start and then we can.
Okay. You're the host. Do you want to start by asking us questions?
Yes. Well, I didn't realize I became the host. I thought you were the main host. But all right. So everyone here is interested in hardware. I think one important thing about hardware and cryptography is there have been many known amazing attacks over the lifetime of custom hardware for cryptography. So why don't we start by you introducing your favorite attack ever against a hardware cryptographic system. Could be an HSM, could be a TE, could be people listening to your memory via obscure ways.
I'm just going to say my favorite one is APIC leak, and this is a bug that's not even a hardware bug. It's just a software bug, and it's not even an especially devious bug. This was a bug affecting Intel SGX. This was a couple of years ago, and it's just a software bug. It's like you load some data, you're supposed to erase it afterward, and it didn't. I'm saying code, but this is like microcode in Intel SGX, and so it just left unerased code, data when switching from the secure process out to the untrusted attacker-controlled OS processes. So it's actually just one of a whole bunch of security vulnerabilities that have affected SGX, and then you find out about it after they've gone through the long disclosure process, and then patches to your BIOS are there. This was the only one that I played around with and paid attention to, but also realized that it was just one in a sequence of other kind of related ones, but that's the one I know best.
I am a little less schooled in the list of security vulnerabilities. I guess the one I know the best is Spectre and Meltdown. But I think those illustrate a really interesting point, which is, these server class processors like Intel Xeon CPUs are really designed for maximal performance, right? Like, so they have things like branch prediction, they have things like speculative execution, they have things like even basic stuff like out-of-order processing. And really all of this serves to increase performance at the expense of making the attack surface exponentially larger. And, I think it is really telling and a great parable for crypto to come together and create really a crypto native processor that has far less attack surface and may not be as performant, but hey, like you could use this in settings where ZK and FHE may be currently or in the end still impractical. And so this is like something that I'm really interested in.
Yeah, this is something I've thought a lot about because I always love reading all those proof of concept papers that are like, hey, we took 500 microphones around this particular device and we just listened to what it was, we just did some simple Fourier analysis and then, we figured out the memory allocator whenever it's actually signing makes this particular tone. And then that always leads to weird, crazy HSM stuff like the HSM machine randomizes some of the fans and noises that exist and stuff like that to try to counter people trying to spy on you by putting microphones near your hardware. So now let's maybe talk a little bit about kind of the two domains you both are working in. So, Andrew, you're a consumer of a lot of hardware that people are making, mainly Intel, maybe NVIDIA. On the other hand, you're working on building ASICs, building custom hardware. You've done that in a previous life as well. How do you think about the end user from the perspective of you, Andrew, you're the end user of this hardware? I mean, theoretically, you're really the end user. No offense to the final user. They're just pressing play or submitting something on MetaMask. Versus, you as you're designing hardware, thinking about the users, the interface, the trade-offs you make between, hey, we can have a really efficient chip, but the programming model's too hard, and then people kind of get really annoyed and stop using your stuff. How do you kind of think about these two directions? Like, how much do you care about knowing the low-level guts, and how much do you care about knowing the actual end user?
Yeah, I mean, I definitely care. I'm only been able to have as much fun with trusted hardware because of pretty much the flexibility and you can run legacy code that wasn't meant to run on TEs in particular, but you can make it work with a little bit of effort. You can make it work, port it basically to make it work in SGX. But I realized that is also why it's so complicated. SGX has to run all of the x86 instructions, so full flexibility and functionality of the existing chip. No extra overhead is tolerated, has to basically be about as fast as running without SGX at all, or people wouldn't use it. So all of the goodies that make it run so fast, like all the pipelining and superscalar and speculative execution stuff, all of that's present. That's why they're able to present, you can use this, and there's so little overhead. So it's great from the perspective of ease of porting it and making it work. But it is not, clearly there's so little room for margin to add security features there that it's a lot of complexity. And so I wonder if maybe that's still a good way to get an introduction to it. But I could imagine that really the most secure solutions would be something that's a little bit lower on the functionality side and higher on the security side.
Yeah, absolutely. And to navigate any trade-off, you have to know the other side of the equation. And so we care a lot about knowing our end users. And I think it's kind of a mistake that hardware companies often make that, many hardware companies don't care about the end user, right? So they won't know exactly what apps are running on their hardware. They'll optimize maybe a performance metric like SpecInt. So if you start a new CPU company, typically there's some funny little Fibonacci type integer benchmark that you're like, okay, I got this many DMIPS per megahertz and the other guy got this many DMIPS per megahertz, and so I'm better. And really this is what we set out to do at Fabric, which is build a really mission-oriented hardware company. So we absolutely care about the end user, not just the end user, but the end developer. Their experience, their ability to use this hardware to actually accomplish their goals, and the community, right? Like we care about the community values And those are built into kind of the trust assumptions, the security assumptions that we want to be able to build into our hardware. So yeah, I think it's really important.
And I think there's always kind of this fear, I think, in the average developer's mind who is not using cryptographic hardware, cryptographically secure hardware, where, there's always many ways to shoot myself in the foot. There's lots of ways I can leave keys in places they shouldn't have been. There's lots of ways I could, accidentally leave, do the simple thing of like not caring about the, to Andrew's point yesterday, taking private state and accidentally leaving it somewhere public and basically revealing things without much sort of kind of care. So because you have all these extra considerations when writing privacy-preserving programs, there's a lot that goes on the end user's mind. What are some of the biggest mistakes you've seen people make, both at the hardware level, where it's like, hey, someone optimized some pipeline, but in the process it leaves a copy somewhere, so like now anyone who could read that gate couldn't figure out a lot of things, versus in the software side, what bugs are people just like kind of leaving a lot of state around in a way that causes issues. Because I think understanding these ways of shooting yourself in the foot is actually really important. Also figuring out if it's like preventable. So obviously all these mistakes are preventable if I knew exactly the cause at the end. But which ones stick out to you? Which ones are the ones that you think are the worst types of mistakes that developers make?
There's a bunch I could go into. The first one that comes to mind is just ignoring side channels and not either noticing them or thinking that they don't affect you, or not taking the right mitigation to avoid them. The most stark examples of these are what I called spicy printfs, which was when trusted hardware-based smart contracts would access an encrypted key value store, but the key value store is off the chip. It's outside the enclave. You're at least encrypting the keys and encrypting the values, so those are just ciphertexts. Are you familiar with penguin mode encryption? You know what I mean by that? Like an encrypted key value store has to work by, you store the value, even if it's with an encrypted key, to get the value back. When you want to read it next time, you have to use the same key that you use to read back that value. So you can tell when the same value is being requested a bunch of times versus all different random values being requested. And so I think this comes from just not keeping in mind like the interface between off the enclave and within the enclave. That's an example of something you just have to be aware of when you're considering what your program is doing when it's running in a trusted hardware enclave. And the thing that's most been on my mind recently is about to what degree even memory accesses can leave some kind of trace if the untrusted operating system out of the enclave in SGX can tell, or can set up page faults such that it can tell when you access a piece of memory. The way that I've started thinking about it is when your enclave process runs, it's not fully isolated, it's streaming a redacted debug log. That's my mental model for it. That's how I imagine all of the information that could be extracted by watching side channels. So you kind of have to understand what that trace would look like and determine whether or not it's bad for your application and you can mitigate it. So that's the first one that comes to mind.
Yeah, absolutely. I think in the world of hardware, obviously it's easy by default to make a mistake and very costly at the same time. The flip side of that is you have a good kind of group of hardware people, they're really used to this, and they're almost just as paranoid as cryptographers, but in another way, in another direction. And so these are kind of the two flip sides. Like there's a lot of formal verification in the world of hardware. There are logical equivalence checks. There are layout versus schematic checks, which kind of show you like, okay, this gate that you wired up to this gate exactly matches the schematic that is the net list of gates that are supposed to be connected. So there are a lot of automated tools. That being said, these tools are also a way to screw up, right? So we've seen a lot of cases in many projects where you need to know how to work with the tool to use the most reliable parts of the tool. So for example, in electronic design automation, the tool will quite frequently have a bug and insert a gate where it was not supposed to be or something like that. And then, knowing which parts of the tools are even mature is like a surprising thing that hardware engineers have to do. So there's really a lot of things that hardware people keep in our minds. But I also think that this means that, in designing TEs, if we just actually have security as a mission and trustworthiness as a mission, then in the short term, we can create some pretty good trade-off points on the trade-off curve between performance and security. It's just that most companies don't have the luxury of having this as a goal. And uniquely, if you're building for the crypto world, you do have this, right? So that's the really awesome thing about crypto is like it's a way, not just to secure crypto, but a way to get more security, more privacy out there in the world by default.
Suppose you built a chip, give it to me, and you wanted to convince me that there was no backdoor in it. How would you go about doing that?
That's a great question. I think that I would have to spend a few hours thinking of a solution.
No, you have 30 seconds.
I think there are ways that you can target the most obvious vectors for backdoors. But ultimately, it will come down to things like people looking over other people's shoulders as they use the tools. It'll come down to things like open source RTL. It'll come down to kind of those semi-social kind of schemes where more transparency is ultimately a really good way to do that. And then ultimately, one thing that I'm a big supporter of in the long term is destructive analysis of chips. Something that no traditional hardware company will do, but a crypto-native hardware company must consider this as one of the things if they're building TEs.
How big of a tool do you need to do destructive analysis? Could it fit on a stage and it's something that could be done at a conference, or it needs an actual, I don't know, you have to take the conference to the destructive analysis zone?
You may have to take the conference to the destructive analysis zone. The tool might fit on stage, but it might require large amounts of nitrogen gas and all sorts of weird things that you wouldn't have on a stage. But I think this is one of the, let's say, utopian visions that we have, that one day there might be some sort of ceremony around this, and then everyone might have, I don't know, ETHCC or SBC there, and then everyone can see it happen. I think that's the level of public scrutiny that you would really need to have one of these things be trustworthy.
Yeah, that's a funny idea for a religious ceremony. Every time you do a tape out, it's we tape out and then we blow up the chip and then we pray to it or something. Let's talk a little bit about supply chain attacks. I would say that a hardware supply chain attack when I worked in ASIC development is why I got into crypto a long time ago. So I have seen some very bizarro supply chain attacks. There's two types of supply chain attacks, of course. There's the hardware ones where, if you're a fabless company, you don't own your own fab, you rely on a bunch of suppliers and vendors along the way. You rely on them executing your verification correctly. If you're outsourcing that, you rely on a lot of stuff. Talk to us about supply chain attacks in the hardware world. And then, of course, in the software world, there's a lot of supply chain attacks that can also show up. So it'd be good to kind of compare and contrast and hear the difference between pushing bits and pushing atoms in terms of supply chain attacks.
I think ultimately there isn't too much of a difference in that in both cases you're swapping out components and you're basically introducing new backdoors or new side channels or new kind of bits of leakage in the hardware. I think that maybe hardware supply chain attacks are more easy to detect in certain cases and difficult to detect in other cases. For example, there are imaging tools that are super high resolution in the hardware world. So okay, you can just take a look at the parts and do maybe a random sampling of parts, and then you can do these things. Whereas in the software world, I think the use of fuzzers is less of a thing than the use in hardware of those kinds of tools already. So I think the introduction of things like computational imaging in the hardware world, a good friend of mine runs one of those kinds of companies where they have this big machine that inspects things for defects. The primitives for this kind of analysis are already widely available and already kind of developed. So that's one nice thing about hardware, I guess. The other side is geopolitics, of course. So you have to watch out for that kind of stuff. But it's just taking these into account and being careful about things.
It's a tough question because, I mean, my first reaction is, well, software supply chain security, that is an issue, but every software supply chain issue is just, it was avoidable. Like someone should have been checking the software updates, but it was, unmaintained, or the maintainer lost their things, and then people upstream that could have checked the software don't check the software. I mean, but maybe that is still, naive because, okay, these are very complicated
What about the
systems.
XZ? When I think about supply chain attacks of recent, I think about the XZ attack, right? It's like in very malicious bytecode injection, only discovered because someone accidentally cared about their booting latency on
And that was like deliberately obfuscated.
Yeah,
right?
yeah,
So
yeah.
that'd be very hard. I mean, so it's
that's the hardware ones. I feel like are adversarial though. They're also like more and as much as the XZ.
hardware is software and hardware. It's like strictly harder, and yeah.
When you think about designing, especially when I think about something like MEV, where all the end users are also adversarial. So clearly they would want to be adversarial on the supply chain side. How do you think about that when you kind of audit and think through your design of the overall system?
Which one was that for? Sorry.
For you.
For me. Yeah, I think it's a lot of techniques that you already use. Like, sometimes people buy parts from places that have a lot of fake parts. And then, you have to detect those already. Side channels are a little more difficult. But if you're buying, by and large, most of the parts on a piece of hardware, won't leak that much information or marginal information, like, for example, resistors and stuff like that. So you're really only talking about a couple of very critical parts. And I think that because of that, it might be cost effective to find solutions to doing this at scale.
And I guess maybe given that we're kind of running out of time, final couple of questions are: what are the applications you most want to see running in trusted hardware, and which ones are the ones that you view as your sort of, if I were building it to dog food?
I want the Ethereum machine, not the Ethereum virtual machine, because that's virtual. I just want hardware Ethereum contract execution.
Look at you! You're gonna take an Enigma. An old Enigma and shove a little machine underneath and be like,
I think what I'm really excited about is some of these applications that have actually been presented today. I was looking at ZK-P2P, it's things like ZK Venmo. I was looking at, Web 2 to Web 3 data bridging. These are all really, really compelling use cases for confidential compute as a whole, where you can actually, attract users from more traditional markets and really bring on new users to crypto and really introduce new ways of, improving UX into the crypto world. I think that's really important, for identity, for credit scores, for uncollateralized lending, risk models. All of these things actually depend on a large amount of confidential compute, and I'm really excited about that.
Cool. Well, with that, maybe a round of applause for our panelists. And I believe we have one more panel where 2 out of 3 people are still on this stage.
We need to add chairs.
Yeah, I think we need one more chair.
Who's next?
Thanks. Thanks. I have no clue if our remote participants are coming. I'm assuming no, so I do not. Ethan, we have All right, everyone. It's the last panel of day 2. Hopefully you had a good couple of days coming to Modular Summit.
Woo!
Exactly.
Modular Summit, yeah.
Let's
Oh yeah.
This is the third annual, I guess I have to call it annual now, Endgame panel at the Modular Summit.
The metagame is what
metagame. Sorry, metagame this time. But we've had this
the inaugural metagame.
This is the inaugural metagame, but oftentimes this panel has been about monolithic versus modular architectures in some shape or form. Unfortunately, this time we don't have Anatoly, so I will do my best to be a Solana edgelord if I can. But we'll see. You can grade me at the end on a scale of 1 to 10.
1 to Toly.
1 to Toly. There we go. 1 to Toly. That's good. I think the first thing that is probably worth talking about, is what are the top 3 events that have happened over the last 3 years in both the monolithic and modular ecosystems. I'll take the monolithic. I'll be the fake Anatoly. So for the 3 of you, kind of like what are some of the big highlights within the modular world that you've seen, and what are the kind of big things you think went well?
I mean, for me, it's got to be the rise of roll-up as a service providers, because if you think about it, it's kind of crazy. Because I mean, when I first created Celestia, my vision has always been like one day you'll be able to go on a website, and then you'll be able to click a button and launch your own blockchain that is completely secure and decentralized. And like this was before we had roll-up frameworks. And to me, it's kind of crazy that's actually possible today now, or has been possible for the last year. And there's actually like over 50 roll-ups deployed in this way. Like you can actually go to Caldera or Gelato or Conduit's website and like deploy your own blockchain in the form of a roll-up in like 1 minute just by clicking a button. To me, that's actually crazy.
All right.
Cool. Yeah. I guess there's been a few things over the last few years, and I don't know if we consider app chains, modular ecosystem, but I would. The original, incomplete modularity.
They're OG.
Yeah. OG modularity to be completed by, which has been completed by the Celestia vision. I mean, the 3 big things in my mind that sort of happened in the Cosmos ecosystem in the last 3 years. One was really the launch of IBC, which was concomitant with the launch of Osmosis. They kind of happened together pretty much 3 years ago, almost to the day, or a couple weeks. And that like really, kicked off the idea that the reality that you could have all these like independent things, modular pieces that could really interoperate with each other. So that was amazing. The second one's a bit sadder, and that was the Terra collapse, which was a very humbling moment, for all of us to get kind of wrecked like that and have, decentralized stablecoin just all of a sudden disappear. But it also demonstrated the fault tolerance element of the kind of modular stack, right? One piece kind of fails and goes away, but the other pieces kind of still work, right? And so, and that's a big part of what makes modularity so appealing. And then the third, I guess in my mind, is the Cosmos Hub's launch of interchain security, right? Initially with Neutron and Stride, 2 very exciting chains that launched with the Cosmos Hub. And now, focusing on ICS v2, interchain security v2, to allow more kinds of chains to launch, even rollups. Rollups are chains too. They can post data to Celestia and get a sequencer or validator set from the hub. And so the hub's becoming the best place to launch a chain. That's our mission for the hub. But it's still a close friend of rollups, and it's kind of an enabler. And so hub was kind of the first to do all this like restaking stuff, which is now kind of dominating. It's coming back.
I remember back in the day, there was like a one-click Bitcoin clone, so you could get like a clone of a whole Bitcoin. You could pick like your proof of work, and you'd get a proof of work clone that way. But I guess none of those work very well. I think that the ones that you get now with one click are actually viable, and that's pretty interesting.
I mean, the difference being that you don't have to bootstrap your own kind of consensus network and security. Like we also have Hyperledger. You can also do,
You really don't want to be the weakest proof of work coin. That's
exactly.
Bad recipe for disaster.
I mean, NiceHash was a great business.
Anything
you want to add?
Yeah, I don't know. I think so I've been spending a bunch of time with Flashbots recently. I think it's really interesting how you can have changes to you don't need to do everything through enshrining. I think doing things through sidecars is super interesting. Okay, but besides Flashbots, I like talking about puffer finance. I think that this is kind of underrated. It's pretty fascinating what they do. This is an application of trusted hardware, so it is related to that. It's been known for a long time that trusted hardware can change consensus protocols. Like you can upgrade a non-fault Byzantine fault-tolerant protocol into, you can upgrade a crash fault-tolerant protocol into a Byzantine fault-tolerant protocol just by adding the TE. It's like an anti-equivocation thing. But that's like, okay, if I'm going to build a consensus protocol, I could include this in it and have this kind of difference. But what Puffer does is really interesting. It doesn't require any change to the consensus protocol at all, but it's basically anti-slashing for delegated staking using trusted hardware. So if you're a delegated staking provider, your users have to worry that you're going to do something wrong and get their principal slashed. But if they can give you a guarantee, look, it's running in an enclave that can't possibly do anything slashable, that gives you a cool defense. That ended up being about trusted hardware, but really just sidecars was the point.
Look, we know you're the trusted hardware Trojan horse in every conversation. Don't worry. And I'm going to take a slight detour and ask the following very simple question, which is, what is your definition of an application? Because actually, 90% of this week, and this is a question that Tina came up with realistically, which is 90% of this week, everyone's talked about the difference between infrastructure and applications. But there's kind of this very blurry line, especially in the modular world, right? Where like if I'm launching my own chain, does that count as infrastructure? So what in your mind, what's like the definition of an application? And how do you kind of define the difference between the two? It sounds very simple, but I suspect everyone's gonna have a slightly different answer.
I guess for me, my general definition, maybe it's not a strict definition, but it's a product that a user who's not a developer would use, and specifically use it not just for investing in coins. Like I think that's what people generally mean when they say there's not enough applications and too much infrastructure, right? Like yeah, I mean if you think about it, crypto does have mainstream adoption, just not in the way we think. Like a big portion of the US does have a Coinbase account and they own a bunch of coins, but the application right now is owning a bunch of coins and to hold them for their value. But I guess when people talk about applications is not just for investments, but they actually use them for things like payments.
But does that mean crypto has adoption or Coinbase has adoption?
I mean, both, right? I mean, Coinbase, if Coinbase wasn't crypto, it wouldn't be being sued by the SEC right now, would it?
Fair enough. I think it really depends on what level, because anything that's an application at one level could be infrastructure at another, right? I mean, Celestia at some level is infrastructure, but it's also, you could think of it as an application built with the SDK or an application built on top of, general purpose computing in the first place. But otherwise, yeah, it seems like generally what maybe just beyond that, it seems like generally what people are talking about when they're talking about applications is like real world users doing not just financial things, which apparently there's no one doing here. Where are they?
Andrew?
Yeah, I think it's inherently relative. Every Twitter is a platform, and each tweet is an application that supports a like and repost feature. It's relative.
Okay. Well, I guess
but each tweet is a platform, right? You can stick an iframe in it.
Yeah, that's true. That's true. well, I guess like Farcaster one's a real platform. That one's a real platform.
Yeah.
All right. Well, I'm not sure if Tina got the answer she was hoping for. So initially, I wrote this question with Anatoly in mind, so I'm going to preface it with that, which is everyone on this panel has a different view of the role of advanced cryptography in blockchains. Ethan gave a very strong defense of his view about half an hour ago, whenever he gave his talk, in terms of uses of TEs, ZK, MPC, and FHE. Just as a summary, Celestia is adding ZK accounts, which allows you to have stronger covenants about DA without making your virtual machine a lot more complex. That's my summary. Solana is adding ZK compression, which is really just for light state diff and cheaper state updates realistically from the way they want to use it. Ethan has been working on TE-based systems for credit, and Andrew's been working on TE stack of flashbots. So
And TE-based systems for credit.
TE-based systems for credit, sorry. Also that. And the one question I kind of think about is like, are these uses of advanced cryptography sort of evolutionary advances? Like they're more about optimizing an existing system and making it more efficient and safe and et cetera? Or are they actually revolutionary in that they're enabling a new application? And if it is, then justify with some examples that you think are important.
I guess I can only talk about my respective use case, or Celestia's specific respective use case, which is ZK accounts. I think in the short term, it's evolutionary, but in the long term, it's revolutionary. Because in the short term, it's just it's pretty much just making Celestia have the same functionality that you could argue Ethereum already has, which is the ability to have a trust minimized bridge between the base layer and the rollup. But in the long term, it could be revolutionary because ZK accounts allow you to have bridges between the Celestia L1 and rollups in a much, much simpler way. Specifically, it was previously thought that in order to extend the functionality of a layer 1, you needed to add smart contracts to the chain, and that's what Vitalik argued. Like, he had a blog post where he argued that, because back in the day, like Bitcoin people were like, let's not add smart contracts. It makes the chain too complex, adds all these issues, and to some extent, they had a point, right? Because it does add a lot of complexity to layer 1 that creates problems like MEV and state bloat, that kind of, and various stack vectors. But it turns out that you don't need to add smart contracts to extend the functionality of a layer 1 or to achieve what's called functional escape velocity. For the layer 1, turns out that you can just have you can actually have a on-chain account, like any normal account, but instead of that account being controlled by a public key, it can be controlled by a ZK program represented by a ZK verification key. And that allows you to achieve, in theory, complete functional escape velocity that gives you all the benefits of a smart contract platform without having any on-chain smart contracts. And I think in the long term, that could be revolutionary in the long run, because it avoids layer 1 from having all kinds of existential issues, such as MEV, which leads to block producers being centralized. And so you basically completely sidestep all of these issues entirely while having the benefits of functional escape velocity.
I guess in my case, I think Cycles is a revolutionary application. Of course, I'm going to talk about Cycles. But I do think in general, I mean, I agree with that point that the cryptography, ZK and others they're both evolutionary and potentially revolutionary in the long run. I mean, arguably the technology, the coordination technology we're building here in general is supposed to be revolutionary, but it requires some additional pieces to actually get there, it seems, and cryptography is required to fill that in. But we also think TEs are sort of part of that story. With Cycles, we want to build something that allows anyone, anywhere in the world to participate in clearing debt and to clear the most debt for the most people with the least amount of money. And that's revolutionary in the sense that it could like fundamentally change the structure of the financial system, which is primarily based around excluding all of you from being able to do clearing and allowing only the banks to get together and do clearing in their clearing houses. And it's not really feasible or possible to bring, the 200 million businesses or 6 billion, 7 billion people into a common clearinghouse. There's just too much complexity of financial contracts and overhead and counterparty risk and all this kind of stuff. And Cycles' design makes unique, it takes unique advantage of the properties of blockchains, atomic multilateral execution. It requires privacy, which today we can only really do meaningfully with this technology, whether it's a TE or in the future MPC plus FHE or whatever. It unlocks this kind of revolutionary use case that we can't otherwise do without it, right? People are always talking about, can't you do this without a blockchain? Is it just more secure, more open, verifiable? We can't actually do this without a blockchain, because you can't do atomic multilateral settlement pretty much without one, unless you're just like willing to trust tons of intermediaries. And so I think this stuff can be very revolutionary.
I'd say it's definitely revolutionary. It's hard to give a good example of something that no one would do without cryptography, because the limit of what you can do with cryptography is what you can do with a trusted third party, and people are often really trusting. They're willing to, share private keys with services to act as, custodians. But I do think that there are examples where actually people won't even trust people for it. I think Shin's demo is really cool because going through that forgot password flow, like that's what it looks like when you're falling for a scam. You're like giving someone your forgot password flow. And even besides the TEs, like just with TLS Notary, I don't think we've even yet scratched the surface of surprising things you can do with that because, yeah, obviously you log into your bank. Well, you aren't sharing that session with like a backup drive. You're certainly not sharing it with other friends and family, but you can now create notarized encrypted logs of the transcripts that you've had with secure sessions with Web 2 apps. I think that's tremendously powerful, and I don't think we've yet seen all of the surprising things you can do with that.
Cool. So, now that we've talked about advanced cryptography, we've also talked about applications. One of I think starting with the app chain version of the world, one of the promised futures of the promised land was the migration away from the fat protocol thesis to the fat application thesis, where like each chain would be its own sovereign nation, generate a bunch of user flow, generate a bunch of application volume flow. But if I look at the fat application thesis in 2024, the modular ecosystem didn't accrue the actual value from it, right? Like the monolithic world actually owns the #1 consumer applications in crypto right now, which are meme coins. And if you think about things like, one kind of thing about the fat application thesis was you run your own chain, you get all these fees, and those fees could be much more than the base chain if it was a roll-up or other chain, kind of hub chains. But arguably the first network to really have an application earn more in fees per day repeatedly, consistently, than the base protocol was Solana with Pump.Fun, or continues to be nowadays. So what do we kind of diagnose as the reasons for this, and where do we think the modular world goes from here to try to regain its superiority in the fat application thesis world?
Well, for one, if I were Tolly, I would say Solana is a Cosmos chain, which he has said. And on a scale of 1 to Tolly, that's Tolly. And the idea behind that is that it's a chain focused on a particular outcome, trying to optimize for being the fastest synchronous composable platform in the world. And it seems like they're achieving that, and they're proving out the use case of that. In Cosmos we have Atom, which some have suggested is a meme coin for academics. I think that's you, right?
Yeah, definitely meme coin for nerds.
Which is was true in the past. Maybe it's less true now. Now we're a serious platform for launching blockchains. That's the Cosmos Hub. We also, Cosmos does have a meme coin chain called Chihuahua. I don't think this has been a success.
Just from the fact that look at the audience reaction to that already says that.
Wawa. Yeah, it's not. It doesn't seem to be working. But
I think Bad Kids might be more successful than Chihuahua. To be honest,
definitely. Yeah, it's challenging to really understand. I think we're still early. We're only a few years into like application-based chains, and they are expensive and a big part of like the roll-up roadmap and Celestia's modular thesis, so that we can bring down the cost significantly. And so maybe once we start to see a lot of roll-ups, we'll start to see the way that they accrue value. It'll be they have to build useful apps. Right now, it seems primarily what people want to do is they just want to gamble on like a fast synchronous platform. And so Solana as app-specific chain for doing that, might just win that.
So you're saying Solana is going to be Pump.Fun chain soon?
It kind of is.
Is that what you're thinking? Okay, just make sure I have that one recorded.
I did not say that.
That is sort of the right. Yeah. That is sort of the fat application thesis, though, right? Like the application generating the fees takes over the chain. Yeah. Okay, Mustafa.
I love meme coins, but I guess like
what's your favorite meme coin? First,
my favorite meme coin right now, Pepe. Just because I think it's the Pepe that is most likely to actually succeed the most recent the meme coin that's the most recent meme coin that's likely to succeed, because I don't like meme coins for the casino aspect of it. For me, I like meme coin for like a very mid curve take, or potentially low IQ or even high IQ take, which is that why should
high IQ meme coin takes? I'm ready for it.
Yeah, which is that like to me, I mean, like since we got off the gold standard in 1971, like why should only nation states compete in the meme coinery, you know? Like so, but for me, I don't like the casino aspect of meme coins. I want to see like sustainable meme coins, you know, like Dogecoin. That's a meme coin that has existed for many years, you know, and I think that's Pepe has a chance of doing that. But a lot of the Solana meme coins, as you said, has kind of been mostly motivated by like a casino style thing, or like casino style activities, and that's not what I'm interested in. Like I haven't been in the crypto space, you know, since 2011 to build a massive speculative casino, you know.
My favorite meme coin is still CryptoKitties because it has a Dutch auction.
Okay, nice. All right. Do you have any view on how modularity takes our? I'm waiting for the TE shill. That's really that's what we're here for.
I don't really have many like upchain thoughts in this, you know, fat app versus platform. What I would say is that I want to see more choice to users and more fine-grained choices, like as close down to the edge as possible. So I like the idea of small apps having more control and optionality, including being able to like migrate with all the users intact to other platforms altogether. So I don't know whether that's a feasible direction, but that's what I hope for.
Cool. As we talk about the rise of, I guess, the applications in Solana, one interesting thing is that the modular world, I would say, has been, I wouldn't say isolated, but certainly shielded in a lot of ways from MEV in a way that Ethereum, base Ethereum, and Solana have not. You know, I think Solana MEV fees have touched $100 million a day in some days. So it's like it's one of the wildest markets. A lot. I mean, the Solana MEV market is honestly crazier than the Ethereum one nowadays. So what do you think the modular world can do to kind of take its advantage, where it is actually somewhat more, quite a bit more complex for MEV extraction to take place? Not that it won't happen, it's just that I think there's many more steps you have to jump through. And how do you build applications that, you know, take advantage of that? You know, I think we saw a bunch of talks today that talked about that. I think Evan, I don't know where Evan is, but Evan used a picture of Max Resnick as a way to emphasize one of these. So yeah, where do you kind of view this kind of advantage that expanding over time, and which applications take advantage of it the most?
Yeah, I mean, I think applications are going to want to capture their own MEV and not dedicate to the base layer. And yeah, it is early in terms of roll-ups having the tooling to capture that MEV, but we are seeing some early products that allow that. For example, Skip is doing some good work there. They have like a Cosmos module that allows you to embed a sort of like private mempool that allows you to capture MEV. So I think in the future, when these tools become more and more mature, like deploying a DEX directly on chain or on the L1 will become insane, especially as the barriers between these chains become more and more abstracted, such that liquidity is not going to be fragmented anymore as chains. Having a DEX or deploying it, there will simply be no incentive to deploy a DEX on an L1 that leaks MEV to the L1. And so I think like in some way, like we're very similar mindset to Solana in the sense that I believe that all of the value, most of the value should accrue to the application and not the base layer. But we kind of differ from Solana in the sense that we think that the order book or the trade does not need to be on a massive synchronous ledger on the L1. It can happen on an L2, and therefore the order flow can be captured by MEV on the L2, and we can still and that doesn't necessarily have to be fragmented if we have good abstraction across the chains.
Yeah, I gave a talk earlier today called Defund the Dealers, sort of about how we can work towards changing market
macrostructure and microstructure to essentially reduce how much can be extracted from users by moving from a model of liquidity providing to liquidity saving. And a big part of that just involves incorporating privacy and batching into the regular execution environments. And so long as that stuff is not there, there's going to be tons of MEV leaked. And I think, or I expect, that we'll see a lot more development and adoption of those kinds of technologies, maybe starting in Cosmos and Celestia rollups and so on, and then moving into of course, Flashbots is already trying to do this kind of stuff. But I think Penumbra just launched like a week ago or 2 weeks ago, and based around this kind of idea that we can reduce how much we leak using privacy and using batching. And so I think there's like a lot of unexplored design space around that I'm hoping we'll see more people develop on.
Andrew?
Yeah, I agree. Privacy and batching are the keys, I think.
Cool. All right, so we got 1.5 minutes left, so I'll kind of go into...
Aren't you supposed to answer a question at some point?
Wait.
Ask him one.
What? Yeah, ask me one.
Shamtoli.
Shamtoli? Okay. You want me to ask myself a question and look like an idiot? All right, let's figure out which question is best suited for this.
Pass it to Andrew. Let him ask whatever one he wants from there.
Down.
Number 10.
All right. So this question is for Anatoly. Will Solana have
Hello,
a
I am
modular?
Anatoly.
Yeah. Will Solana have a modular ecosystem given the recent interest in restaking on Solana?
I think Solana will have some form of rollups at some point. I think there's actually been a big shift for applications there to kind of control a lot more, especially in light of the high MEV lately, and the fact that like certain applications have been crowding out other noisy neighbor problem type of stuff. I think the other thing is, the restaking stuff in Solana actually seems to be kind of an interesting gambit, because like initially it seems like, okay, well, what are the real applications, right? And ETH people want pre-confs and all this stuff that's, well, okay, Solana sort of already has in some ways, like at lower latency, but I think there's starting to be some interesting things, and we'll see some weird applications in next year.
Great answer.
And my fake toliness ends with the final question to Mustafa, which is, if that happens, do we do another modular versus monolithic panel, or is it all over?
You mean if Solana becomes totally modular?
Yeah.
I mean, this is blockchain. Like there's always tribes, so even if everyone's modular, there's going to be like a Catholic version of modular.
Catholic modular. We talked about religion in the last panel, about like praying to the destructive chips, and now we're having the Catholic modular chain. You heard it here first. Everyone dressed as a nun for Halloween. All right. Thanks, everyone. You were the real fake Tolly. Yeah, exactly. Yeah.